Hey, if you thought time travel wasn't possible for you, well, think again. On today's What If Marathon, we're going to take you on a journey back to the beginning of time. We're covering everything from the Big Bang to human evolution, so stick around for the next few billion years or so as we reshape the history of humankind. But before we start, I got a bit of a trivia question for you. When did the Big Bang happen? Was it A, 12 billion years ago, B, 14 billion years ago, or C, 16 billion years ago? Well, strap into the time machine and hang on because we're sending you back to the Big Bang right now. In the beginning, there was nothing. Well, except for you and the Big Bang. What would the first moments of the universe be like? What would happen over the next thousands of years? And would anyone believe you? This is What If, and here's what would happen if you were alive during the Big Bang.
Who wants the last dumpling?
The Big Bang Theory. No, not the TV show. I'm talking about the most popular story about the earliest moments in the history of the universe. According to this theory, the universe emerged from a single point nearly 14 billion years ago. This point, known as a singularity, would have been infinitely dense. From this singularity, the entire universe expanded, eventually cooling down enough to form stars, galaxies, and planets like the one you are on now. And our universe is still expanding today. That's one of the most compelling pieces of evidence supporting the Big Bang Theory. So let's travel back to a time where it all began. Set your coordinates to 13.82 billion years ago. Time to take your shiny new time machine on an epic spin into the past. What you'd find when you arrived would be, well, nothing. You and everything you've ever known no longer exist. But by some miracle of your time machine/spaceship, you'd arrive at the exact moment of the Big Bang. Before this moment, all the particles that make up the universe were crammed so tightly that not one atom could even form. In this state, the density was infinitely higher than the matter in our current universe. Right after the Big Bang occurred, this matter existed in the form of quark-gluon plasma, or QGP. Very quickly, in a matter of milliseconds, the particles making up this QGP would clump together to form the protons and neutrons that make up the atoms we know today. According to astrophysicist Paul Sutter, at this point, everything was crushed into a ball about the size of a peach. This ball would have been very hot. How hot? Well, only like a trillion Kelvin. That's like 999 billion degrees Celsius. And I wouldn't blink if I were you, because if you did, you'd miss the universe rapidly inflating from the size of a basketball to roughly the size of the sun. Particles would be flying through the QGP at velocities higher than the speed of sound. Like a jet traveling at Mach speed, these particles would emit a supersonic boom. Of course, you wouldn't hear anything. Sound can't travel through the vacuum of space. Not to mention, you'd be witnessing a time before any matter has formed. And sorry to say, you'd barely be able to see anything either. Everything would look foggy and blurry. The super dense plasma would scatter light, similar to water droplets in clouds. 1 microsecond after the Big Bang, you'd see neutrinos, quarks, and electrons form. Shortly after that, you'd see protons and neutrons forming. This would all be happening within 1 second. At this point, the temperature of everything would have dropped to a chilly 5.5 billion degrees Celsius. And after about 3 minutes, things would have cooled down enough for these protons and neutrons to form hydrogen nuclei. You'd now be witnessing the era of nucleosynthesis. But don't get ahead of yourself. You wouldn't see the first elements form for another 380,000 years. All those years later, the universe has finally expanded and cooled enough for electrons to stay in orbit around an atomic nuclei. The first hydrogen and helium atoms would form. You'd finally be able to see things more clearly, too. Okay, now you've reached the point in our creation timeline that scientists have some evidence of today. Cosmic microwave background radiation, or CMB, is leftover radiation from about 400,000 years after the Big Bang. These microwaves are invisible to the naked eye, but they reveal that there was a time when the universe was both hotter and denser. More proof that scientists point to in favor of this history of the universe is the speed that galaxies appear to be moving away from us faster than those closer to us. This would suggest that there was a time when all galaxies were in the same spot. Yeah, the singularity. Of course, you would have witnessed all this firsthand, but without bringing back any definitive proof, the Big Bang would still remain a theoretical model of the history of the universe. There would still be so many unanswered questions, and even if it was all true, would that really have been the beginning of everything? Stars are gigantic balls of fire holding planets, asteroids, and meteorites in their firm gravitational grip. And their fire sends light into the farthest reaches of their galaxies. But how did they get here? I mean, these incredible orbs must have come from somewhere, right? What would it be like to witness this epic birth? What would it feel like at the center of the action? And why would this beautiful event have a funny smell? This is What If, and here's what would happen if you saw a star being born. The Milky Way galaxy spans about 100,000 light years across, and it contains somewhere around 200 billion stars. If there are that many stars in our little section of space real estate, imagine how many there are in the entire universe. Now, depending on where you look in the night sky, you could see around 5,000 stars just with your naked eye. The brightest ones have melodic names like Polaris, Alpha Centauri, and Betelgeuse. Looking further out into the universe with the help of telescopes, there are simply too many stars to name.
That's the North Star. Well, what is that?
That's why many of these are now identified more generically, like WASP 50, HD 28678, and HAT P23. But today, you're not just going to look into a telescope and name some baby stars. You're going to be in the thick of it. The hot, dense thick of it. Every year, 7 new stars are born in the Milky Way alone. Now, that might not sound like a whole lot, but keep in mind that our galaxy has already used up 90% of its star-making material over the billions of years of its existence. And yet, new stars are still being born all the time. Now, To witness their birth, you need to travel to one of the many star nurseries in the universe. These are known as nebulas. Nebulas are huge clouds of gas and dust that can span light years across. So, hop into your interstellar spacecraft and set your coordinates for one of the most famous stellar nurseries of our galaxy, a mere 1,344 light years away, the Orion Nebula. Yeah, it's here that you'd find the necessary ingredients for a star to be born: gas, dust, gravity, and turbulence. Sounds like my car. Being in the middle of a nebula would feel like being in the clouds. You'd be surrounded by over 200 different kinds of molecules. There would be hydrogen and helium gas, as well as microscopic grains of silicon and iron. And I hope you packed some warm clothes because conditions in this cloud would be frigid. You'd need a spacesuit thick enough to withstand temperatures as low as minus 270 degrees Celsius. But don't worry, things are about to heat up. Suddenly, you'd be hit by a blast. This would be a ripple effect from an exploding nearby star, and it would cause the nebula to become turbulent. All it means is that the gases around you would start to mix and swirl together. It would be the beginning of the epic event you're here for. First, dust particles would begin to clump together. These clumps would become denser and denser, forming knots. Once these knots gain enough mass, they'd start to collapse under their own gravity, and their internal pressure and temperature would increase. Yeah, at around 2,200 degrees Celsius, these high-pressure knots would emit a dull red glow. You wouldn't be able to see it because that light would be infrared. Oh, but you would be uncomfortably aware of the temperatures starting to rise. And things would keep heating up. Eventually, the protostar before your eyes would emit its first rays of visible light. Wait, do you smell that? Well, no, of course you don't. You're wearing a heat-resistant spacesuit, but if you could, you'd learn that this hot mass of dust and gas would also smell.
It's disgusting.
But not necessarily in a bad way. Depending on the mixture of compounds around you, you could detect hints of sweetness, lemon, or even alcohol. But be careful, your baby star wouldn't only be pulling things inward. Every now and then, it would shoot powerful jets from its poles at supersonic speeds. These would flash brightly as they come into contact with the surrounding gases. All the while, the protostar would simultaneously grow and collapse under its own weight. This would make the core continue to heat up. Yeah, once it reached the scorching hot temperature of 5 million degrees Celsius, you'd witness your baby star's first nuclear fusion. Deep within the center of the star, 4 hydrogen atoms would fuse together to form helium. This would release a ton of energy. And with all that energy, the protostar's pulsations would come to a halt. It would finally become a star. Now, during the excitement of witnessing a star being born, you'd have seriously lost track of the time. If the star that formed in front of your eyes was similar to our sun, well, you'd have just watched 50 million years fly right by you. And you might want to get your hearing checked after experiencing all this. Of course, there's no sound in the vacuum of space, we all know that, but in the stellar nursery filled with gas and dust, sound waves may have a medium to travel through. And if you were wondering what the birth of a star sounds like, well, it would be deafening. If we could hear our own sun, it would be a lot like Earth was covered in constantly wailing sirens, except multiplied by 10,000. A new star created by a series of violent contractions of superheated gas? Ugh, forget about it. Okay, now that your baby star is all stabilized, it could burn bright for another 10 billion years. Okay, going back to our trivia question, if you said the Big Bang happened 14 billion years ago, well, you're correct. I mean, technically it was 13.8 billion years ago, but let's round up. Are we really going to nitpick over a lousy 200 million years in the grand scheme of things? Now, I hope all this time travel isn't making you dizzy. Honestly, you should be grateful. They never send me on these cool trips. I'm always just watching from above and narrating everything. You know, there was a time when fancy trips and overseas travel wasn't a thing. That's because we used to be one giant landmass. That's right, at one point in history, we were all neighbors. Well, kinda. All the continents used to be connected, so you didn't necessarily need to spend days traveling from one point of Earth to another. You know what? I'm choosing your next mission. You're gonna go back in time and make sure Pangaea doesn't fall apart. What could go wrong? I'm sure all the new neighboring continents will get along just fine. Or will they?
Millions of years ago, the Earth looked very different. A huge landmass called Pangaea covered about a third of our planet. But about 175 million years ago, the Earth broke up into continents and formed the world we know today. What if that had never happened? Where would your country be located? And how different would your life be? This is What If, and here's what would happen if Pangaea had never broken apart. If Pangaea existed today, in theory, you could drive from California to England, since they'd both be part of the same landmass. And although you may only think of Pangaea as just another piece of land, it would be much more than that. It's played an integral part in human and animal evolution. If Pangaea had not broken apart, you may not be here today. But let's assume it didn't, and that we survived and evolved to be the people we are today. What would the Earth be like? First, let's talk about where your country would be located. North America would be right here. Europe would be a lot closer, just to the east. Asia would be up north by Russia, and Antarctica would remain down south. India and Australia would be further south, connected to Antarctica. These countries that used to have hot climates would now be cold, covered with snow and ice. And those wouldn't be the only environmental changes. Regions in the middle of Pangaea would have lush rainforests along their borders. And as you travel further inland, it would become a desert. This would be due to Pangaea's landmass being so large. Rain, which comes from the ocean, wouldn't be able to travel far enough inland, leaving parts of Pangaea practically uninhabitable by humans and other species. And weather up north would be different too, with Russia being much warmer than it is today. But the weather wouldn't be the only thing that would change. On Pangaea, we might have less diversity of species. The species at the top of the food chain today would most likely remain there, but some of today's animals would not exist in Pangaea. They wouldn't have the chance to evolve. Fewer animals might make it easier to travel, and on this modern version of Pangaea, you'd probably want to do a lot of it. Luckily, you wouldn't have to go far. If you lived in Florida, you'd be right next to the Caribbean islands, Venezuela, and Brazil. You could visit all of these in a single day. And if you lived in Nova Scotia, Canada, you'd be driving distance from France, England, and Germany. Although this might sound like fun, a lot of countries would have new neighbors, which could cause some serious issues for some. Places like the United States, which used to have oceans on both sides of the country, would now have Africa on its east coast. If these countries didn't get along, things could get ugly. How much easier would it be to start a war in another country if they were just a short drive away? Transporting weapons, people, and supplies would all be faster and cheaper if certain countries were right next to each other. Or none of this would happen and the entire world would be more unified than ever. With all of us sharing the same landmass, maybe we'd learn to treat each other just a bit better than what we do now.
Okay, power up the What If Time Machine because today you're traveling back to witness the most radical changes ever known in Earth's history. You'll watch our planet give birth to strange new animals and see continents taking shape. We're going to the time that defines our existence, the Paleozoic era. But how would your body react to the new climate? What kind of creatures would you eat? And how hot would the planet get? This is What If, and here's what would happen if you lived in the Paleozoic era. The Paleozoic era began 530 million years ago when the Earth woke up from an ice age. The era lasted for 289 million years, but you might not even last 5 minutes in this climate. But hey, if you're as resilient as the life in these waters, you just might stay alive. In these oceans, life has the perfect space to begin. And like all great things, it started small. Good luck trying to find a meal. 543 million years ago, all life on Earth lived below a thick layer of mud on the sea floor. But don't get out your lobster bib yet. The only things you'll find here are microbes. Ooh, so chewy. Your menu won't be getting any bigger for a few million years until the Cambrian explosion, the big event that would kickstart life on Earth. The cyanobacteria would pump more oxygen into the atmosphere, making it easier for you to breathe. So take a deep breath and enjoy life on this doomed continent. During the Ordovician period, 485 million years ago, you would watch North America and Europe merge to become the supercontinent known as Gondwana. Now, grab your parka because as this landmass moves over the South Pole, a massive ice age would spread across the globe. Under the water, jawless fish would roam the sea, dominating the ocean. Algae and sponges would begin living on coral reefs, and back on land, the first plants would take root. But 80% of the life in shallow seas would die as sea levels plummet when the new ice age begins. Starting about 444 million years ago, you would see the glaciers melt. This event would create a climate similar to what we have now. The ocean would be full of sea scorpions, the size of dogs. So look out, these opportunistic predators may confuse you with dinner. In the Devonian period, 3 continents blanketed the planet. 419 million years ago, much of Earth's landmass remained underwater. You would need to live near the shoreline to harvest the resources you need to stay alive. Since trees would be covering the world for the first time, you could build shelter and even start a fire. And with the soil rich in nutrients, you could begin to farm plants. But while you would rule the land as an apex predator, the ocean would belong to the early sharks, and they look hungry. Travel back 358 million years ago, and you would see life near the equator would thrive while the rest of the world would experience deadly temperature changes. The first reptiles would start appearing. Look out for that ophiuchodon. They can grow almost 3 meters tall. Even dragonflies can have wingspans of 75 centimeters. Well, one of those could feed you for a while. Okay, all the changes we saw have led to this event, the Permian period. About 299 million years ago, almost every landmass on Earth had merged into the supercontinent known as Pangaea. This massive land stretched from pole to pole, with vast deserts in the center. The wild temperature changes would kill amphibians, but don't worry, you wouldn't be alone here. The Archaeops would tower over you, standing 2 meters tall. This lizard-like creature devoured its prey whole. If you keep out of its way, you might enjoy the new oxygen levels, thanks to more trees sprouting up everywhere. But you would see a violent end to this period. Whether it's meteors, exploding volcanoes, or methane clouds, 96% of all life on Earth would die out. The highest extinction rate ever known. Now, if you made it through, get back in the time machine. You know, when I was a kid, I was never really interested in having a pet dog or cat like the other kids, not even a goldfish. No, I was dreaming of a pet pterodactyl. You know, those huge prehistoric bird dinosaurs with huge beaks and blood-curdling screams. Yeah, imagine flying through your city on one of these. I was kind of a weird kid. But today, we might be making my dream a reality because we're going to find out what would happen if the dinosaurs never went extinct. Did you know that scientists have found dinosaur DNA in our water? So, in a way, they're still with us. Before this next episode, grab yourself a nice cold cup of dino DNA and we'll talk about why they went extinct and how we could have lived in a reality where we coexisted with them.
How cool would it be to see a real-life T-Rex? If only that one fatal asteroid never hit the Earth. Would dinosaurs still be alive today? Would they have evolved? Would humans have survived this long? Could we ever learn to coexist? This is What If, and here's what would happen if dinosaurs never went extinct. Until 66 million years ago, dinosaurs of all shapes and sizes roamed the Earth. Intelligent, adaptable, and sometimes weighing as much as 2 jet planes, it's hard to believe that it only took one rock to wipe them all out. Of course, this was no ordinary rock. The asteroid that took out the dinosaurs was 9 miles wide and hit Earth with the destructive force of 10 billion Hiroshima bombs. The radioactive shockwave obliterated everything for hundreds of miles in every direction, and 75% of all species on Earth went extinct. If that asteroid had hit just a little earlier, a little later, or even a few miles off course, we would be living in a very different world today. The rock that killed the dinosaurs struck the shallow waters of Mexico's Yucatan Peninsula. Had it landed a little farther off the coast, in a deeper part of the ocean, the water might have absorbed some of the blast, along with its devastating effects on the atmosphere. But even if the asteroid missed the Earth, dinosaurs would have to survive several significant global events in order to make it to the present day. 55 million years ago, temperatures rose. The climate was 8 degrees hotter than it is today. Rainforests sprouted, and vegetation flourished. Herbivores would have adapted and thrived, but they'd have started to look a little different. The plants of this period were less nutritious and easier to digest, meaning dinosaurs would likely shrink in size, since their new diet wouldn't have as much energy. Roughly 20 million years after that, South America and Antarctica split, creating a cooler and drier world climate. During this period, long-legged, fast-moving dinosaurs would have evolved to travel the huge grasslands stretching out across the globe. Compared to mammals of this period, dinosaurs held significant advantages, such as having more teeth and better eyesight. Considering the dinosaurs were already so advanced, scientists wonder whether mammals would have evolved at all if dinosaurs hadn't gone extinct. It's likely that the big animals we know today would have been prey to dinosaurs. But remember, humans evolved alongside woolly mammoths and saber-toothed cats. While those species didn't survive the ice ages of 2.6 million years ago, given the evolutionary traits of some dinosaurs, there's a chance they might have persisted. But what about us? Could we handle freezing temperatures and huge, terrifyingly vicious predators? They say running keeps the body warm, but that might also make you taste better. In an alternate universe, if we did survive alongside these prehistoric beasts, it's possible we could see a real live T-Rex on a protected reserve, not unlike Jurassic Park. Human population growth and excessive hunting would have driven larger dinosaurs to near extinction. Today, they would most certainly be an endangered species, but those that shrank and adapted over millions of years could coexist peacefully among us. In fact, some actually do. Where do you think pigeons came from? It's hard to believe that birds were once the size of biplanes, but then again, it's hard to believe that with a slight twist of fate, we might have walked with dinosaurs. Or we might have become dinosaur chow and not have evolved at all.
What was life like in the Cenozoic era? Welcome to one of the most formative and terrifying time periods ever, the Cenozoic era. You'll find giant creatures like woolly mammoths and megalodons roaming the seas, along with some other creatures you might be a little bit more familiar with, but more on that later. Let's strap in and travel back in time to the Cenozoic era. How would you survive during this period? Why was Earth so dangerous? And how is this era similar to modern day? This is What If, and here's what would happen if you traveled to the Cenozoic era. Okay, you're now 66 million years in the past. You just missed the age of dinosaurs by a couple of million years. They were wiped out by a giant asteroid and are now extinct. But that doesn't mean that other life hasn't found a way. The death of the dinos made way for new creatures to emerge. Mammals. Yeah, the early Cenozoic period saw the rise of primitive mammals that would begin to diversify into different evolutionary niches. Let's explore and check them out. One of the most famous mammals during this time was the megafauna. These were giant creatures that roamed the earth. A lot of these probably look familiar. Go to the colder regions of the earth and you'll find packs of woolly mammoths roaming about. These guys were nearly 3.5 meters tall and weighed up to 8 tons. Okay, go over to what's now known as Australia and you'll see the Diprotodon. This is the biggest marsupial that ever lived and looks like a giant wombat. And it wasn't just the mammals that were giant. Watch out in the water because you'll be met with one of the most terrifying creatures ever, the megalodon. This giant shark dominated the oceans with teeth as big as 18 centimeters and a body as long as 20 meters. I could go on, but we have so much more to explore. Let's check out a couple of other creatures and then I'm going to show you something really cool. The Cenozoic era also had the Glyptodon, which was like a giant armadillo, the Megatherium, a giant sloth and one of the largest of the mammals, and the Elasmotherium, also known as the Siberian unicorn. It was basically a woolly version of a rhinoceros. And there were a bunch more creatures. But why were they all so big? Well, researchers have several different theories as to why these creatures became so massive. One of the leading ones is that with the dinosaurs gone, these mammals could thrive in open habitats, helping them grow larger and larger as generations progressed. But there's another incredibly important mammal I haven't mentioned yet, and although it's not a giant, it is one of the most important. And that's you. Well, sort of. Humans' early ancestors were primates. With the death of the dinosaurs, the rise of primates became possible, allowing them to evolve. Early primates were small and weak creatures when the Cenozoic era started, but they had two key features to help them become dominant: grasping fingers and forward-facing eyes. Over millions of years, they survived and later thrived on Earth. This led to primates diversifying and the emergence of different species, which then gave us two main groups: the primates, who would later evolve into monkeys and apes, and the hominids, who would later evolve into humans. But this wouldn't happen for millions of years. As the Cenozoic era progressed, hominids learned how to use tools, control fire, and develop the beginnings of early language. As more and more hominids appeared, they spread globally and could be found in Asia, Europe, Africa, and North America. Some of these species died out, specifically the Neanderthal. They evolved outside of Africa and adapted to live life in Eurasia, but as modern humans progressed, they were more technologically advanced, eventually leading to the extinction of the Neanderthal. As more and more species of hominids evolved, more and more died out. The only ones to survive were the Homo sapiens, who stayed in Africa. Their brains continued to grow, leading to more advanced language, technology, culture, and eventually you. Speaking of you, how would you survive in this era? Well, to do that, it'd be helpful to know what the Cenozoic era was made up of. After all, it spanned tens of millions of years and a lot of stuff happened. The Cenozoic era is divided into three time periods: Paleogene, Neogene, and the Quaternary period. Let's quickly break them down. Paleogene period. This marked the start of the Cenozoic era. The mammals we've been talking about, along with flowering plants, have begun to emerge. Oh, and watch out for some creepy-looking insects. Earth's tectonic plates continued to shape continents, as they have been for many millions of years. South America and Africa would continue to move apart, and the Himalayas would begin to form. You'd notice a generally warm and comfortable climate, but that would start to change as you move into the next era. Neogene period. Okay, the hominids we've been talking about have now appeared, and more modern plants and animals have begun to evolve. One of the main things you'll notice is how much colder it's getting. Ice ages are becoming more common during this period. Quaternary period. This period had multiple ice ages and interglacial moments. The Earth cooled down and heated up several times. Humans, along with the large mammals we mentioned earlier, had more impact than ever before. This period is also known as the Anthropocene, which recognizes the significant impact humans had on the Earth's ecosystem and geology. So, how would you survive during these times? Well, it would be much easier than if you were to live in a time period even further away. Hundreds of millions of years ago, Earth had more oxygen, which would make breathing more difficult. But luckily, you don't need to worry about that. You just have to be wary of the giant animals trying to kill you, the unpredictable weather, and the weird kinds of foods that could make you sick. Sounds easy, right? Hopefully, you'll be able to cozy up with some early hominids and join their tribe. They'll have access to shelter, fire, and tools. And if you can't manage to do that, well, find a cave, make a fire, and hope for the best. But wait, you're technically surviving in the Cenozoic era right now. Yeah, that's right. This era hasn't ended yet. We're currently living in the Quaternary period. Eras on Earth are typically marked by major geological shifts or mass extinctions, neither of which we've had to deal with, luckily. Folks, are you like me? Have you ever looked at a chimpanzee and thought to yourself, are we absolutely sure humans came from them? Well, human evolution is a little bit more complicated than that, so you have the right to be confused about it. One of the many things that make humans so special is our consciousness, our awareness of life and existence, and expenses and the future. Have you been planning for the future? Have you set aside any money for your retirement? It's never too late to start thinking about it. Philosophers debate how we could possibly have such self-awareness if we evolved from the same animals we see in the wild. Some credit the start of human consciousness to a certain drug. Keep watching to find out which drug they're talking about, if all humans are related, and where we drew the line between apes and being human. Asteroids, volcanoes, a lack of oxygen. These were just some of the ways that life was almost snuffed out on our planet. But against all odds, humans have managed to survive. So how did we go from tiny molecules to taking over the entire world? Well, we'll take you on a journey through time that explores the evolution of humans in 20 minutes. Who the heck is Luca? Is it evolution's fault that we're all wearing braces? And wait a minute, do we all really have the same great-great-great-grandmother? 4.5 billion years ago. 4.5 billion years ago, something absolutely mind-blowing happened. And I'm not talking about the Big Bang. Believe it or not, this second act might be even wilder. I'm talking about abiogenesis, the beginning of life from non-life. Imagine a soup of ammonia, methane, and hydrogen in a hot broth of water. This could be cooking in a volcanic vent deep in the ocean. Instead of curry powder, Mother Earth probably added some sulfur, nickel, and iron to the broth. Molten rock underneath then heated things up. Over millions of years, these molecules clashed together to form chains of amino acids like lysine, lactic acid, and urea. These may have been the building blocks of life. In the end, some of these chains started replicating, and voila! Molecules became replicating cells. We now have life on Earth. Okay, it's probably not that simple, but this was roughly how the very first single-celled organism came to be. Probably in a deep-sea hydrothermal vent. Meet Luca, the last universal common ancestor. Humans, animals, fungi, not-so-fun guys, trees, we can all trace our existence back to this critter. One of the countless differences between modern humans and our friend Luca here is that he was not self-conscious. And while we may have tons of information on how we developed our big brains and started walking on 2 feet, our leap to self-consciousness is still a little mysterious. Let's take a moment to explore this a bit further because there's some pretty wild ideas out there. Some philosophers have even proposed that the key that unlocked our self-consciousness was psychedelic mushrooms. Yeah, the theory goes that our ability to use language, reflect on ourselves, and perform other unique human brain functions might all stem from ancient ancestors who consumed psilocybin mushrooms. These psychedelics are known to de-pattern the brain, alter modes of perception, and encourage social bonding, which could be the perfect ingredients for the emergence of human consciousness. And if you're doubting the power of these little mushrooms, all you need to do is look how they're being used today. One biopharmaceutical company called Cybin is using them to solve one of humanity's biggest problems: depression. Depression is a chronic illness that affects 280 million people worldwide, and it costs the global economy $1 trillion each year in lost productivity. Cybin is developing safe and effective psychedelic-based therapies with top partners, creating scalable synthetic psilocybin for inpatient depression treatment. Instead of the bandage solution of antidepressants, which just numb the symptoms through daily use, Cybin offers a long-term fix in just a couple of doses. Now, this might sound like something from the future, but the company's already gaining traction. They got the FDA's Breakthrough Therapy designation, which means a fast track for their drug development process. This is the first known time the FDA has granted this status for a psychedelic-based therapy for major depressive disorders. Cybin recently had no issue raising $150 million in capital, and following a positive FDA meeting, they're set to launch phase 3 trials in the US and Europe, with all clinical supplies ready to go. It's pretty wild to think that the same mushrooms that are healing our minds today may have played a key role in shaping them in the first place. But we're getting a little ahead of ourselves. In order to be self-conscious, we need a brain first, so let's get back to our timeline. 3.5 billion years ago. Before we humans can enter the scene, we need one very important thing, and that's oxygen. Earth used to be full of nitrogen, hydrogen, water vapor, and carbon dioxide. It wasn't until cyanobacteria came along that we got the precious oxygen that we humans need. 1 billion years ago. Fast forward to 1 billion years ago, when Earth was shifting around, creating different supercontinents. You had Rhodina, and then a couple of 100 million years later, another supercontinent, Pannotia, formed near the South Pole. This was also a time when single-celled organisms were starting to form into the first simple animals. 550 million years ago. 550 million years ago, one of the most critical events in our history took place, the Cambrian explosion. This is when hundreds of different animals burst onto the evolutionary scene. It was the building block for every major animal we know today, including you. 66 million years ago. The dinosaurs ruled Earth for hundreds of millions of years and survived multiple extinctions, but all good things eventually come to an end. 66 million years ago, an enormous asteroid hit Earth, landing on the Yucatan Peninsula in today's Mexico. It coughed up a ton of debris, blocking the sun. This finally wiped out the dinosaurs. This might seem like an insignificant event for us humans, but this extinction opened up the spot for mammals to become the leaders of the animal kingdom. 40 million years ago. These mammals included small, furry ancestors of all primates. The early primates were similar to the small rodents we see today. They lived and multiplied in a unique ecological niche, eating an omnivorous diet of fruits and insects. They continued to evolve, and their brains grew bigger. Without competition from the dinosaurs, they were able to grow exponentially. After millions of years of evolution, monkeys were seen in Africa, Asia, and South America. Fast forward another several million years, and apes evolved. Then the orangutan lineage split off. Soon it would be our turn. 8 million years ago. Then, about 8 or 9 million years ago, human, a common ancestor to both chimpanzees and humans, split into two lines, chimpanzee and human. For a long time, biologists thought this was a clean split that created separate chimpanzee and human species, but they were wrong. The two lines continued to mate and exchange genes for millions of years. It may have taken a full 4 million years before the two species fully broke from each other. Even today, though we're a different species, humans share an astonishing 98 to 99% of our genes with chimps. So, 5 to 6 million years ago, the Homo genus became distinct. Despite being a separate line, our ancestors were still pretty ape-like. You may have heard of Lucy, a 3.2 million year old ancestor from Ethiopia. Her brain was tiny, chimp-sized. The secret to big brains had yet to be discovered. And Lucy had long arms. She probably spent a lot of time swinging in the trees at night. But there was one important feature that separated early humans, including Lucy, from apes. We were bipeds, walking on two legs. What led to that? Well, there are two explanations for what got humans walking upright. The first is the savanna hypothesis. According to this, when forests retreated and savanna spread, humans spent more time foraging among the grasses, and walking upright allowed them to see better, like an SUV that towers over all the sedans. However, after studying chimps in western Tanzania, some scientists believe early humans mostly walked upright in trees. This may have been to gather fruit in the upper branches or to escape predators, but this theory has got some explaining to do. For instance, it can't explain why humans became bipeds but chimps didn't. Then how about them kangaroos? 2.6 million years ago. About 2.6 million years ago, early humans started getting the hang of things. Their brains began developing further, which allowed them to start making tools.
The species behind this was Homo habilis, sometimes known as handyman. The early tools were only sharpened stones. It took another million years for humans to make hand axes, but we'll get to that in a bit. Scientists don't believe these early humans were fearless hunters. They were probably mostly scavengers, eating leftovers from kills of saber-toothed tigers. They used their tools to cut up carcasses and break bones to get to the nutritious marrow. If they got lucky, they also ate zebras, elephants, rhinos, buffalo, and giraffes. But mostly, they were just eating salad. It's no surprise that early humans weren't all that fearless. Life was dangerous. We see some pretty gruesome deaths in the fossil record from 1 to 2 million years ago. One adolescent was caught by a leopard and dragged up a tree. A 3-year-old was likely picked up by an eagle with its talons digging into the child's skull. And if it wasn't a leopard or an eagle, gum disease might get you. One kid got an infection after a baby tooth fell out and died of sepsis. Scientists even found a woman who died of vitamin A poisoning. Maybe she binged on animal liver. I don't know about you, but I'm feeling pretty lucky that I live in the present. 800,000 years ago. Then, 800,000 years ago, early humans learned a new valuable skill. Not only would this change the path of history, but it would give today's dentists something to do. But more on that in a second. Humans learned to control the use of fire. This meant we could keep ourselves warm, scare off predators, and cook meat. With humans eating more meat, this caused our most important organ to grow larger: the brain. But there was a downside to all this new delicious cooked food. It was now softer and easier to eat. This led to humans needing to chew less and our jaws becoming smaller. And a smaller jaw means we were more likely to have crooked teeth due to crowding. Take a look at this caveman's teeth. Yeah, perfectly straight because of the larger jaw size. 400,000 years ago. Okay, now that humans had fire and food, they were looking for a better form of shelter. They didn't want to live in dark and dingy caves any longer. They decided to start building houses. Now, the oldest building we have a record of is from 400,000 years ago, located in France. This is also when Homo heidelbergensis enters the picture. They're a key extinct species of human that were ancestors to Homo sapiens, Denisovans, and Neanderthals. Between 300,000 and 400,000 years ago, a group of Homo heidelbergensis moved from Africa to Eurasia. One subgroup moved west to Europe, becoming Neanderthals. Another subgroup moved east into Asia to become Denisovans. A little later, we'll tell you about interspecies romance, so keep these players in mind. Meanwhile, back in Africa, 300,000 years ago, a gradual evolutionary transition began from Homo heidelbergensis to the first of our species, Homo sapiens. In another 150,000 years, these archaic Homo sapiens further transitioned and evolved into the humans we know today. Fossil evidence helps us to see a transition in the physical features. The size and shape of the forehead, the brow ridge, and the face changed over time. Homo heidelbergensis had a more prominent brow ridge and a projecting face. Modern Homo sapiens skull was more rounded and bigger, and they also developed a higher forehead. 200,000 years ago. About 200,000 years ago, sometime in the middle of this transition from archaic to modern, a key female ancestor was born. Scientists now call her mitochondrial Eve. The DNA of each and every one of us tracks back to her. Think of her as your great-great-great-great-great-great-great-great-great-grandmother. Okay, we've got fire, shelter, and a great-grandma, but life was still hard for early humans. Anything could kill you. Diseases, a fight over a giraffe carcass, encounters with animals. In Africa, it was lions or venomous snakes. In the Asian tropics, tigers. In the Americas, cougars and jaguars. So the average life expectancy was only about 30 years. The total number of humans on Earth was probably under 1 million.
74,000 years ago. Then, 74,000 years ago, our fragile existence was threatened. A supervolcano erupted. There was a massive global climate disruption. Africa experienced increasingly dry conditions. Homo sapiens came close to being wiped out. Maybe only 600 to 10,000 adults of reproductive age survived. During this difficult time, humans seem to have broken off into smaller, isolated groups. As the area became drier, rivers shrank, but this made aquatic life easier to catch, so for a while, humans ate more fish. Ultimately, the fish may have been depleted, and this was one of the likely reasons that they left Africa. 60,000 years ago. About 60,000 years ago, modern humans began migrating out of Africa. With waters receding, new travel routes might have become more accessible. Humans first went to Asia. By 45,000 years ago, they were settled in Indonesia, Papua New Guinea, and Australia. Now, remember I said we'd tell you about romance with Denisovans? Well, in Asia, Homo sapiens mated with Denisovan populations. Denisovan DNA is 3 to 6% of the genome of specific Asian populations today. 40,000 years ago. Now, around 40,000 years ago, Homo sapiens made it to Europe using two paths. They got into Eastern Europe from Turkey, and the Mediterranean coast was another route. Here, Homo sapiens mated with Neanderthals in Europe and acquired genes related to skin and hair growth from them. Those cute freckles that you see? That's from the Neanderthals. Now, around 15,000 years ago, Homo sapiens went from Asia to North America. But how? Well, remember, the topography was different. Though today's continents were in place, a piece of land formed a bridge between Asia and North America for 5,000 years. It was called Beringia, and it connected eastern Siberia to Alaska. After making the trek to North America, some traveled down to South America. Now, this was the point in time when all other Homo species became extinct, leaving Homo sapiens as the only remaining humans left. We don't know exactly why this happened, but research suggests that it may have been due to us having better survival rates, or the other species were just outcompeted in some way. 12,000 years ago. Then, 12,000 years ago, we reached a major turning point. Humans began to master farming. They grew wild varieties of peas, lentils, and barley, and began herding goats and oxen. The first farmers lived in the Fertile Crescent, a region in the Middle East, but there wasn't just one group. Multiple unrelated groups, isolated from each other, all pursued farming around this time. As humans became farmers, population growth picked up. By 1 AD, our population was about 170 million. In the 14th century, we were hit by the bubonic plague. It wiped out 50 million people of a worldwide population of just about 450 million. It took 2 whole centuries for Europe's population to recover to pre-plague levels. 250 years ago. 250 years ago, the Industrial Revolution began. Our world transformed from rural and agricultural to urban and industrialized. Our population started to grow rapidly. We hit 1 billion people in 1804, and in 2023, we were at 8 billion. Our growth has been exponential, but humans have needed vast amounts of energy. First, we got this from coal, then from oil and natural gas. Now, we're on the path to harvesting solar power, discovering new technology, and space travel. Now, if you're intrigued by the psychedelic mushroom theory, then, hey man, make sure to check out our other channel, Aperture. Here, we dig into more insane philosophical concepts, like how money is humanity's biggest illusion and the fundamental reality of consciousness. Let's step back, 2 billion years back, into Earth's evolution, a time full of life, but also mass extinction. An invisible killer was on the loose, ready to change the course of history. This was a time on Earth that had direct impact on what the world's like today. The animals that inhabit it, the food that we eat, and the air we breathe. Would you be able to survive in this new environment? And how did almost all life come to an end during this time? Time to go back. 2 billion years ago. Welcome to Earth 2 billion years ago. You're landing at a time when Earth is about halfway to its current age. Now, as you make your descent towards this prehistoric Earth, you'll see blobs of land and maybe some chunks of ice separated by water. These land masses look nothing like our continents today, but that's gonna change soon. As your time machine touches down, it's a bleak and rocky landscape. There are no plants, no trees, no vegetation at all. No signs of any animals either. This was a time before complex multicellular life. The only living things on Earth were microorganisms. Yeah, it might sound a little dull, but at least there are no predators you need to worry about. I hope. Before you step out on the ground, you better put on your suit that's fitted with oxygen tanks, because while there is oxygen in the air, there isn't enough for you to breathe comfortably. It's less than 10% of today's oxygen levels. When Earth was first formed, there was only carbon dioxide, methane, and water vapor in the air. But more on that in a minute. As you step out, you look into the water surrounding you. It's completely still, and there are no fish swimming in it, but it's filled with a ton of green, slimy stuff. What you're looking at is a whole lot of cyanobacteria, one of the most important bacteria ever to live on Earth. Cyanobacteria are responsible for the air we breathe, but they were also responsible for the most massive extinction event of all time. Flashback about 500 million years. To see how this extinction event happened, we need to skip back in time even further, another 500 million years. This time when you land, you'll definitely need your oxygen mask because there's zero oxygen in the air. Like the calm before the mass extinction event, everything looks great on Earth. Our young sun is a bit dimmer, even a little bit cooler, but temperatures on Earth are balmy, around 21 degrees Celsius. There's plenty of liquid water, but no ice. The carbon dioxide and methane in the atmosphere are driving a greenhouse effect. The only life that's around is in the water, and again, I'm not talking about fish. It's all single-celled organisms like bacteria, which were living in very different circumstances, like the zero oxygen environment you're standing in right now. But this water isn't only filled with boring bacteria, it's now filled with cyanobacteria. This bacteria evolved with a special trait, the ability to use water as a fuel to photosynthesize. And with this trait, it was able to produce oxygen. The cyanobacteria began to change the chemistry of Earth's atmosphere. As bigger and bigger colonies of cyanobacteria photosynthesized, they produced more and more oxygen. Now, this didn't result in much at the start, as much of the oxygen being produced would react with minerals and get removed from the environment. But fast forward a few 100 million years, and things start to change drastically. Now, so much oxygen is being produced that it can't be removed fast enough. It oxygenates the water, it escapes into the air, it reacts with methane and displaces it from the atmosphere. Earth's atmosphere is filling up with oxygen and becoming breathable. But don't take off that mask just yet. The oxygen level is still only 20 to 40% of what it is today. Maybe even lower, but this level is obviously much higher than the near zero level Earth had before. So, how do the other bacteria react to this new level of oxygen? Well, you can't see it happening because they're microscopic, but they're dying off in huge numbers. This is the Great Oxidation Event, also known as the biggest extinction event in Earth's history. The oxygen being created turned out to be pure poison for other bacteria, killing off 99% of all life on Earth. And this isn't the only catastrophic event happening. This massive amount of oxygen in the atmosphere is about to have a big impact on something else. The cyanobacteria is creating oxygen, but it's also wiping out two greenhouse gases, carbon dioxide and methane. These two gases played a key role in the evolution of Earth up until now. They helped trap the sun's energy, keeping the planet warm. With both of these elements being removed and oxygen taking their place, it's starting to get very, very cold. Over hundreds of millions of years, you'd see massive changes in the landscape. The oceans are freezing. Sheets of ice are covering Earth. Brown and rocky land is now turning snow white. One of the earliest ice ages has begun. This is the start of the Huronian glaciation. It'll last about 200 million years. Throughout this time, you'll see Earth go through 3 glaciations. No part of the planet is spared. The continents, the poles, even at sea level. It's all ice all the time. Now, all life on Earth has already taken a severe beating, and these chilly conditions aren't doing much to help. Neither the oxygen nor the deep freeze are doing any good for the survival of our older microbes. But somehow, a small sliver of life, just around 1% of the living, persists over these 200 million years. No, sorry you can't see them, they're still microscopic and living in rare parts of the Earth. They're just hanging on, waiting for the ice to thaw. Back to 2 billion years ago. Wow, look at you, time traveling everywhere. You're quite the explorer. If you want to explore even more, well, you should check out the What If Explorers Club on Patreon. There you'll find ad-free videos, get a chance to contribute story ideas like this one, and more. But our Explorers Club is in the present day, and right now, you're 2 billion years in the past, at a pretty significant turning point in history. A whole slew of exciting things are about to happen that will transform the face of Earth, both physically and biologically. Volcanoes are erupting, the ice is melting, a new continent is forming, and life is making a comeback. 3 different natural and geological processes started, beginning a transformation and ending the ice-covered Earth. Let's go through them. The sun is a little bit warmer now than when we flashed back the extra 500 million years, but maybe you notice the sun is also looking a little bit brighter. Well, this is because the sun's luminosity increases at the rate of about 1 degree Celsius every 100 million years. So now the sun is 5 degrees warmer. But this warmer sun by itself is not what melted the ice sheets. A second natural phenomenon is now playing a role. It's typically known for causing mass destruction and extinctions, but at this point in history, it's shaping the continents and saving the Earth. I'm talking about volcanoes. Although Earth was just covered with significant amounts of ice, under the crust, it remains hot and molten. Plate tectonics are starting to change things deep below the surface. A giant surge of volcanic activity is happening. Powerful whirlpool currents of lava deep in the mantle can no longer be suppressed. Magma is swelling up under the Earth and breaking through in a series of volcanic eruptions. These explosive conditions will continue for another 300 million years. The small separate land masses that you saw as your time machine descended are being pulled together by this volcanic activity to form the first supercontinent, Nuna. Fast forward to today and you'd be standing in Colombia. The volcanoes are also causing a remarkable transformation of Earth's atmosphere. This will affect the climate, making it much warmer. Now, this change might seem catastrophic at first, but it's going to give life on Earth another chance. That's because these volcanic eruptions are spewing water vapor and carbon dioxide into the air, and there's no microbial life to remove the carbon dioxide yet, so more and more of it is accumulating, trapping heat and making Earth hotter. With this new heat, the ice sheets are melting away. This volcanic action is still affecting us today. The lava spewing from the volcanoes eventually helped turn carbon into diamonds. In fact, most natural diamonds today can be traced back to this era. So take a moment to think about this cataclysmic event 2 billion years ago on your wedding day. But this isn't all that's happening. Over in Africa, another massive event is occurring. Nature's first nuclear reactor. Now, you're probably wondering how you could possibly get a nuclear reactor going on Earth. After all, don't you need a concentration of radioactive material? Well, yes you do. And this is what that pocket of Earth had. During its formation, Earth had accumulated bits of uranium from interstellar dust. This uranium was created by supernovas as stars died and exploded. Over hundreds of millions of years, microbial activity concentrated this uranium, and tectonic activity had it buried deep inside of Earth. 2 billion years ago, the right set of circumstances came together. A nuclear fission reaction began in the concentrated uranium. Uranium is naturally radioactive, so it decays over time. It splits to release neutrons. Like one domino hitting another, these neutrons in turn hit other uranium atoms which split, and this causes a chain reaction, creating this natural nuclear reactor. This natural process might have important lessons for humans today. Burning fossil fuels is making climate change worse, and the pressure is on to explore other sources of energy, like nuclear fission. But one of the challenges has always been how to store nuclear waste safely. It's possible that by studying this uranium mine, we could learn something useful. All these processes are working to warm up the Earth. The warming sun, greenhouse gases from volcanoes, and in this particular spot, Earth's very own nuclear reactor. As temperatures rise, water is becoming more prevalent than ice, and the landmass of Nuna is shrinking. One more important thing is happening right now. You can't see a lot of it without a microscope, but the 1% of microorganisms that made it through the Ice Age are wiggling their toes, metaphorically speaking, and starting to thrive. New life evolved through the oxygen-rich Ice Age. Microorganisms evolved that took in oxygen to burn food and released carbon dioxide in the process. The carbon dioxide released was then used by the cyanobacteria to produce more oxygen. This was happening at a microscopic level. Today, it happens with all kinds of different creatures. Now, humans and animals breathe in oxygen and exhale carbon dioxide. Plants take in carbon dioxide, photosynthesize, and release oxygen. So, the cyanobacteria was one of the original building blocks for all life today. But the oxygen didn't just power up microbes. During the long Ice Age, it began to form a protective layer in the upper atmosphere of the Earth, the ozone layer. This protected new life from ultraviolet radiation. Practically speaking, it expanded the real estate of Earth. Microbial life could now live on thin films of water protected from radiation and use the sun's energy to photosynthesize. You know what? I just remembered I packed a special microscope in the time machine. I know, sorry, we could have used it earlier. But you can use it to take a better look now at how cellular life is evolving. At this point in history, cells are changing to become more complex, with a distinct nucleus. This will allow the first plants to borrow traits from the cyanobacteria, which allows them to photosynthesize. So we can thank these microorganisms for the creation of all plant life we have today. Without photosynthesis, plants just wouldn't exist. Other creatures began to form during this time too. Scientists have unearthed fossils of multicellular creatures. These are sea creatures with soft, gelatinous bodies. They come in many different sizes, some as long as 17 centimeters long. At the time, they probably burrowed into the mud of rivers. These particular creatures survived while oxygen concentrations were high, but later disappeared, leaving no direct descendants. Rest in peace, little guys. Their complex multicellular life is the basic blueprint for all multicellular life today. Plants, humans, animals, fungi. Even the algae from this time didn't disappear completely. They're preserved in beautiful rocks called stromatolites, and if you're ever in the mood to see 2 billion-year-old rocks, pay a visit to the Belcher Islands in Hudson Bay, Canada. Geological and biological events from 2 billion years ago are the key to life on Earth today. The oxygen we breathe, chlorophyll in the plants we eat, the beginnings of our complex multicellular existence, not to mention the protective ozone layer. Who knows, maybe the past holds the key to our future. Maybe cyanobacteria could gobble up carbon dioxide and save us from the climate crisis we're in today. Millions of years ago, Earth looked very different. All the continents were fused into one, teeming with life, both beautiful and terrifying. When you think of prehistoric times, you might picture a T-Rex rampaging through the jungle with its razor-sharp teeth. But even before the dinosaurs, there were other giant creatures ruling the Earth. Yeah, welcome to the Permian period. This epoch started 300 million years ago. Back then, our planet had one supercontinent, Pangaea, surrounded by a world ocean called Panthalassa. The Permian period began at the end of an ice age when temperatures were much cooler than today. Then, during early Permian days, Earth warmed to a lush environment with a diversity of plants and a rapid evolution of insect and animal life. Only, as you probably know, everything is ever-changing on our blue marble. Over the next 50 million years, Earth kept growing hotter and drier. Eventually, the most deadly event in the history of our planet wiped out nearly everything that ever lived here. Scientists call this event the Great Dying, and it was the most catastrophic mass extinction event the Earth has ever seen. And the Earth has seen 5 of them. But before we get to all this doom and gloom, let me take you on an epic journey back in time. Here in the Permian period, some of the most incredible species that roamed our young planet are about to emerge. If you could time travel nearly 300 million years into the past, you'd land smack dab in the middle of the supercontinent Pangaea. Earth's smaller continents would have just finished colliding with each other to form this enormous landmass, taking up 1/3 of the planet's surface. There was likely less oxygen in the air than there is now, but you still might be able to breathe. Oh, and bring a jacket because it would likely be chilly, with some areas averaging no more than a brisk 4 degrees Celsius. But don't worry, things will soon start heating up. By the end of the early Permian, the Ice Age was on its way out and Pangaea was becoming a lush world. Plants and animals started to thrive. This was a volcanic world. Violent eruptions changed the climate, shaped the landscape, and paved the way for evolution. When giant swamp forests began drying out, plant life had to adapt, and so, 290 million years ago, Earth saw the very first seed-bearing plants called gymnosperms. These plants carried seeds on their cones, and they spread across the supercontinent like wildfire. The ancient evergreen forest of the early Permian was hiding something familiar. Just like today, you could find cicadas and beetles piercing and sucking on the plants, and the cutest of them all? Cockroaches. Only, these weren't the cockroaches you know today. These prehistoric vermin were gigantic, the size of birds. But despite their size, cockroaches never ruled prehistoric land, and that's good news, am I right? No, something much more fascinating was roaming Pangaea. The now extinct ancestor of primitive mammals, Dimetrodon. This animal was as fascinating as it was terrifying. Encountering a Dimetrodon would be quite a sight to behold. This ancient lizard grew to 5 meters long and weighed 225 kilograms. It had a large sail running down its spine. Scientists think this sail helped the reptile regulate its body temperature, soaking up warmth during the daytime and dissipating excess heat during the cooler nights. It would walk toward you like a crocodile and act like a total menace. Dimetrodon was an apex predator of its time. Watch out for a mix of sharp and flat teeth that would slice you open and grind you up. In the Middle Permian period, other mammal-like reptiles took over the planet. Therapsids. They had strong jaws with sharp teeth and a somewhat upright stance thanks to their legs being situated underneath their bodies. Therapsid reptiles varied from the 5-meter-long, likely omnivorous Deuterosaurus to the 5 times smaller, meat-eating Lycanops. You could meet plenty more therapsids if you stuck around for another 20 million years. During the Middle Permian period, Earth kept getting hotter. The average global temperature on Pangaea grew to about 25 degrees Celsius. And volcanoes were spitting greenhouse gases out into the atmosphere. Due to the changing climate, sea levels were shifting, but marine life found ways to thrive. If you were to take a dip in the prehistoric superocean, you'd be swimming alongside ancient sharks and bony primitive fish. Many more complex marine species came and went as the environment kept changing. In the late Permian period, you could have a friendly encounter with another reptile, Lystrosaurus. These looked like a cross between a lizard and a pig, but unlike all the scary prehistoric monsters out there, Lystrosaurus was a herbivore. It was just 1 meter long and had powerful front legs for burrowing. Soon, another cute mammal-like lizard evolved, the cynodont. The cynodont looked like a giant rodent. It was about 1 meter long, had whiskers, and fed on small animals and insects. Now, during this time, something bad was brewing in the air. A large amount of volcanic activity was displacing oxygen from the atmosphere. Scientists think there was as little as 10% oxygen in the air. Compare that to 21% today. You'd have a hard time breathing in that environment. And the temperature kept rising and rising. With an average temperature of about 28 degrees Celsius, this lush prehistoric world was turning into an oven. All good things must come to an end, and sadly, this period came to a particularly brutal one. About 252 million years ago, about 90% of all plant and animal life was wiped out. This tragic moment is called the Great Dying, and it was Earth's most devastating mass extinction event. Scientists still debate what caused this catastrophic extinction. Most theories suggest it was the result of explosive volcanic activity. As huge volcanic eruptions swept the continent, massive amounts of ash were unleashed into the atmosphere. So much ash that it blocked out most, if not all, of the incoming sunlight. And with no sunlight, global temperatures dropped suddenly. Plants couldn't perform their photosynthetic processes and died off. And without plants, the very basis of their food chain, animals soon followed. Things got worse before they got better. Because of all the carbon dioxide emitted during the volcanic eruptions, global temperatures rose again. And not just to where they were, but higher, much higher. And this caused the superocean to lose most of its oxygen. And unable to breathe, a majority of the Permian sea animals perished. Eventually, over 95% of marine species and more than 70% of land animals became extinct. This mass extinction event could make you sad enough to want to bring back all the animals that have ever gone away. This is the Megatherium, a giant sloth that roamed Earth just 12,000 years ago. This beast stood more than 3.5 meters tall. And today, we're gonna see what this creature was all about. Oof, that anyone hurt. But this is just one way you might die from a prehistoric animal. Creatures that lived thousands or millions of years ago were absolutely terrifying. From giant dinosaurs to the largest snakes ever discovered. If you were to come face to face with any of these creatures, there's a pretty good chance you'd end up dead. But how would that shake down? Okay, let's start by sending Digipeater 60 million years into the past. This is the Cretaceous period. During this period, part of the Mesozoic era, there's a good chance you could come face to face with a Titanoboa. A Titanoboa was nearly twice as big as any snake living today. They grew to more than 12.5 meters long and typically weighed over 1,000 kilograms. These giant snakes would lurk in swampy rainforests in what's now known as Colombia.
Titanoboa is such a big animal that, like big animals, it probably spent most of its time in the water. It would have been in aquatic environments for a good part of it, simply because it's so big, it's going to be hard to hide.
That's Dr. Michael Caldwell, one of the leading paleontologists here in Canada. Our correspondent Rose spoke with him and other prehistoric experts to figure out how I would die from these creatures. Thanks, Rose.
No problem, Peter. And speaking of which, what would happen if the Titanoboa attacked you?
Now, a snake this big needs a lot of food. And seeing a piece of prey the size of Digipeater, it would attack instantly. But how? Well, these snakes would swim through the water, using it for camouflage to get close enough to attack. They often hung out near lakes and rivers, waiting to strike. As it approaches Digipeater, the Titanoboa would open its mouth, sinking its curved teeth into him in order to grip and secure his body. A Titanoboa would then coil its body around you rapidly. The feeling would be like you were being crushed by the Eiffel Tower. Oh, poor Digipeater. This feels wrong. So, is there a possibility that we don't have to use a Digipeater? We could use somebody else in a 3D model? No, not a possibility? Okay. As the Titanoboa wraps around your body, it would eventually stop your blood from flowing. And we all know what that leads to.
Honestly, if it was coming after you, you probably wouldn't stand much of a chance. If it's got to be you versus the snake, my vote's going for the snake.
Sorry, Peter, this doesn't sound like it'd be very good for you. How is it that the Titanoboa can open its jaws so wide that it could swallow you whole?
Particularly the boa and python kind have really developed extremely elastic muscles and soft tissues in the throat region.
Snakes' esophaguses blow up like a balloon and then deflate over time, so we can apply the same logic to the Titanoboa.
The body of the animal is so large that just weight alone, it pins you to the ground, and it's going to get a hold of your head with its mouth, and you're going to be crushed just under the weight of the animal. Whether it could or could not constrict you really wouldn't matter.
Great, thanks for making this even worse for me. Now, as you're passing through the Titanoboa's body, you're slowly being dissolved by the snake's stomach acids. This would be a long, slow, and painful process. Remember, it's a 12.5 meter snake. Well, it wouldn't really be painful since you're already dead. And by the time the Titanoboa has finished digesting you, virtually nothing would be left. That's right, the Titanoboa's stomach acids are so strong that even your bones would be dissolved. The only parts of you remaining would be your nails and some of your hair.
So even though the Titanoboa's belly might be full, it might not be for the best.
If you choose to eat a big goat, you're sitting there for 3 or 4 days before you can move. That has serious biological repercussions because anything walking by and you're just like a snack with another snack inside of you.
So Peter, even though now you're eaten by a Titanoboa, you can at least be happy that the predator has now become the prey.
Yeah, I guess so. Okay, let's rank these deaths on our pain scale.
I'm giving this one a 7 out of 10, because we have some even more terrible scenarios coming up. Okay, now that's how you die 60 million years ago. Now let's go back a little further, 66 million years into the past. This is the age of dinosaurs. Lurking around every corner is something that wants to kill you. Let's see how Digipeater fares. Why is the ground shaking? Oh no, oh gosh, it's a Tyrannosaurus Rex. I better start moving. Run, little guy, run! This nearly 7,000 kilogram beast was the ruler of the dinosaur kingdom. Hunting in complete solitude, it's approaching Digipeater at nearly 60 kilometers per hour. Yeah, I don't think I stand a chance here. Maybe I can survive by hiding behind a tree or staying very still. After all, the T-Rex was only good at detecting prey when it's moving. It had eyes the size of oranges, which are bigger than any mammal we have living today. There's no chance my digital legs are getting away from this. All of a sudden, the T-Rex bites with its banana-sized teeth. It had a bite force of nearly 13,000 psi. That would feel like you were being crushed by a building. Then it would tear the flesh off your bones until they were stripped clean. That doesn't look too fun. But what do we really know about the T-Rex? I mean, other than what we've watched in the movies. What do the experts have to say?
I went to the Canadian Museum of Nature to talk with Dr. Jordan Mallon to find out. I saw online that Tyrannosaurs are really fast runners. They can run up to 45 kilometers an hour. Is that true?
I think the consensus nowadays is T-Rex probably wasn't as fast as you suggested, probably more like half that. It would have needed more muscle dedicated to its legs than it possibly could have fit on those legs. Because of course, the bigger you are and the faster you want to move, the more muscle you need. And at some point, the amount of muscle required to move a certain speed is just impossible.
Not only that, but if the T-Rex were to move at speeds over 40 kilometers an hour, that would increase its chances of falling over, which, according to Dr. Mallon,
if you've got an animal moving that fast and it falls at those speeds, forget about it. Like, that's a dead animal.
Okay, maybe its speed is over-exaggerated in movies, but you know what isn't? Their size. The T-Rex is ridiculously massive. It wasn't until I got to see a cast of its skull where it really started to click.
You know, T-Rex could eat you in one bite effectively. You know, the skull's 4 or 5 feet long.
And its teeth were even more terrifying.
What's really cool about T-Rex is that its teeth are unlike those of many other meat-eating dinosaurs. They're almost like banana-shaped. And this would have allowed T-Rex to not just cut through meat, but crush bone.
This kind of feels like a dagger slash really, really heavy knife with tiny serrations on both sides. I feel like this could kill somebody, honestly. It gets even worse. There's some evidence that suggests T-Rexes might have traveled and hunted in packs. So Peter, it looks like there's some good and bad. On one hand, the T-Rex is ridiculously massive, deadly, and you might have to deal with a couple at a time. But on the other, it's not as fast as we thought, so you might have a chance to outrun it. Good luck.
Okay, let's try this again. So, if you were transported 66 million years into the past and a T-Rex was coming for you, it might look something like this. Instead of just one T-Rex, Digipeater is dealing with 3, 4. He can try standing still in hopes that the T-Rexes don't see him, but wait, that doesn't look like it's gonna work. T-Rexes actually had amazing eyesight, and they didn't rely on movement to see their prey. They had better eyes than a modern-day hawk, so seeing prey was incredibly easy.
One of the really distinctive features about T-Rex in particular is that its eyes face forward like yours and mine. It had binocular vision. It had an overlapping field of view. So the eyes would have been located one here and in the same socket on the other side here. That's a big eye. It would have taken in a lot of light, so they almost certainly had good vision.
So Digipeater has no choice but to run away and hope for the best. And this time, running might be his best option. Oh no, never mind.
Remember, T-Rexes were also ambush predators, so you likely wouldn't even have the chance to run away from them.
Jurassic Park, the T-Rex in that movie was always roaring and announcing its presence. You knew it was getting close before it was there because it was causing the ground to shake. And very likely T-Rex was not quite so loud.
Instead, they'd sneak up on you, chomp down, and kill you. Then the whole group of T-Rexes would devour your body, bones and all.
So if the T-Rex ate everything and it was a bone crusher, did it actually eat the bones of the animals that it ate?
Yes, and I've got something to show you here. This is actually a T-Rex turd. There was some science done on this. It was put inside of a CT scanner, and it contains many fragments of dinosaur bone.
Ooh, this one is nasty. This is an 8 on the pain scale. But the T-Rex wasn't the only deadly creature that would be out to get you. Another deadly dino and Jurassic Park star during this time? The raptor. If they're anything like what we see in the movies, these guys are terrifying and extremely dangerous. Early research depicted these creatures standing at about 2 meters tall, that's 6 feet. They would easily use their size and strength to overpower Digipeater. The main thing you'd need to watch out for? Their sharp, sickle-shaped claws. These claws could inflict fatal wounds or disembowel you almost instantly. And good luck outrunning them. A raptor could run at speeds of over 40 kilometers per hour.
This sounds pretty bad for you, but I wonder if we can get a second opinion.
So the velociraptors in Jurassic Park were nowhere as big as they were depicted. Velociraptors in life were more turkey-sized. They're quite a bit smaller.
Good news, but you still gotta worry about those claws.
Historically, the thinking was that killer claw there, the idea was that really it slashed open the belly of its prey.
But current research suggests that these so-called killer claws may have been quite different.
The problem is that when you actually look at the cross-section of the claw, it's not especially sharp or pointed, it's quite rounded. And so now the thinking is that maybe that claw was used to, like as a crampon, maybe to climb up on top of its prey, or maybe it was used to hold down the prey while the jaws did the dirty work.
In order to get our answer, I wanted to know just one simple thing. If a human was to hunt a raptor, who would win?
One-on-one?
Yep.
I think humans are pretty smart. I'll go advantage human.
Okay, but what does that mean for Digipeater? How many could he take on?
So I'll give you 5. 5, yeah.
How many raptors do you think I could take on?
11.
Yeah, that sounds about right.
All right, I like my odds. So, based off what we now know about raptors, maybe an attack would look more like this. Let's start by making the raptor way smaller and adding some feathers, another thing Dr. Mallon told us. Now it kind of looks more like a modern-day bird. And just like we're not afraid of most birds, you probably don't need to be incredibly scared of raptors. Sure, they might attack and hurt you. Again, they have the claws and the sharp teeth, but in terms of them killing our Digipeater, they don't really stand a chance. The only other thing Digipeater would have to worry about is if these raptors traveled in packs.
A lot of people think that raptors moved about in packs, that they were pack hunters. Again, that's thanks to the movies. But we actually don't have great evidence for pack hunting in any of these animals.
Phew, okay. Then I'm gonna chalk this up as a win for me, or for Digipeater. It looks like there's a good chance he'd survive an encounter with a raptor. So this is more like a 5 out of 10 on the pain meter. Okay, let's get back to our giant sloth. Would dying at the slow hands of this creature really be that bad? Well, again, our correspondent Rose may have the answer.
You might think of a giant sloth as, well, sloth-like, moving slowly and methodically. I'm talking 1/4 of a kilometer an hour, but they're actually a lot faster than that. I talked to Marisa Gilbert to find out more.
They probably moved around 3 to 5 kilometers an hour, and they probably were able to do short bursts of 8 kilometers an hour, but they were not very fast animals.
But we wouldn't have to worry about it killing us, right? These giant sloths were strictly herbivores.
We can say that yes, they were eating plant material. We know they were eating stems, foliage, leaves, that sort of thing, fruits.
But this time, instead of this giant sloth attacking us humans, it may have been the other way around. Megatherium may have gone extinct due to humans and climate change.
Sites have found tool marks on Megatherium and other ground sloth bones. And so it's safe to say that yes, it was a great resource for our ancestors. They were hunting and utilizing ground sloths for sure.
Finally, now it's time for some revenge. Instead of Digipeter constantly getting his butt kicked by prehistoric creatures, he's gonna fight back and win. The Megatherium was a type of giant sloth that originated in South America. Around 35 million years ago, when humans hunted these beasts, we did so with a variety of different tactics. Instead of using brute force and chasing these animals down, we used a more stealthy approach. And that's what Digipeter is going to do. Let's equip him with a stone spear and see what happens. As he approaches the local watering hole, he sees a giant sloth, ready for the taking. This could mean food for him and his tribe for the next 3 months. But remember, it's a giant sloth. These creatures were massive. They needed multiple humans to take them down. So, let's duplicate Digipeter and give him a fighting chance. Ah, that's better. Okay, now this should be a walk in the park. Our Digipeters go and ambush the Megatherium, poking and prodding with their spears, but as they continue their fight, it's not looking good. What happened here? Well, even though we had all the advantages we could think of, hunting a giant sloth was still no easy task back in the day. Even though they were mainly herbivores, they were pacifists. They'd still fight back when pushed into a corner. Their claws were more than 30 centimeters long. That's 1 foot. They mainly used them for digging roots, but now they're being used for clawing humans. If you got swiped with one of these, you'd be left to bleed out. A slow, painful death. You might be able to recover, but without modern medicine, the chances are pretty slim. This is an 8 out of 10 for me. Okay, next, we're going over 300 million years into the past to experience the Carboniferous period. This era had one particularly terrifying trait: giant insects. Now, this was because of really high oxygen levels in the atmosphere at the time. The insects drank it up. The extra oxygen allowed them to grow bigger than we've ever seen. One of the most notable bugs, the Arthropleura. This giant centipede-like creature was over 2 meters long. Once it sees you, it'll rush on over and start biting you with its giant fangs. An insect this large is surely going to want to attack you. Maybe it wants your blood. Or at least that's what you think would happen with an insect so large. Actually, research suggests that the Arthropleura was a super slow-moving insect. It hung out in forests and dined on dead plant material all day. It wouldn't be interested in you or any other creature. I'm giving this one a 0 on the pain scale. Okay, so we might not have to worry about a giant insect coming after us, but one creature we will have to worry about? The saber-toothed tiger. Let's fast forward from the Carboniferous to just 56 million years ago, a time when these beasts were one of the apex predators. These giant cats weighed over 200 kilograms and could run up to 40 kilometers per hour, but only for short bursts. And due to this lack of running, saber-toothed tigers were ambush predators. They'd hide in the bushes and the tall grass, waiting to strike. And when they did, they'd pounce on you with their giant claws and teeth. Their canine teeth could be up to 20 centimeters long. But once they got hold of you, there'd be no going back.
The saber-tooth would be on top of you, clawing and biting. It would likely go for your neck first to incapacitate you, kill you. Then it would feast on the rest of you. But unlike most predators during these times, this ferocious tiger wouldn't consume everything. It'd feast on your muscles and your flesh, but leave your bones. This is because it didn't want to damage its valuable canine teeth. Remember, we're about 56 million years away from veterinary dentists. Without the canine teeth that this beast was named for, it wouldn't be all that scary.
And you probably wouldn't have to worry about these saber-toothed tigers attacking you in the first place.
So we don't have any evidence of any tool marks on Smilodon, and we don't have any evidence of Smilodon attacking or having used humans as prey. We do know that they overlapped in time and space for quite some time. And I could say with certainty that there were encounters. They did see each other. They lived in the same place. They utilized the same prey. Were they prey? Were they preyed upon? I can't answer that.
So luckily for you, Peter, even if you were in this time period and saw this big cat, you probably wouldn't end up in a fight with one. But let's say you somehow did and wanted to survive. What are you doing next?
Humans would craft spears and strategize on how they'd attack a saber-toothed tiger. They'd also make sure that they set up camps in places that would give them a lot of advance notice if a saber-tooth was about to attack. These first encounters with saber-toothed tigers would be terrifying. Similar to the sloth, a single attack from this beast would mean the end for you. Yeah, I'm giving this one a 9 on the pain meter. But the good news is, it wouldn't always be like this.
After all, these saber-toothed tigers went extinct 10,000 years ago. And it wasn't from humans. There is no evidence that shows we had any significant encounters.
There was climate change happening at the time, and so they were part of that larger megafauna that went extinct at the end of the last ice age.
Okay, next up, the terror croc. About 80 million years ago, this beast reigned supreme. It was over 10 meters long and had a stronger bite force than the T-Rex. Similar to a lot of other animals on our list, terror crocs would ambush you. You'd likely be unaware of their presence due to their ability to camouflage themselves near the water. If you got too close, a terror croc would quickly lunge at you with its powerful open jaws and then bite down. And if its bite didn't kill you, it would perform the death roll. This is when a terror croc drags you underwater and spins you rapidly. This kind of punishment would almost certainly kill you. At that point, the terror croc would use its massive teeth to chew you into chunks, splitting your body into multiple pieces. And then the terror croc would consume every last chunk of you. Now, similar to modern-day crocodiles, the terror croc had a highly acidic stomach acid that was capable of dissolving your bones. Ugh, I think I'll pass. Now, given that these creatures basically roam around today, I'm giving this a 10. More on the fear scale, but also on the pain meter. Regardless of whatever creature we think we might be able to take on in a fight, I think coming across any of these scenarios would be terrifying. Let's just say I'm pretty happy that humans are at the top of the food chain in our modern world. What was life like in the Cenozoic era? Welcome to one of the most formative and terrifying time periods ever, the Cenozoic era. You'll find giant creatures like woolly mammoths and megalodons roaming the seas, along with some other creatures you might be a little bit more familiar with. But more on that later. Let's strap in and travel back in time to the Cenozoic era. How would you survive during this period? Why was Earth so dangerous? And how is this era similar to modern day? This is What If, and here's what would happen if you traveled to the Cenozoic era. Okay, you're now 66 million years in the past. You just missed the age of dinosaurs by a couple of million years. They were wiped out by a giant asteroid and are now extinct.
But that doesn't mean that other life hasn't found a way. The death of the dinos made way for new creatures to emerge. Mammals. Yeah, the early Cenozoic period saw the rise of primitive mammals that would begin to diversify into different evolutionary niches. Let's explore and check them out. One of the most famous mammals during this time was the megafauna. These were giant creatures that roamed the earth. A lot of these probably look familiar. Go to the colder regions of the earth and you'll find packs of woolly mammoths roaming about. These guys were nearly 3.5 meters tall and weighed up to 8 tons. Okay, go over to what's now known as Australia and you'll see the Diprotodon. This is the biggest marsupial that ever lived and looks like a giant wombat. And it wasn't just the mammals that were giant. Watch out in the water because you'll be met with one of the most terrifying creatures ever. The Megalodon. This giant shark dominated the oceans with teeth as big as 18 centimeters and a body as long as 20 meters. I could go on, but we have so much more to explore. Let's check out a couple of other creatures and then I'm going to show you something really cool. The Cenozoic era also had the Glyptodon, which was like a giant armadillo, the Megatherium, a giant sloth and one of the largest of the mammals, and the Elasmotherium, also known as the Siberian unicorn. It was basically a woolly version of a rhinoceros. And there were a bunch more creatures. But why were they all so big? Well, researchers have several different theories as to why these creatures became so massive. One of the leading ones is that with the dinosaurs gone, these mammals could thrive in open habitats, helping them grow larger and larger as generations progressed. But there's another incredibly important mammal I haven't mentioned yet, and although it's not a giant, it is one of the most important. And that's you. Well, sort of. Humans' early ancestors were primates. With the death of the dinosaurs, the rise of primates became possible, allowing them to evolve. Early primates were small and weak creatures when the Cenozoic era started, but they had two key features to help them become dominant: grasping fingers and forward-facing eyes. Over millions of years, they survived and later thrived on Earth. This led to primates diversifying and the emergence of different species, which then gave us two main groups: the primates, who would later evolve into monkeys and apes, and the hominids, who would later evolve into humans. But this wouldn't happen for millions of years. As the Cenozoic era progressed, hominids learned how to use tools, control fire, and develop the beginnings of early language. As more and more hominids appeared, they spread globally and could be found in Asia, Europe, Africa, and North America. Some of these species died out, specifically the Neanderthal. They evolved outside of Africa and adapted to live life in Eurasia, but as modern humans progressed, they were more technologically advanced, eventually leading to the extinction of the Neanderthal. As more and more species of hominids evolved, more and more died out. The only ones to survive were the Homo sapiens, who stayed in Africa. Their brains continued to grow, leading to more advanced language, technology, culture, and eventually you. Speaking of you, how would you survive in this era? Well, to do that, it'd be helpful to know what the Cenozoic era was made up of. After all, it spanned tens of millions of years and a lot of stuff happened. The Cenozoic era is divided into 3 time periods: the Paleogene, Neogene, and the Quaternary period. Let's quickly break them down. Paleogene period. This marked the start of the Cenozoic era. The mammals we've been talking about, along with flowering plants, have begun to emerge. Oh, and watch out for some creepy-looking insects. Earth's tectonic plates continued to shape continents, as they have been for many millions of years. South America and Africa would continue to move apart, and the Himalayas would begin to form. You'd notice a generally warm and comfortable climate, but that would start to change as you move into the next era. Neogene period. Okay, the hominids we've been talking about have now appeared, and more modern plants and animals have begun to evolve. One of the main things you'll notice is how much colder it's getting. Ice ages are becoming more common during this period. Quaternary period. This period had multiple ice ages and interglacial moments. The Earth cooled down and heated up several times. Humans, along with the large mammals we mentioned earlier, had more impact than ever before. This period is also known as the Anthropocene, which recognizes the significant impact humans had on the Earth's ecosystem and geology. So, how would you survive during these times? Well, it would be much easier than if you were to live in a time period even further away. Hundreds of millions of years ago, Earth had more oxygen, which would make breathing more difficult. But luckily, you don't need to worry about that. You just have to be wary of the giant animals trying to kill you, the unpredictable weather, and the weird kinds of foods that could make you sick. Sounds easy, right? Hopefully, you'll be able to cozy up with some early hominids and join their tribe. They'll have access to shelter, fire, and tools. And if you can't manage to do that, well, find a cave, make a fire, and hope for the best. But wait, you're technically surviving in the Cenozoic era right now. Yeah, that's right. This era hasn't ended yet. We're currently living in the Quaternary period. Eras on Earth are typically marked by major geological shifts or mass extinctions, neither of which we've had to deal with, luckily. You've traveled over 500 million years into the past to experience some of the most dangerous seas and alien organisms ever to exist on Earth. Welcome to the Cambrian period. What would Earth look like compared to how it does now? What could you eat to survive? And what kind of creatures would you need to watch out for? This is What If, and here's what would happen if you lived in the Cambrian period. Traveling 500 million years into the past? Well, the first thing you should probably do is get your bearings. Unfortunately for you, the Earth you knew so well is gone. Or rather, it's yet to come into existence. You'd find yourself on a planet with shallow seas covering most of its surface. And in the southern hemisphere, where you're standing right now, the supercontinent Rodinia is just starting to break apart. There's Gondwana, the landmass that will go on to include South America, Africa, and Australia. Laurentia, which includes most of North America, plus Siberia and Baltica, which span across what you might recognize as the eventual Scandinavia, Eastern Europe, and parts of Russia. You wouldn't really recognize anything, though. No familiar mountain peaks or lush greenery. It would mostly be barren, except for mosses and algae spread across the landscape. But as you made your way over to the ocean's edge, you'd soon discover an explosion of life thriving on this early Earth. But be careful, some of it could kill you. Just below the ocean's surface, you'd be treated to a glimpse of a time when life on Earth was diversified.
You won't find any here for a long, long time. By now, you'd be getting hungry, especially after watching those trilobites munch down on all their yummy snacks. And you'd start to wonder what on earth you'd be able to eat in the Cambrian period. Well, your best bet would be to stick close to the sea, but be careful. Don't reach for those worms too quickly. Some of the food sources you'd find could be highly toxic. You'd be consuming strange new bacterias that your body isn't used to, so brace yourself for an upset stomach or something even worse. And while you're out hunting for dinner, we'll keep an eye out for larger predators lurking in the shadows. But don't worry too much. A lot of what you'll see are organisms like the anomalocaridids. These shrimp-like animals could grow up to 38 centimeters, so they wouldn't do you much harm. You'd actually be the apex predator at the top of the prehistoric food chain. As your days stuck in the Cambrian period turn into weeks, you'll continue to struggle with adapting to your new environment. The low oxygen levels would make even the simplest physical tasks more difficult. And without fruits, veggies, and your usual proteins, you could be headed toward malnutrition. Now, despite all the challenges, you'd be witnessing one of the most significant eras of life's development on this planet. All those creatures in the sea will go on to evolve and be the foundation for much of life as we know it.
Human beings have existed for 300,000 years and have managed to live in many unstable environments. We've survived ice ages, devastating pandemics, and world wars. But how would we fare even further back in time? What about 400 million years ago when deadly marine life dominated our oceans and creatures on land were practically non-existent? Let's imagine your what-if time machine happened to break down right at this moment, trapping you in the Devonian period. What would life be like? Where would you live? And how long could you last? This is What If, and here's what would happen if you lived in the Devonian period. Stroke of luck, our time machine stops you on land. At this point in time, 85% of the Earth was comprised of ocean. Only 2 supercontinents existed 600 million years ago, Gondwana and Laurussia. Gondwana had a massive mountain range, similar to the Himalayas, which slowly eroded, washing sediments into the ocean. These sediments provided nutrients that allowed marine life to flourish, giving rise to the Devonian period. Okay, enough background. Our first step for survival is to seek shelter. In the early Devonian period, trees and plants had not yet evolved. But there's lots of moss. The land was barren, Mars-like, and surrounded by water. You might need to get a little creative to build shelter. If humans actually evolved in this period, they would likely be naked with little material to make clothes. Or maybe we would develop a new fashion line, made of moss, seashells, and fish bones. Ooh la la, how Devonian chic. Speaking of fish bones, you'd want to be very careful about fishing. Many scary sea creatures would be happy to eat you. Like placoderms, a species of armored fish with huge, sharp jaws that could easily make you bite-sized. In the early Devonian period, placoderms were the apex predator and would grow up to 10 meters. Let's say you got lucky and actually caught a fish without being eaten yourself in the process. How would you cook it? With no trees for fuel, you'd have to find some very dry moss and start rubbing some rocks together. Luckily, the climate was pretty warm, meaning you wouldn't freeze at night. But with very little kindling available, you might be better off sticking to a raw diet of mollusks and other early arthropods. You'd also have to move around a lot to keep finding these critters, so be prepared to do a lot of walking. I can see you're getting a little tired and bored of existing out there. Let's fast forward another 40 million years toward the late Devonian period. This period is also known as the Devonian extinction. But don't worry, it could actually be a really good time for you, fearless traveler. Since by this point, almost 79 to 87% of all existing species were wiped out. But what could cause such a catastrophe? Scientists believe it was the evolution of plants. Vascular plants began dominating the environment, including trees, ferns, and flowering plants. Their roots broke up the rocky ground and released nutrients and minerals in the water. These nutrients fed algae, which multiplied rapidly and produced greedy bacteria that fed on oxygen. Many regions of the ocean became anoxic zones, and much of the marine life died off due to the lack of oxygen. And with more air in the atmosphere, some sea creatures slowly adapted and made their way to shore. So you can breathe easier knowing there are less predators in the water, but look out for your new neighbors on land. These land dwellers, known as lobophinns, were the early ancestors of amphibians and all four-legged vertebrates. In fact, the Devonian period got its name from the fossils of lobophinns found in Devon, England. In 2004, a lobophin fossil was found in the Canadian Arctic, known as the Tiktaalik, which is considered to be the species between fish and land-dwelling tetrapod. It had a crocodile-like head, bony fins, sharp teeth, and a flat body almost 3 meters long. Its fins had partial wrists, allowing it to crawl on land. So if I were you, I would quickly hide if I saw a Tiktaalik coming my way. The other dominant species were cartilaginous fish, with skeletons covered in, you guessed it, cartilage. These are the ancestors of sharks and rays. But you don't have to worry about sharks. Oh no, there's something far bigger and scarier. I'd keep my distance if you happen to see a Dunkleosteus swimming around. These were the deadliest predators of the Devonian age, with thick bony plates covering their skulls and razor-sharp jaws. Some would grow up to 10 meters in length. Their jaws were strong enough to chomp right through another Dunkleosteus. With few fish left because of plants hogging the oxygen, these placoderms were starving and desperate enough to eat each other, so be very careful where you bathe. With more trees and plants emerging in your environment, you could finally create some helpful tools like spears, fishing hooks, and rope. You could improve your diet and maybe become a vegetarian. And you could fashion some new clothes that aren't so irritatingly itchy. By the late Devonian period, you might even be able to build yourself a treehouse in the Archaeopteryx, the first tree on Earth which grew up to 30 meters tall, with a trunk 3 meters wide. This may be nice for a while, but if you think the Devonian period is easy, you might want to plan a hasty exit before the Cretaceous period rolls around.
This is the world 200 million years ago. No cell phones, electricity, or even other humans. Would you be able to survive in this new world? Could you get yourself a pet dinosaur? Wait, dinosaurs are here? Okay, maybe this won't be so bad. This is What If, and here's what would happen if you were alive 200 million years ago. The world was pretty different during the late Triassic period. One of the most notable differences is this right here. This is Pangaea, a supercontinent containing different parts of today's world. There's Australia down south, North America in the northwest, and Eurasia in the east, all interconnected. It would take you a while, but in theory, you could walk from California to France. You won't see the Hollywood Walk of Fame or see the Eiffel Tower, as they don't exist yet. What would you see? The first thing you'd notice as you're traveling across Pangaea are all the dinosaurs running about. You won't have to worry about dinosaurs such as the Delong that weigh only 11 kilograms. They won't pose much of a threat. But watch out for the Melanorosaurus, who has a height of 12 meters and would find you to be a tasty snack. Scientists say that the late Triassic period was the dawn of the first dinosaurs. Dinosaurs of all sizes would be everywhere. You'd also see some other crazy creatures you've never seen before, and some that may remind you of animals you see today. This species, known as the Drepanosaurus, with its reptile-like skin and arched back, might be one of the first versions of birds to ever exist. The Triassic period was an incredibly important 50 million years of evolution. A time with not a lot of competition between species, since just prior to this period, 70% of Earth's creatures were wiped out in a mass extinction event. Many of the animals at the time were able to thrive and grow without having to be constantly wary of other predators. The further you travel inland into Pangaea, you'll notice the massive weather changes. The outer edges of the supercontinent may be full of lush forests and green grass, but the further you go in, that begins to change. Scientists suspect that much of Pangaea was a dry, desert wasteland. That's because the land mass was so large that the interior wouldn't have received the cooling effects of the ocean. Speaking of which, the ocean, known as Panthalassa, surrounded all of Pangaea and covered 70% of Earth's surface. This ocean was extremely deadly. It could easily produce super hurricanes and monsoons, and due to its massive size, they could gain enough momentum to hit Pangaea with potentially fatal weather. Pangaea was just beginning to separate 200 million years ago. If you were able to stick around a few million more years for the Jurassic period, that's when you'd truly see dinosaurs thrive.
66 million years ago, an asteroid as big as Mount Everest was headed on a deadly collision course with Earth. The impact was so devastating that it wiped out the most gigantic, deadliest reptiles to ever roam our planet. But the dinosaurs didn't just die from one big boom. No. They faced a slow, agonizing end. How did this extinction event cause the largest tsunami Earth has ever seen? And what exactly happened after the big reptiles were gone? Hold on tight, we're taking you on the most epic and deadly trip of your life. This dinosaur-ending asteroid is terrifying. Not only was it about 10 kilometers in diameter, but it also traveled incredibly fast, between 10 and 30 kilometers per second. At this point, it was a blazing fireball. As it hurtled down to Earth, the air in front of it was compressing and heating up to unimaginably hot temperatures. Just before the impact, the asteroid could have been as hot as the surface of the sun. Once it entered our atmosphere, it only took this massive space rock a few seconds to reach Earth's surface and alter the course of life forever. As the asteroid slammed into Earth off the coast of where Mexico is now, it sent huge amounts of debris up into the air. The shocking blast wave killed everything in its way, and from here, it was only getting worse. This powerful blast ejected bits of the Earth's surface into the atmosphere, and minutes later, scorching hot pieces of glass and rock rained back down. Some of the debris reacted with the atmosphere, causing acid rain that would last for years. The land was burning. The fires caused by this devastating impact spread across the continent like literal wildfire, killing more and more life along the way. And then, just when you thought the apocalyptic scenario couldn't get any more intense, well, it did. The impact of the asteroid hitting Earth was so powerful that it sent shockwaves through the planet. And all that energy had to go somewhere. Cue the mega tsunami. A wall of water over 10 meters high raced across the ocean. This wasn't your regular tsunami. It was a staggering 30,000 times more powerful than anything you see today. As this monstrous wave spread across the North Atlantic and South Pacific, coastlines didn't stand a chance. The wave hit with such force that it destroyed and reshaped the continent. If you were there to witness this apocalyptic destruction, well, you wouldn't survive any of it. But some dinosaurs did. Yeah, the ones further away from Ground Zero weren't immediately obliterated by the impact. They weren't incinerated by the resulting infernos, and they managed to avoid being swept away by the mega tsunami. But still, their fate was sealed. As the dust began to settle, it was the start of a nuclear winter. Even though it wasn't nuclear weapons that caused it, the effect was the same. The massive amount of debris in the air blocked the sunlight for months, maybe even years. Earth suddenly became a cold, dark place, and the dinos weren't ready for it. As temperatures plummeted and fires released enormous amounts of greenhouse gases, the climate changed dramatically. Plants weren't able to perform photosynthesis, and most of them started to die out. This disrupted the food chain and starved many of the animals that survived the impact. And remember the acid rain? It lasted for several years, causing more devastation to the ecosystems. The oceans became too acidic for marine life. Most ocean species didn't have the time to adapt to such a drastic change. These prolonged harsh conditions, together with the initial blast, pushed about 75% of Earth's life to extinction. The good news is that this included the horrifying T-Rex. Yeah, as much as I feel bad for this guy, I'm happy he's not running around today. When the last of the dinosaurs breathed their last breath, Earth became an empty, devastated place, cold and acidic. So when did things get back to normal? Yeah, well, here's the thing. They didn't. Not dinosaur-era normal, anyway. Earth didn't rebuild after that. It reinvented itself. 1,000 years later, the planet was recovering from the post-apocalyptic winter. It was still cold and food was still scarce, but life was ready to make a comeback. In this new wild world, a few furry little critters were sprinting around. Among the first plants to reappear after the impact were ferns. They really hit it off well after the disaster. 100,000 years later, Earth began to get a little more lively. Creatures about the size of raccoons were repopulating the continents. And the oceans were once again teeming with life. Fast forward about 10 million years, and Earth had finally restored its biodiversity. Only it wasn't the same Earth as it used to be. Now it was the age of mammals. Yeah, after the dinosaurs checked out, mammals were on fire. Yeah, not literally, of course. Mammals, together with birds and flowering plants, were rocking the planet. Yeah, Earth never got back to its old self. After the last dinosaur died, it took our planet millions of years to bounce back in a new way. But don't get me wrong, this world was still pretty terrifying. It had beasts like Paraceratherium roaming the land and megalodons raining terror in the oceans. Yeah, it's really for the best that most of these creatures aren't around these days. You wouldn't want to face a meg when you're out there swimming in the ocean. 1 billion years into the future, you might imagine a world full of artificial intelligence, interstellar travel, and space colonies. Maybe we'll see the end of poverty and hunger. A society where we're all truly equal. Well, these are all incredible scenarios that may happen one day, but let's take a step back from our usual human-centric approach of looking at the future. Instead, let's keep our feet firmly grounded right here on Earth. Well, sort of grounded. Let's hop in our time machine and let's explore all the ways Earth will evolve in the next billion years. The Earth is already 4.5 billion years old, and as you probably know, a ton of stuff has happened in that time. Just 250 million years ago, dinosaurs ruled the planet. Think they'll make a big comeback in the future? Let's find out. 100 years. You'd be surprised by how much things would have already changed just a century from now. Well, maybe you shouldn't be totally shocked, because even now the effects of global warming are very real. Just how dramatically the climate changes in the next century will depend on what steps humanity takes to curb its effects, but you should certainly anticipate that temperatures around the globe will get, well, warmer. The biggest impact this will have is on sea levels, which, as you know, are already on the rise. You'll see them climb higher and higher, threatening many of the world's coastal cities. Bangkok, Miami, Venice, and many more around the globe could all be heavily submerged by 2124. This would force humanity to redraw the world map. But more devastatingly, rising sea levels would displace hundreds of millions of people worldwide. This would lead to chaos, causing political crises and societal transformations. Plenty of animal species would be forced to migrate or face extinction. The major ecological shifts happening around Earth could permanently transform entire ecosystems. Now, beyond the melting polar ice caps, higher temperatures and changes in rainfall would alter rainforests into something we don't recognize. Heat-tolerant plants, insects, and small mammals would probably survive, but we'd lose many iconic species. Say goodbye to jaguars and orangutans. Couple all these disasters with an increase in the number of hurricanes, and we're looking at a very different world. 1,000 years. Okay, let's fast forward a millennium. Earth would still be getting hotter, and the effects of global warming would be even more pronounced. But several other forces would erupt to change our planet. Literally. At this point in the future, several major volcanoes could awaken from their long sleep. Let's take a look at the supervolcano located in Yellowstone National Park. Or rather, the volcano that is Yellowstone National Park. When this thing blows, it could produce an eruption as big as volcanic eruptions can be. And it wouldn't just affect the immediate area or the western region of North America. No, this one is going to impact the whole globe. Massive amounts of gas and ash will be ejected into the atmosphere, blocking out sunlight in the sky. Earth will effectively enter a volcanic winter. This will have devastating effects on the lives of different species around the world. Entire populations of animals and humans will face extinction. It'll also heavily affect our planet's agriculture systems. Plants would be starved of light and covered in volcanic ash, forcing most of them to die. But this may not be an entirely bad thing. A volcanic winter like this could help cool down the planet. Hey, do you have an iPad? Well, if so, you probably use it to take notes on, or maybe even draw with, and I bet you hate how the iPad pen feels on the glass screen. Well, luckily, I found a solution for you. With the sponsor of today's video, Swiss Paperlike, that all changes. It's a screen protector that makes your iPad feel like you're writing on paper. The secret sauce is this nano dot layer that's spread across the surface. It's made with Swiss-based manufacturing, and it's what provides that signature feel of pen-to-paper resistance, making it easier to take notes. And now, it's more transparent than ever before, while also reducing light reflection. So if you're taking notes or drawing on your iPad, well, the Paperlike 2.1 is for you. So go check it out in the link in the description and get yourself one of these to make your iPad experience even better. And not only that, but each click we get will help out the channel. So go check it out. 10,000 years. Welcome to a completely new era of Earth's geological history. 10,000 years into the future, our landscapes and coastlines could be reshaped with new mountain ranges and large inland seas. This would be thanks to the eruptions of more large supervolcanoes, mega-earthquakes, and, in general, the constant shifting of our planet's tectonic plates. It would almost seem as if Earth is slowly sculpting itself into a new form. Geographically, we might experience as much change as when Earth formed into Pangaea. And even without thinking about where humans fit into this changing planet, much of the evidence of our existence would be buried under layers of rock and ice. If you or alien archaeologists were to dig down, you'd find a clear record of our human impact on Earth embedded in the geological record. 100,000 years. Okay, jumping even further into the future, we'd only be a decimal point on the way toward 1 billion years, but by this time, Earth would have gone through at least one new ice age, maybe even a couple. These periods of global freezing and melting would continue to transform the landscapes we once knew so well. There'd be new rivers, seas, new emerging environments inhabited by new species of plants and animals that managed to adapt to all the changes over the last 100,000 years. Who knows what new species would be on top of the food chain? Even Earth's orbit could be different. This wouldn't necessarily be a dramatic change, but the pull of other celestial bodies like Jupiter might bring us slightly further away from the Sun than we are today. This would change our day and night cycles and the temperature on Earth. 1 million years. Okay, at this point, the big blue marble we once called home would be almost unrecognizable. For starters, the continents would no longer be where you thought they were. Hey, maybe Canada will finally get more than 2 months of summer. And what was formerly the continent of Africa might now be covered in snow. Within these new continents, new ecosystems would emerge, making way for new life forms, some of which might even be intelligent. There's no way of knowing exactly what these new dominant species would look like, but it's likely that whatever they are, they'd be perfectly tailored to the environment. If the Earth were a giant rocky ball of magma, they would have evolved to withstand that. Or if it were a watery planet, they'd have gills to breathe underwater. Humanity at this point might be looked at like the dinosaurs, a fascinating species that once ruled the world but ultimately went extinct. 1 billion years. Okay, finally, you've arrived at your destination, even if you didn't travel very far from where you began. Except for the 1 billion years of history you've witnessed, of course. Earth, 1 billion years into the future, would be unrecognizable to you. By now, the sun would be about 10% brighter than you remembered it, and this would mean that temperatures around the planet would be soaring. Earth would be a completely barren, desert-like world, without any of the oceans that used to cover a majority of it. Any sign of life would have to be resilient enough to live deep underground. Hopefully, humans or any other intelligent species have left Earth and started populating other celestial bodies. If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes? Or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated? Or would it have become one giant water world? Okay, now what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? This is What If. And here's what would happen if you traveled 1 billion years into the future. Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? Well, let's take a look into the future and find out. just under 10,000 years from now, we're going to run into a big problem called the Deca-millennium bug. In the year 10,000 AD, software encoding the AD calendar year won't encode dates with more than 4 decimals. Remember Y2K? Yeah, it's just like that, except hopefully we won't panic as much this time around. On the bright side, in 10,000 years, genetic differences and traits between humans will no longer be regional. Traits like skin and hair color will be evenly distributed around the world. Maybe that will help us all get along. Finally. 20,000 years into the future, none of the current languages will be recognizable. Future languages will only contain 1% of the core vocabulary words of their present-day counterparts. 50,000 years from now will mark a new glacial period for the Earth, which will start a new ice age. Niagara Falls will have eroded into Lake Erie completely. And, interestingly, a full day on Earth will also increase by 1 second at this point in time. So much more time for activities. In 250,000 years, the Loihi volcano will rise above the water to form a new island in Hawaii. And in 500,000 years, it's likely that an asteroid with a diameter greater than 1 kilometer will hit Earth, unless we can prevent it. The resulting crater will be no less than 400 kilometers across. It will start fires all over the planet and make the air unbreathable. So there's something to look forward to. And in case that's not enough, in 1 million years, we'll likely have another supervolcano eruption, large enough to spew out 3,200 cubic kilometers of ash. It would produce enough lava to fill 75% of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago. Oh, and the nearby star Betelgeuse will have exploded into a supernova by this time, making it visible from Earth even during the daytime. In 2 million AD, humanity will have settlements throughout the solar system. This also means that if populations on different planets have remained separate, humans may have evolved into other species adapted to their specific world. In 10 million years, a huge part of Eastern Africa will break off, forming a new ocean basin. In 50 million years, Africa will collide with Eurasia, closing off the Mediterranean Sea, and a new mountain range will form between the two land masses. This mountain range may include a mountain taller than Mount Everest. Out in space, Mars will collide with its moon, resulting in it developing a ring system like Saturn's. In 60 million years, the Canadian and American Rockies will have eroded entirely. In 80 million years, all Hawaiian Islands will be below the water. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth, one that is 10 kilometers wide. In 250 million years, all of Earth's continents will be fused together like Pangea, except this time it will be called Pangea Ultima. But don't get too attached to it, because in 400 to 500 million years, Pangea Ultima will separate again. In 500 to 600 million years, a gamma ray burst will likely occur within 6,500 light years from Earth. If it strikes Earth, it could damage the ozone layer and trigger a mass extinction. 600 million years from now, the moon will be so far from Earth that
total solar eclipses will no longer be possible. And the sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. In 800 million years, carbon dioxide levels will drop dramatically and photosynthesis will no longer be possible. Free oxygen and ozone will disappear from the atmosphere, and complex life on Earth will die. And finally, in 1 billion years, the sun's luminosity will have increased by 10%, and the average temperature on Earth will be 47 degrees Celsius. Our atmosphere will feel like a damp greenhouse, and our oceans will evaporate, leaving just pockets of water at each of the poles. When you arrive here in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The human race will be gone, hopefully living its best life on some other far-off planet. Because of the intense heat, lack of water, and lack of breathable air, Earth will be uninhabitable. So you probably shouldn't stay too long.
Today, we're going to go on a journey 10 quintillion years into the future. A time where our universe will look and act completely different. Stars will have died out, black holes will form, Earth will be a distant memory. But what else will happen? Will humanity be able to survive this long? Before we get started, let's clear up how many years we're going into the future. What is 10 quintillion years anyway? Well, it's a 1 followed by 19 zeros. Yeah, it's pretty big. 10 billion billions. We can't even squeeze all those zeros onto your screen. But never mind that, we've got a lot of ground to cover. Let's start 1 billion years into the future, where something terrifying is happening. 1 billion years from today. In 1 billion years, Earth will look incredibly different. What was once our blue marble full of life is now a dull brown rock with no life to be seen. Changes to our sun have killed off all life on Earth. The sun has been growing hotter and hotter, about 1 degree more every 100 million years, and the surface temperature of Earth is now 47 degrees Celsius. That's 117 Fahrenheit. This increase in heat first disrupted the carbon cycle. Plants died off, and then animals shortly thereafter. There might have been a little bit of life left in our oceans, but then it got hotter and the water evaporated. What was once a beautiful planet, teeming with life, is now a dry, dead rock. But what about us humans? Well, hopefully we made it out of Earth and built colonies somewhere else in the galaxy before the sun decided to kill us. But you wouldn't catch us living on Mars. Even that would be too dangerous with this hotter sun. We humans would need to be living much farther away. We'd need to set up shop in other galaxies within the Milky Way. Hopefully, within 1 billion years, humans have developed an efficient system of populating habitable planets. By this time, a populated Mars would be a distant memory. But it's possible that the outer planets in our solar system, or their moons, might become habitable for us for a little while. There's also another possibility. There may be a subset of humans who live on in the form of pure artificial intelligence. People who have uploaded their consciousness into machines and live virtually forever. But the machines that host them, well, they'd need to be powered by something, somewhere, so physical humans would still be around to set up these colonies that will keep our virtual humans going. But this is just the start of where our future is headed. Let's hop back in your time machine and go forward another few billion years. 10 billion years. Time for your next stop. 10 billion years into the future. As you're flying in your time machine, you notice that the solar system looks very, very different. The sun is now smaller. It's about the size of Earth. It's also white and much dimmer than before. Well, over the last 9 billion years, the sun burned all the hydrogen in its core. As its shell started burning, it became a red giant. Finally, with all of its fuel burned up and with it reaching an older stage in its life as a star, it became a white dwarf. That's what you're seeing now. During its red giant phase, the enormous energy given off by the sun caused its outer layers to expand, engulfing Mercury and probably Venus too. It looks like the Earth has been vaporized and is stripped down to its iron core. At this point, the sun will cool off for billions of years before it reaches its next stage, a black dwarf. More on that in a minute. As the sun was getting older and dying out, another big event was also happening. 2 massive galaxies merged with each other, creating an entirely new galaxy. You've got the Milky Way galaxy, which is the one we live in, and then our neighboring galaxy, Andromeda. Both galaxies are part of a shared space neighborhood containing 50 galaxies. These are called the local group. And due to gravitational forces, some were moving closer together. The Andromeda galaxy moved toward the Milky Way at 400 million kilometers per hour. If you stood in the middle as they merged, you'd probably feel like you were in the middle of a giant snow globe that had been shaken violently. Except instead of fluffy snow being thrown around, it's rocks, planets, and entire stars. This went on for millions of years. When these 2 galaxies were finally merged, they created what's known as the Milkomeda galaxy. Would stars have collided during this merger? Well, you might think so, but probably not because of the vast distances between them. They're really far apart. We're talking hundreds of billions of kilometers. But what would happen to our solar system in this merger? Well, scientists have calculated that there's a 50% chance our solar system would be pushed far away from the galactic core, 3 times further away from where we are today. And there's a 12% chance our solar system would be completely ejected from this new galaxy. But by that point, we humans would no longer be living in our solar system. If we were still around, we'd have populated planets in a galaxy far, far away, and we'd definitely choose one that wasn't about to go through a merger. So say goodbye to the Milky Way galaxy and say hello to Milkomeda. All right, now it's time to check in and see what else is happening in our universe. 22 billion years. In 22 billion years, things start to get a little complicated. Something is going to happen that's known as the Big Rip. According to one theory, we're heading to a point in about 20 billion years where the universe is going to tear itself apart. This will be due to dark energy. Yeah, dark energy. Now, that's something physicists don't even completely understand, but they do know one thing. It's causing the universe to expand faster and faster. Keep this dark energy in mind, as we'll come back to it later. Now, if the Big Rip happens, galaxies that exist today in clusters will begin to stretch apart, and then all the objects within these galaxies will move away from each other. Star systems, planets, everything will accelerate away from one another. Right down to their atoms, which would rip apart and dissolve, leading to the end of the universe. Scientists have found some evidence that we could be heading toward this demise, but it's not 100% certain. Good, I was getting a little nervous there. Okay, so for now, let's assume that our universe doesn't rip apart 20 billion years from now. What happens next? 100 trillion years from today. Even though the Big Rip may not happen, that doesn't mean our universe will be safe. Over these 100 trillion years, stars all across the universe will be dying out. Let's go back for a second to the Big Bang, when the universe began to form. 150 million years after that, stars were created. Now, since the formation of that first star to where you are now, new stars have been and still are forming all the time. The best way to see this is if you peer into these clouds of interstellar hydrogen gas that are everywhere in space. If you look at a dense area, you can see how it collapses in on itself and leads to the formation of a star. Over the 100 trillion years, you'll notice that stars are forming in all different sizes. The basic rule is the smaller the star, the longer it lives. Look at this star, which is just 8% the mass of our sun. It's just a little too small to get hydrogen fusion going, so it's a failed star, also known as a brown dwarf. And here's a bigger one, about 10 times as massive as our sun. It burns hotter and it's blasting through its fuel very quickly, so in about 20 million years, it'll die out. And you already saw how our sun died after about 10 billion years, but the majority of stars you've seen are smaller than our sun. These are red dwarfs. They're about 8% to 50% the mass of our sun. They're a lot dimmer, but they also live longer, about 80 to 100 billion years. So during this time, you'll start to see a lot of these red dwarfs starting to die out. Then we've got the brown dwarfs. These are so dim that they're hard for you to see. They die in a mellow kind of way, getting cooler and cooler. As they cool, their temperature will drop to about 2,500 degrees Celsius, which is cooler than most stars. Finally, let's check out the end of this incredibly massive star. It's 8 times the size of our sun. Its core is collapsing into a massive explosion that creates a supernova. This gives rise to a neutron star, which is an incredibly dense and compact star. Or its death could result in a black hole. Over these 100 trillion years, you've just witnessed the stelliferous era. You've seen stars being born and dying, planets coming and going, and the merging of galaxies. Well, there's also another incredibly important thing that's been happening as our stars have been dying. You see, when stars die, they release various elements and materials out into space. This often leads to new stars forming, but not all the mass of a dying star gets released and available for new star formation. Because of this, the universe will slowly run out of raw materials in the form of hydrogen gas to make new stars. Could this spell the end of the universe? 10 quintillion years. Okay, welcome to your final stop, or almost final. It's 10 quintillion years into the future. Remember, that's 1 followed by 19 zeros. The stelliferous era has ended, and we're in the early part of a new time called the degenerate era. And no, that's not when a bunch of Redditors take over the universe. As you fly through the universe, it appears much dimmer than it did before. Once twinkling with bright stars, it's now a graveyard. This is a universe littered with the remnants of dead stars. White dwarfs, brown dwarfs, neutron stars, black holes. All the stars that have ever been born have given up their light and died. So, if star formation is over, what happens to humans? Even if we're living in other galaxies, we still need a solar system and a viable planet to live on. Well, one possibility is that we've given up our material bodies and we're existing entirely in the form of energy. Oh, that's cool. But there's another possibility involving a whole new universe. More on that in a second, but back to the degenerate era. Keep your eyes open for rare collisions between remnants stirring things up in the universe. Like if 2 brown dwarfs collide, it might give birth to a new star that lives for trillions of years. Or if 2 white dwarfs collide, you could see a supernova explosion. But overall, the universe is becoming cooler and darker. Matter and its tiniest building blocks continue to decay. All right, that's our 10 quintillion years. Pretty crazy, but what happens after that? What happens at the end of the universe? 10 decillion years. Okay, at 10 decillion years, that's a 1 followed by 34 zeros. You're close to the end of the degenerate era. White dwarfs, brown dwarfs, even neutron stars will begin to die. Their death will come about because of a process called proton decay, where the tiniest subatomic particles that they're made of begin to disintegrate and die themselves. These white dwarfs will no longer be giving off an immense amount of light. Instead, they'll have the brightness of just a few light bulbs. The time it takes for this decay to be completed is incredibly long, but hey, on this journey, we've got all the time in the world. Or maybe I should say in the universe. It's sad to see these little protons die out. Well, you couldn't really see them dying because they're so tiny, but still. If the fundamental building blocks of molecules ultimately decay, it would appear that the fate of the universe is sealed. With protons disintegrating, on your last stop, you'll confront an old, unstoppable enemy. 10 duodecillion years. You're at 10 duodecillion years in the future. That's a 1 followed by 40 zeros. A lot of zeros, right? You've climbed another rung in the desolate universe. Things just keep getting bleaker and bleaker. No planets, no stars, no dwarfs. No wonder it's so dark. You can barely see anything other than a very, very weak shine. These are the black holes. It's no surprise that some scientists have labeled this time the beginning of the black hole era. Black holes are these massive structures in the universe that suck up anything that gets close to them. Not even light can escape a black hole. They're like some kind of planetary zombie, scarfing up the remnants of dead stars and getting more and more dense and massive. You thought Thanos was bad. Did I mention that nothing escapes a black hole? Yeah, well, nothing can escape a black hole. Well, there is one thing that can escape. It's been proposed that black holes might leak tiny bits of radiation. This is known as Hawking radiation. Here's how it works. Twin particles are appearing in space all the time, immediately annihilating each other, but when they appear at the mouth of a black hole, sometimes one falls into the black hole while the other escapes. Over trillions of years, this particle leakage would reduce the mass of the black hole, causing it to die. So if you did multiple stops in the time machine, you could watch these black holes eventually die out over massively long periods of time. All right, looks like there's still some time left in the video, so let's check out what happens next. Google years and beyond. All right, before we get to our last stop, for real this time, I gotta mention the What If Explorers Club over on Patreon. For just a couple bucks a month, you can get exclusive ad-free videos. Check it out in the description. Okay, a Google years into the future. What is that? That's a 1 followed by 100 zeros. What's happening here? Well, even the last black hole in the universe has lost its last bit of mass and died out. Welcome to the dark era. It's cold, dark, and very quiet. What can you see in our universe at this point? Well, only a few subatomic particles and dark energy. The universe has expanded so much that the few subatomic particles left are super spread out, incredibly far away from each other. At one point, there were stars, and then remnants of stars, then black holes. But now, you have to zip around in the time machine all over the area of our current universe to catch sight of a single subatomic particle. What a sad and lonely place. And remember the dark energy, the stuff that almost destroyed the universe during the Big Rip? Well, it will keep the universe expanding out further and further. And as the universe keeps expanding, it keeps cooling. Scientists have labeled this stage the Big Freeze. All energy will be evenly distributed in the universe, and the temperature will be just north of absolute zero. Yeah, very, very cold, but not as cold as winter in Canada. This theory of the universe has a cool, dark end, but there's another theory, though, called the Big Crunch. Instead of infinite expansion, the universe reaches a point where it switches into reverse and begins contracting. It would be like playing your life back to you in reverse when you got really old. You return to a baby, then to an embryo, then to a single cell. If that does play out, well, maybe then the whole cycle of the Big Bang starts up again a second time. Or maybe this has happened before and we're in the middle of one of the many cycles of expansion and contraction. Unfortunately, scientists think that's less likely. It appears more likely that the universe is in the grip of dark energy, which will lead to the big freeze at the end. What does this mean for the human race? Well, even putting aside the big freeze, things appear pretty bleak for life in the universe once we hit the degenerate era. Those damn Redditors. After all, we need bright, luminous stars to create habitable zones to live on planets. So, how do we make that a reality? Well, one intriguing possibility is the ability for us to build our own universe, maybe in a lab. Keep in mind, we're only 200 years past the Industrial Revolution. Centuries from now, humans will know a whole lot more about how to manipulate our environment. Using our smarts will take control of the future. In fact, as humans progress from a Type 1 to a Type 7 civilization, the possibilities are mind-boggling. Humans merging with AI, the ability to control the weather, reinstating extinct species. These are just a few of the things that will happen in the next 100 years. Hop in our time machine and get ready for a wild ride as we travel decade by decade, exploring what humanity will look like in terms of technology, space exploration, and more. 2025 to 2035. In just the next 10 years, we're going to see some incredible progress in terms of space travel. SpaceX will be sending humans to the moon. The first step will be an uncrewed demo mission, but soon after that, SpaceX will launch the Artemis mission, allowing humans to set foot on the moon once again. And if you're wondering about getting to Mars, well, that's going to take a little bit longer. Stick around and we'll tell you when. But what else is going to happen to Earth in this time frame? Well, we'll fight a deadly killer, pancreatic cancer, with a new vaccine. It's based in mRNA technology, the same technology we used for the COVID vaccine. The first step to fighting this cancer will be surgery, but the vaccine will help prevent it from coming back. Vaccination will drive the body to produce protective T cells. These will recognize any new cancer cells and wipe them out. Now, while we're saving lives from cancer, humans will still be facing threats from climate change. One casualty of our climate crisis will be Bangkok, a city of 10 million people. Unfortunately, its soft, loamy ground is sinking lower and lower, 10 centimeters a year. The pumping of groundwater is pulling the city down. Now, at the same time, global warming is causing the oceans to rise. This beautiful city will see a terrible and devastating flood within the next decade. In the most extreme scenario, 96% of the city would be below sea level by the year 2030. Maybe a barrier at the mouth of the Chao Phraya River would help a little, but flooding can't be held off forever. For cities that don't get flooded with water, well, they'll see a big shift on the roads. Self-driving cars will finally deliver on their promise to dominate in the next decade. Unfortunately, they'll probably be tied to a subscription service, so get ready to pay an extra $10 a month for car flicks. And if you do choose to drive your own car, it'll be kind of like a hobby, like flying a kite or something. But this is just the start of our future. We've got 90 more years to cover. Hop back in the time machine and let's head over to the next decade. 2035 to 2044. Okay, let's check in on how space exploration is progressing. We'll finally get to surf the hydrocarbon seas of Titan, Saturn's largest moon. We'll send a submarine into space, getting it to land on another moon and plunge into the ocean there. By studying Titan, we'll learn new and fascinating things about how life began on Earth. Titan has an internal liquid water ocean, which could contain the building blocks to alien or human life. It also has dunes that are rich in carbon and nitrogen compounds. Who knows what new life forms we might find out there? But that's not all. This is also the decade when we finally have a crew of humans landing on Mars. We'll get a better understanding on how to deal with the many challenges of this mission by around 2040. And we'll find solutions for all sorts of things we previously thought weren't doable. Things like how to minimize the effects of radiation during the trip to Mars and how to produce oxygen from the Martian atmosphere. We'll also solve the problem of having fresh food and water on the planet. Not to mention, we'd be building pressurized, radiation-resistant shelters that will allow us to live on the red planet. And it's a good thing we'll be further along in our exploration of other worlds too, because things might be getting a little too hot to handle here on Earth. By 2035, our planet will be 1.5 degrees Celsius warmer. Lemurs will be going extinct, and those cute koalas in Australia, say goodbye to them too. Extreme heat waves will be common in the US. Worse than that, high-intensity hurricane winds are breaking and redefining the hurricane scale. Category 6 hurricanes with sustained winds over 125 kilometers per second may be pretty infrequent today. We've only seen 5 of these since 2013, but in 20 years, they'll hit the Gulf Coast cities so frequently that people will start emptying out of the coastal cities. Goodbye Houston, Galveston, Baton Rouge. Now, weather won't be the only thing that's changing. Our demographics will be shifting too. By around 2044, white people will be a minority population in the US. And if your reaction to this is, meh, so what? Well, you're in good company. A majority of Americans feel this is neither a good nor a bad thing for society. 2045 to 2054. Climate news will get worse during the 10 years between 2045 and 2055. Temperatures will be 2 degrees Celsius above pre-industrial levels. That's a lot. This will have important consequences for the trillion-odd species on Earth right now. Many will be victims of the 6th extinction event. In this decade, 40 to 50% of our current species could go extinct. Among them are the African forest elephants, Amur leopards, and the Yangtze finless dolphins. Populations of these creatures are already dwindling today, so unless there's a drastic change in our warming climate, poaching, and forest loss, well, animals like these are on their way out. The Dead Sea, a unique natural phenomenon with a salt content 10 times higher than the oceans, is also at risk. Sadly, these salty waters will slowly evaporate due to the immense heat. Currently, in the Dead Sea, evaporation is causing water levels to drop an incredible 1.2 meters each year. During this decade, we'll finally kiss it goodbye. Now, with the devastating effects of global warming, there will be more pressure to innovate. We'll see a major new development in energy, one that will crack the code to commercializing fusion power. This is the process that smashes 2 hydrogen atoms together to form helium, and in the process, release a lot of energy. Today, we don't know how to do this cheaply, but 20 years down the line, we'll figure out how to get the cost down. This will be the beginning of the end of carbon emissions. Something else we emitted into the air decades ago might also finally have an update. In 1999, Ukraine sent a message named Cosmic Call 1 into space. In 2051, this message will reach its destination, Gliese 777, a yellow subgiant star 52 light years away. Maybe we'll get a call back from the aliens on their iPhone 6751. 2055 to 2064. In 2058, the Beatles' music catalog will enter the public domain. I'd play some of it for you right now, but we get a copyright strike. But not 50 years from now. Also in this decade, we'll have established a permanent presence on Mars. Probably not the colony of 1 million people that Elon Musk has projected, but definitely a base camp and the start of a Martian future. Back on Earth, we'll finally have umbrellas that don't get wet in the rain. Not super exciting at first glance, but it means we'll be masters of nanotechnology. We'll be able to incorporate tiny structures into fabrics, which do amazing things. In the umbrellas, we'll use what's called the lotus effect, where the nanoparticles repel water. Nanoparticles in our clothing could dissolve dirt and kill microbes, so we never have to wash our clothing either. I'd be happy if I never had to do laundry ever again, but forget about laundry. There's another thing we'll be rid of. By 2060, we'll eliminate coal and oil from our energy system. Solar and wind power will be widely incorporated into society, and we'll be making even bigger strides in fusion power. More on that in a minute. 2065 to 2074. Now, if you think nanotech clothing is pretty cool, well, in the next decade, we'll be mastering pico technology. This is 1,000 times smaller than nanotech. Scientists will be manipulating the energy states within electrons. This will change the structures and properties of individual atoms. From this, new types of matter will emerge. Who knows, maybe we'll be building entirely new kinds of chips or supercomputers using this new technology. Now, if you're watching this and you think you might have a hard time making it to 2065, well, you're in luck, because by this decade, technology in the medical field will have progressed so far that we'll be able to print new body parts in 3D. Yeah, we'll be rejuvenating ourselves with stem cells, and gene editing will be able to cure diseases. Through a combination of these and other methods, the medical field will be helping people live years, maybe decades longer. 2075 to 2084. Okay, by the late 2070s, the transition to clean energy will be complete. Humanity will be carbon neutral across the globe, and the last of natural gas power will be phased out. Electric cars will be everywhere. The gas vehicles we ride around in today will be considered vintage toys. And with the advances made in nanotechnology, our solar cells, which convert the sun's energy into electricity, will be super efficient. Now, technology will optimize our human bodies too. Artificial organs, bionic eyes and ears for supervision and hearing, and implants to enhance intelligence. Humans 2.0 will be vastly superior to what we are today. More intelligent, by design. This is the decade we'll also find a new way to launch ourselves into space. We'll look back at today and think, gosh, space rockets? That was so 2024. Instead, we'll have a space elevator. This will require a cable that runs from the ground up through the atmosphere all the way to a satellite that orbits in sync with the Earth's rotation. That cable will have to be made of some special material, maybe diamond nanothreads. 2085 to 2094. Now, despite our efforts to curb climate change, temperatures will keep rising due to the carbon dioxide that's already been baked into the atmosphere from prior decades. Many parts of the world won't have snow anymore. We might have to say goodbye to the Winter Olympics, skiing, and ice hockey. But that might be the least of our worries. With our ice continuing to melt, polar bears could face extinction. Their numbers will have already dropped by 70% between 2000 and 2050. The few remaining bears in the interior Arctic will be struggling to stay alive. But having figured out the de-extinction processes, we'll know how to bring the polar bears back in the future. We've already created embryos of some extinct animals using genome mapping and gene editing. In the next half century, scientists might figure out how to implant these embryos into closely related species, giving us a path out of extinction. For the first time in Earth's history, we may be able to turn back the clock. With global temperatures still rising, by 2090, Western Antarctica will be as warm as today's Alaska or Iceland. If we travel even further ahead in time, the new landscape would be unrecognizable. Many of the largest Antarctic ice sheets will have melted away, and human settlements will be on the rise, with new towns and urban infrastructure built on the Antarctic soil. 2095 to 2104. The landscape will also be different for the Atlantic Ocean. In the second half of the 21st century, a vast network of wind farms will be springing up in this part of the world. By the end of the century, they'll transform our methods of power generation. But they'll have another interesting capability, allowing us to control and moderate the weather. Even as hurricanes intensify and break all records, wind turbines can absorb the energy, reducing hurricanes from a level 5 to a level 1. Some of the Gulf cities that emptied out may start to repopulate. Over 80% of the Amazon rainforest will disappear by the end of the century. Logging, fires, farming, and industry will destroy this valuable resource. As a result, many plant and animal species that lived in these forests will have gone extinct, and indigenous peoples who made their home here may be wiped out. Rapid globalization and interconnectedness will also cause the extinction of our languages. In the late 20th century, there were over 7,000 languages worldwide, but by the time we get to the year 2100, we'll be down to just 3 languages: English, Mandarin, and Spanish. 2105 to 2115. Okay, if you're able to live until the 2100s, genetic engineering will be able to transform your body in new and unusual ways. Early in the 22nd century, we might be incorporating a key element of plants into our human cells, giving some of us fantastic new capabilities. Which element? Chloroplasts, where photosynthesis takes place. This would enable us to take in the sun's energy and carbon dioxide to produce our own sugars. It'll be a whole new way of feeding ourselves. And humans could also find a way to live forever. The technology to upload our minds, including our complete memories, into a computer will be perfected. The world might divide into those who want to live forever inside a computer and those who don't. 2115 to 2124. By the dawn of the 22nd century, AI will be an integral part of all society. Humans merged with AI will possess vastly superior cognitive capabilities. These human-AI hybrids will combine the emotional intelligence of humans with the intellectual and analytical superpowers of AI. This could create wars between humans who have merged with AI and those who have not. We'll now have permanent settlements on the Moon and Mars. We'll have explored the outer reaches of our solar system, sending missions to the gas giants, the Kuiper Belt, and beyond. We'll be mining asteroids for minerals and metals. Couples getting married will argue about whether the destination wedding will take place on the Moon or on the Red Planet. Well, maybe they'll marry on one and honeymoon on the other. The next 100 years will see terrible lows and amazing highs. With massive climactic shifts, Earth will transform, cities will be underwater, and many species will go extinct. Even as this is happening, humans will merge with AI to become exceptional transhuman beings. We'll conquer space. Eventually, we'll become carbon neutral and then find ways to tame the weather. And in the distant future, we'll apply our intelligence to repopulate the Earth with the species we wiped out. If you're young, buckle up. The next 100 years are going to be a wild and amazing ride. But forget flat Earth. Let me introduce you to Earth shaped like a pizza. It might look delicious, but it would be a scorching, violent, breathtaking place. Would you dare to live there? There could be anywhere from 10 sextillion to 1 septillion exoplanets in the observable universe, and approximately 0 of those are shaped like a flat planetary pizza. It's gravitationally impossible for a planet to form in a shape like this, because when planets form, they tend to clump all the rock and dust around them evenly in all directions. The most oddly shaped exoplanet scientists have discovered is in the shape of an egg. This exoplanet is called WASP-12b, and it orbits a distant star some 1,200 light years away from us. Now, the reason WASP-12b is shaped this way is due to an overbearing proximity to its star. Yeah, WASP's star pulls on the planet with its enormous gravity, stretching it in the process. But flat planets? Well, if they do exist, we haven't found one yet. But hey, this is what if anything is possible. Even Earth shaped like a mouth-watering pepperoni-covered pie. A pizza-shaped Earth wouldn't be much different from a flat Earth. It would have continents scattered around like pizza toppings and a crust of mountains around its edge. This is making me hungry. If this slice of planetary pie is anything like what the flat earthers consider a flat Earth to be, a pizza-shaped Earth would be in for a wild ride. Yeah, flat earthers don't believe in gravity. They believe in universal acceleration. They think that all planets constantly accelerate upward through space at 9.8 meters per second squared. That means that every second, our flavorful pizza-shaped Earth would move faster and faster. It would start at 9.8 meters per second, and then the next second, it would move at 19.6 meters per second, then at 29.4 meters per second, and so on. This acceleration would be like a new gravity, preventing everything on its surface from flying away into space. But there's a problem. Pizza-shaped or not, Earth is 4.5 billion years old, and that's a lot of seconds. After 4.5 billion years of constant acceleration, the pizza-shaped Earth would move at about this speed. Yeah, that is 4.63 billion times faster than the speed of light. Let that number sink in for a moment. And moving on. Not only does that violate the laws of physics, require infinite energy, and shred this pie-shaped Earth into atoms, but it would also break space-time itself. But hey, this might be one way to invent time travel. Luckily for you down on Earth, it wouldn't mean instant death. As soon as Earth approached the speed of light, time dilation would kick in. For you and everyone else on Earth, time would come to stand. You'd be trapped in one moment forever and ever. But all of this is physically impossible. Gravity is real. And as far as real science goes, well, let's just say things would get out of hand quickly. If we take a look at the entire pizza Earth, the center of gravity would be right here in the middle. At this point, gravity would feel like a regular Earth's gravity. But further from this center, gravity would start pulling you sideways and downward at the same time. At the edge of this Earth pizza, it would pull on you almost horizontally. Then it would get weaker and weaker closer to the crust. Now, you could jump a lot higher and scale those mountains at the edge more easily due to the weaker gravity. It'd kind of feel like you're in a Dune movie. Sand everywhere. Gravity would pull all of Earth's oceans closer to the center. This would be the best place to live on a pizza-shaped Earth because it would pretty much be like living on a regular sphere-shaped Earth. The oceans would regulate the climate around this area. It'd be pretty balmy. And around the edges, it would be mostly rivers, lakes, and severe dust storms. Yeah, the further from the center of this hot mess of a pie you get, the weather would get incredibly worse. As the winds are pulled inward to the center, they would create constant storms. The edges of this pizza Earth would be cold and dry. Cold pizza. Excuse me. The atmosphere would be thinner here, so you'd have trouble catching your breath. Living on the edge of this pizza Earth wouldn't be much different from living on Mars. I don't know why you would want to settle there, but if you did, you'd have to build a reinforced, tilted house to account for the change in gravity. Another option would be a semi-underground home. Or, if you want to get futuristic, maybe build a geodesic dome like this one. Either way, your home would need to be able to withstand harsh weather conditions, like dust storms and extreme temperatures, while you'd have to adjust to living without a sufficient breathable atmosphere. Yikes, not fun. Now, if Earth was shaped like a slice of pizza rather than the whole pie, well, the gravity would pull towards its center right here. This planetary slice would need to be thicker to maintain some geological stability. If the pizza Earth was too thin, it would lose its magnetic field and all its atmosphere, all the while collapsing under its own weight. Now, in order to stand a chance on this delicious Earth, you'd really need the magnetic field. Without it, you'd get cooked by extreme solar radiation. You'd also suffocate because a magnetic field holds a planet's atmosphere in place, and that includes your oxygen. Now, to keep a proper internal structure with a magnetic field and a breathable atmosphere, well, this slice of a planet would need to be at least 6,000 kilometers thick. That's about half as wide as our round Earth. And even then, you still might get cooked. That is, if you believe the flat Earth theories. All because, according to the flat earthers, the sun wouldn't be like the big old star we know and love. On this pizza Earth, the sun would be tiny and hang much closer to the surface. It would be so bright and so close that it would be emitting immense amounts of solar radiation. Now, this would create hotspots directly beneath the star. If you think summers are hot now, well, on this pizza Earth, it would be literally hell. At night, things would cool off a little, but as soon as the first rays of sunshine hit your face in the morning, well, you better be wearing a fire protection suit. But that's if our cosmic pie was more like a flat Earth, which we know is not physically possible. Sorry, flat earthers, sorry. Here's a more realistic take on the pizza Earth. It would still orbit the sun, and as it would rotate on its axis, all of this would create seasons and a day-night cycle, so you'd be all good there. And the moon would revolve around this pizza Earth, keeping the tidal forces in check. It really doesn't sound so bad until you start thinking about climate. Just like on a whole pizza-shaped Earth, the center area on a pizza slice Earth would have a mild climate, as all the oceans would be pulled there. Now, closer to the edges, gravity would get weaker, and the atmosphere would get thinner, and the land would get drier, and this would be an area of extreme dust storms and harsh temperatures. And since the middle of this new Earth would be covered in ocean, you'd be forced to live on the continents scattered around the edges, unless you want to live underwater. Life on this Earth wouldn't be anything like what it used to be. Imagine a world where the cities we know are underwater, and what used to be the ocean is now a barren wasteland. This is a world where every bit of water and land have suddenly switched places. Cities like New York and Paris would find themselves underwater. Tsunamis would come rushing into the cities, destroying everything. And if you're on a boat, you'd find yourself falling down into a dry ocean bed. The Amazon rainforest would be flooded and ancient diseases would come back to life. Which species of animals and plants would fare the best? Is there any way humans could survive this? And what would our new Earth look like? This is What If, and here's what would happen if water and land suddenly switched places. One of the more unexpected changes we'd see in this scenario would be significant climate change. This would be because of changing weather patterns and changing ocean currents. And because this dramatic change is happening overnight, we won't have time to prepare for it. But what if we knew this massive switch was coming ahead of time? Would there be anything we could do to stop it? Well, to answer that, let's take a look at our own climate issues that we're dealing with here on Earth right now. Climate change is causing global sea levels to rise at an alarming rate, leaving some of the world's biggest cities like London and Bangkok facing significant threats within a few decades if we don't do anything to stop it. With this much advance notice, well, you'd think everyone would be taking action to prevent this grim future, but as we all know, that's not the case. Some people won't believe or care about climate change until they're faced with an extreme situation like the one we're talking about today. But many people do want to help and make a difference. They just don't know how. Well, I might have just the solution. Say hello to Solar Slice, the startup company making it easy for you to make a real difference in the fight against climate change. SolarSlice lets you directly fund large-scale solar farms. With their app, you can track your energy production and carbon savings and even earn rewards to further support other climate initiatives. Here's how it works. First, you sponsor a slice of their large-scale solar farm, adding 50 watts of clean energy to the grid and reducing harmful emissions. Then, you can use their app to track your impact with real-time data on your slice's energy production and carbon savings. You earn eco-points as your slices generate clean energy, points you can use to buy more slices, plant more trees, or fund more meaningful initiatives. And if you want to expand your impact even further, you can share your progress with others, create group initiatives with friends, or send solar slices as eco-conscious gifts. To learn more, visit solarslice.com. You'll find a link to their Kickstarter campaign, which will help fund the construction of their first solar farm and development of their app. With the help of SolarSlice, we've got a chance to prevent a future where our cities are swallowed by rising seas. The people in our story, on the other hand, might not be so lucky. Okay, it's safe to say that water and land switching places would be the start of a new mass extinction. Your cities, towns, and any bit of dry land are now covered with water. Water now covers 21% of the globe, and land covers the other 79%. That means we'll have new oceans. We've now got the North American Ocean, the South American Ocean, and the European, African, and Asian oceans, all connected by narrow channels of water. And a new super large continent. In cities, people might have to run into skyscrapers to save themselves from drowning. They'll be looking outside, wondering when the waters are going to recede. Unfortunately, the answer is never. Because in our new world, water is here to stay on the old land. In this scenario, there would be two kinds of unlucky people. First, the ones who were outside on dry land and couldn't swim, they would have drowned immediately. The second group are the ones who lived far away from any kind of water, because now they'd be surrounded by water with no ability to get to land, unless they had a boat stored somewhere. Maybe you'd be one of the lucky ones. If you lived in a coastal city, say like New York, the Hudson River would now be bone dry. Maybe you'd grab a tire inner tube and put on your swimsuit and a backpack and swim out to the dry riverbed. Now, what about the animals? Well, unfortunately, marine life would be toast, or soggy toast. If all the water suddenly disappeared from lakes, and rivers, and oceans, fish would be left gasping for air and would die almost instantly. Riverbeds and dried up oceans would be piled up with the carcasses of dead marine animals. No more whales, sharks, or any kind of fish. Say goodbye to sushi. Now, on the bright side, looking at this new world of ocean floors might be a fascinating experience. After all, maps of oceans here on Earth are less detailed than maps we've made of Mars. Scientists find 2,300 new ocean species every year. If we didn't have the water to stop us, we'd find hundreds of thousands of new species. Unfortunately, they'd all be dead. And animals in forests might have it even worse. Instead of a swift death, they might be left to suffer. Big cats like tigers and lions forced to climb up into trees. They might find themselves sharing the canopy with apes. Other animals like zebras and giraffes would be carried away by the current and drown. So some of our land animals would survive and others would go extinct. But regardless of who makes it out alive, ecosystems would be savagely altered. But there are two species that would do particularly well in this scenario. The first are reptiles. Crocodiles, turtles, alligators, they're used to living on both water and land. And as they generally hang out in water close to land, well, they won't have to crawl far to find a new habitat. It'll be right next door. The second group that'll do great is insects. 66 million years ago, when the Chicxulub impactor hit Earth and the planet was full of dead, decaying matter, insects had a feast. Count on a repeat of that scenario as insects jump on anything that's rotting. The bad news? Well, with swarms of mosquitoes, diseases like malaria are likely to break out among humans. Now, besides insects swarming everywhere, the other major problem in our new switched world? Well, there's no electricity. With power plants submerged in water, there will be damage to electrical circuits that can't be repaired. Because the water's not going away, for the first time, you realize how dependent you are on energy. Heck, your 13th floor toilet won't flush anymore because water is pumped up to it using electricity. There's no television, and of course there's no internet. Many of the world's population would be gone from this catastrophe, but there is a lucky set of humans who survive this horror. They are the 40% of the world's population who live in coastal cities, or they might live next to a lake, which is now an island. They've somehow lived through the initial tsunami. Their land is now water, but they can make their way to safety. On the California coast, they scramble onto the new shore of Pacifica, the old Pacific Ocean. From New York, they doggy paddle to Atlantica, the old Atlantic Ocean. To get the world back to normal, everything will have to be built from the ground up. Homes, agriculture, transportation, the list is endless and challenging. Building any kind of new home will be hard without materials like wood or cement. But there is one thing we could use: trash. Yeah, it's estimated that there are over 5 trillion pieces of trash in our oceans. Once the water leaves the oceans, humans could get resourceful and use the leftover garbage to make structures to live in. Kinda gross, yeah, I know, but at least it's been washed. Most land plants now will be submerged in water and will die, which means no access to fresh fruits and vegetables. Without vitamin C, scurvy, the disease sailors used to get, will increase. What is available is huge amounts of fish that have just died. Now, smart foodies will get to work. They dry and salt the fish to preserve it for the future. Pickling will be the new trend. Access to fresh water will be very limited. The humans who survive will be in for a punishing time. Now, in the medium term, the big challenge for humans will come from a shift in our climate. Our vast oceans play a key role in moderating our temperature today. As they shrink to a quarter of the area they once were, Earth will get much, much hotter. Water absorbs a large amount of heat, but with the total water area reduced to 21% of Earth's surface, oceans won't absorb as much energy from the sun as they do today. There will also be less water to absorb carbon dioxide. With oceans absorbing less heat and with more carbon dioxide in our atmosphere, Earth will get pretty toasty. Also, today's ocean currents are able to distribute the heat that they absorb to different parts of the world. In this new geography, the paths these currents are able to take will have bottlenecks that will prevent the smooth flow of water. Look how narrow the new Latin American channel is. Less water surface also means less water vapor and less rainfall. In this new world, prepare yourself for dry, desert-like conditions. Your best chance for survival will be to live near the coast. Expensive coastal real estate, that's one thing that remains the same. Now, let's say an enterprising group of humans somehow survives this catastrophe. How will life evolve? Well, humans will become insect and reptile eaters, connoisseurs of pickled fish. But that'll be a tricky balance because with many of our previous weapons now lost underwater, hunting crocodiles won't be easy. And if humans wipe out the reptile population, that eliminates an important food source. Unfortunately, slower moving turtles will probably be quickly hunted into extinction. Reptiles that can retreat further into the new oceans, far away from humans, will have a better chance at survival. In general, smaller members of any surviving species will do better as they can get by with less food. Over millions of years, they'll evolve, and as Earth's food sources get reestablished, the species will become bigger again. Birds are also likely to survive, though with trees gone, nesting becomes a challenge. Maybe they'll build nests in the top floors of old skyscrapers. And don't forget, with the destruction of ocean plankton and all of our land-based plant life, over time, oxygen will settle at a new lower level equilibrium. Unless plants begin to grow again on both land and in water, This lower level of oxygen will cause all species to evolve in new ways. Mammals may have bigger red blood cells, bigger lungs, or smaller bodies to use their oxygen more efficiently. And insect sizes will decrease over time as less oxygen will be available to them. Now, of course, the big question is, will humans survive such a catastrophic event? Well, it's hard to say, but if we look back in time, human populations have rebounded from numbers as small as a few thousand, so yeah, it's possible. If humans do survive, we'll emerge stronger and hardier than ever before. We'll build a new civilization on what's now become a hot brown marble. Mars has been on a direct collision course with Earth for weeks now. The destruction has already started with massive tsunamis and earthquakes. Now, our planet is beginning to crack and gravity is significantly changing. But how bad will this be? How could it create a new planet? And is there any way humans could survive? This is What If, and here's what would happen if Earth collided with Mars. 15 days before impact. This won't be the first time Earth has had to deal with a massive collision. Over millions of years, asteroids have rained down on our planet. One of the biggest, the asteroid that wiped out the dinosaurs 66 million years ago. Now, despite its massive impact on Earth and our history, that asteroid was only 10 kilometers wide, about the size of 90 football fields. Mars, on the other hand, has a diameter of 6,800 kilometers, and it's coming straight at us. The red planet is normally about 225 kilometers away from us, but at this moment, it's just 4 million kilometers away. From this distance, it looks like a smaller red moon is approaching us. Now, just because it hasn't made impact yet, doesn't mean we won't be feeling any of its effects. The moon affects the Earth's tides, so what happens when another massive celestial body comes near our planet? Well, the gravitational force would be so strong that Earth's crust would start to bulge and our water would be rising. It could rise so violently that multiple tsunamis become a real possibility. More on that in a bit. 3 days before impact. Okay, now at just 800,000 kilometers away, Mars is twice as far away from Earth as the Moon is. Given its angle of approach to Earth, we'd be looking at a red half moon getting bigger and bigger by the minute. But the red planet is 10 times heavier than the Moon and is already tugging at everything on Earth with much greater force than the Moon could even dream of. It's creating havoc. At this point, tides are rising 30 to 50 meters high. Deep inside Earth, tectonic plates begin to shift and creak, but it's gonna get much worse. In 36 hours, Mars will reach the same distance away from Earth as the Moon. Then, the tides will rise 10 times higher than usual, 60 to 100 meters. Vast stretches of coastal areas and cities would be flooded. Say goodbye to Miami, Venice, and any other city near a large body of water. Millions of people will drown. There will be widespread panic as people on Earth see Mars's relentless approach. Earth is starting to crack. Earthquakes shake the globe. Volcanoes erupt, covering the surrounding landscape in hot, molten lava. People are running for underground bunkers, grabbing any power source available. Will they make it? Well, getting emergency assistance to one disaster site is challenging enough. Now, imagine trying to do that when you've got countless disaster sites, many in remote locations. And, oh yeah, most of the planet is without power because this incoming collision has wiped out our infrastructure. Fun times, right? Well, thankfully, before the big crash, some great minds were already cooking up a solution. One company called Nano Nuclear Technology has been developing these fantastic microreactors. These tiny powerhouses can produce between 1 and 20 megawatts of thermal energy that can be used as heat or converted to electricity. Microreactors can be deployed and removed quickly, making them perfect for emergencies. But here's where it gets even cooler. Nanonuclear isn't just developing any old microreactors. Hailing from Mount Olympus and Valhalla, their projects are Zeus and Odin. I guess when you're dealing with world-changing tech, you name them after Greek and Norse gods, right? Zeus, the solid core battery reactor, and Odin, the low-pressure coolant reactor, are the perfect duo to save us from this doomsday scenario. But we don't need to go to these extremes to see their benefits. You see, these microreactors are helping us tackle real crises today. Their small size and portability make them perfect for remote communities that lack access to the central power grid. Plus, they can help our fight against arguably our biggest crisis right now, climate change. Microreactors can significantly reduce emissions from electricity production by providing a zero-carbon alternative to coal, oil, and natural gas plants, ensuring a steady power supply without the intermittency issues of solar and wind energy. But nanonuclear energy isn't stopping there. They're thinking big by going small. They're working on becoming a vertically integrated company, covering everything from cutting-edge portable microreactor technology to nuclear fuel fabrication and transportation. Talk about covering all your bases. Now, if you want to learn more about how nanonuclear technology is changing the world and fighting climate change, well, check out nanonuclearenergy.com. But hey, maybe climate change isn't our biggest worry right now because we have another planet crashing into us. So let's get back to that, shall we? 4.6 billion years ago. Okay, wait a minute. Before we get into what happens next to Earth, how did we get here? What sent Mars hurtling toward us in the first place? Well, Mars could have been pushed out of its orbit by a rogue planet. This is a planet that exists without orbiting a star. There are billions of these kinds of planets roaming around our universe. They're sometimes hard to detect, though. Why? Well, because they don't give off a huge amount of light, and the light they do reflect is at wavelengths that are incredibly hard to detect. So, it's possible a rogue planet could have entered the solar system undetected, shoved Mars from its current orbit, and here we are. And like I said earlier, it's not the first time a planet the size of Mars has collided with Earth. About 4.5 billion years ago, just after the solar system formed, baby Earth and a Mars-sized planet crashed into each other. You can see it today. The debris from the collision eventually formed the Moon. At this point, people on Earth are in a frenzy, trying to find shelter from this terrifying catastrophe. But violent quakes shake the ground and toss people about. Tsunamis rage and millions of people are drowning. Wherever they can, people are running to underground shelters, hoping for some level of protection. Mars is just 10,000 kilometers away. The gravitational force of Mars and Earth are pulling at each other intensely. Mars is starting to pick up speed, reaching 10 kilometers per second. What's happening now is incredibly interesting. As it's making its way toward Earth, Mars is starting to crack. Why? Well, Earth has 10 times the mass of Mars, and because of this, our planet is exerting gravitational pressure on Mars, causing it to break. Now, there is a possibility that Mars crumbles entirely from this pressure. Maybe the people of Earth live to see another day, but unfortunately that's not likely to happen. Because Mars is moving so fast, there's not enough time for Earth to break the red planet apart. What happens next isn't going to be pretty. 20 seconds before impact. If you looked up now, Mars would be filling up nearly the whole sky. It's now just 200 kilometers above Earth's surface. It's entered the upper reaches of Earth's atmosphere. An enormous shock wave has hit the atmosphere. Due to this, you're finding it hard to breathe. Mars's gravity is pulling at our atmosphere. But that's nothing compared to what's coming next. cracks in the surface of the Earth will be widening, creating massive canyons. The biggest earthquakes ever don't hold a candle to this. Buildings crumble and entire cities will be reduced to rubble. If you're on Earth as this is happening, well, there's not much you can do. Just hold tight for what's about to happen. Moment of impact. As Mars makes contact with Earth's surface, gravity will be about 30% of what it usually is on the side of the Earth where the crash happens. That's because Mars's gravity is 40% of Earth's, and it's pulling in the opposite direction. Both planets' gravitational forces are now pulling at each other at the same time. But that's only on one side of the planet. On the other side of the world, people will actually be 3% lighter right before they die. Thanks, Mars. That's just when people want to lose weight. Now, at the moment of impact, a massive amount of heat is generated, the equivalent of billions of nuclear bombs exploding. After the initial collision, these two rocky planets briefly separate, but that doesn't mean the battle is over. They'll eventually come together again and re-collide. Now, with the amount of heat generated, both Earth and Mars will get liquefied. A shockwave will rock Earth, reverberating through the entire planet, all the way to the other side. Within 20 minutes, everyone on Earth would feel the impact. And everything on the surface of the planet will burn, creating a mass extinction that no living thing could survive. Earth's surface will crack open down to its core. Mars will have broken apart. Large pieces of Mars's core will embed themselves into Earth's core. The entire top layer of the planets will be molten lava, and our two mantles will be mixing together. The energy from the collision will change the speed of Earth's spin. We might spin faster or slower, we don't know. And molten debris from the crash gets ejected into the sky. Smaller bits will fall back to Earth as molten lava, while the larger pieces will start to orbit Earth, forming a ring. Some of the debris will collide with the Moon, and some will be ejected further into space, hitting Venus and the asteroid belt. Over millions of years, the debris collisions with the Moon will make the Moon bigger and heavier. After the collision, part of Mars will be incorporated into Earth. Earth will be slightly heavier. Now, since Mars is 10% of Earth's mass, well, maybe Earth would weigh about 5% more than before. But this new Earth will be devoid of life. Could life ever emerge again on what was once our blue marble? Well, without an atmosphere and without water, it's hard to see how this would happen. Maybe in the future, comets will crash into Earth delivering water, and over billions of years, life might begin again. But with the sun getting hotter and hotter, it's likely going to boil off that water within the next billion years. Prospects for new life on Earth don't look promising.
Yeah, right, let's shake things up a bit. Our solar system has been around for billions of years and is starting to get a little boring. So what if we shook up the positions of our planets? What if Jupiter was right next to the Sun? Or what if Earth switched places with Mars? Today, we're rearranging the planets in our solar system from largest to smallest, and then flipping them back to go smallest to largest. But how would this affect Earth? And would we have a new planet to call home? This is What If, and here's what would happen if the planets changed positions. Okay, first let's take a look at what would happen if the planets were laid out from largest to smallest, starting with the Sun. Well, this configuration has a big problem. But before we tell you what that is, let's look at how the individual planets would line up. Jupiter is the granddaddy of the solar system. It's more than twice as massive as all the other planets put together. It would move from its current position all the way to Mercury's spot, placing it less than 1/10 of its original distance from the Sun. Think that's a crazy idea? Well, astronomers studying exoplanets tell us that this is not so unusual. Other large gaseous planets orbiting very close to their stars have actually been named hot Jupiters.
Now, sitting in Mercury's orbit, Jupiter's orbit around the Sun, a trip that normally takes 12 years, would now take just 90 days. And the average temperature would rise to around 167 degrees Celsius, making Jupiter's gaseous atmosphere heat and swell. And what would happen to Jupiter's moons? Well, the icy layers of the moons Ganymede, Callisto, and Europa might start to sublimate, forming water vapor, revealing the oceans beneath. But that wouldn't last long. Given the intense heat of the sun, the water would evaporate. Now, if there's any life in Europa's ocean, it might welcome the warm thaw, only to quickly realize things are a bit too hot to handle. Okay, in second position, behind Jupiter, would be the gas giant Saturn, taking the place of Venus. Things would be warming up here, too. The average temperature of Saturn would climb from minus 140 degrees Celsius to 55 degrees Celsius. And in its new position, Saturn would look a lot different. Now, bombarded by the intense heat and radiation from the sun, the planet's rings would disappear. The rocks found in the rings might survive, but the ice particles would melt and the dust would get blown away by solar winds. But who knows? The magnetic fields of Saturn and the Sun might interact and form brand new patterns. Okay, now we get to the best seat in the house, the Goldilocks zone. Yeah, unfortunately, Earth no longer gets this spot. We'll check in on our new home in the solar system in a bit, but for now, the habitable zone is occupied by our third largest planet, Uranus. Now, normally, it takes Uranus 84 years to revolve around the Sun, but here, that shrinks to just a single Earth year. And instead of it being a cold, barren planet, it would now be basking in the Sun's rays. So, would this transform the ice giant into a habitable planet? Well, for habitability, you need three things: liquid water, carbon-based molecules, and an energy source. Well, with more heat from the sun, water ice in Uranus's atmosphere could become liquid water, so we can check that off the list. Now, what about carbon-based molecules? Well, luckily they exist in Uranus's icy atmosphere of methane and ammonia. Check. And in its new spot closer to the sun, there'd be way more energy available. So, yeah, looks like we got everything we need. But not so fast. Remember, Uranus has super high atmospheric pressure and also lacks a surface. So the chances of this ice giant becoming Earth 2.0 are pretty slim. Maybe Uranus's moons would be a better spot to live. Or maybe things would improve for Uranus in a couple billion years. After all, Earth wasn't the most habitable planet at the start of its life either. Yeah, but there's no time for that. We've got more planets to check out. Alright, in the number 4 spot, we've got Neptune, filling in for where Mars would normally be. Moving this ice giant so much closer to the Sun would start warming it up considerably, from its current minus 200 degrees Celsius. It would also go from having an orbit of 165 Earth years to being able to zip around the Sun in just under 2. But Neptune is known for having violent storms, and due to the increased heat and energy it would get from being this close to the Sun, its storms might get even worse. Okay, I bet you're wondering about that big problem I was talking about earlier. Well, this new planet order would be seriously destabilizing. We've got 4 big planets now crammed into orbits that are very close. As these large planets swing around the Sun, they'd exert huge gravitational pull on each other. This could tear the system out of whack, destroying our entire solar system. And even if that doesn't happen, something terrifying would happen to us in this newly redecorated solar system. In this new order, Earth would be the 5th planet from the Sun, sandwiched between Neptune and Venus. Now, if Earth were to orbit too close to Neptune, we could become the planet's 15th moon. Oops. But
Really, that might be our best case scenario. Being so much further away from the sun, we'd now be getting less energy. Our surface water would freeze. All life on the planet would die out, including you. The only things that might stand a chance are a few creatures living inside deep-sea hydrothermal vents being heated by the Earth's core. Anyone want to be a snailfish? Okay, after Earth would come Venus, then Mars, then Mercury. This far away from the sun, temperatures would plummet on all three planets. Venus's sulfuric clouds would condense, forming acid rain, sulfuric acid ice, and carbon dioxide ice. Not the kind of ice you want in your whiskey. Mars and Mercury, with little to no atmospheres, would become cold ice boxes orbiting the sun. Yeah, none of this sounds great. I think I like the current order of the planets that we have now. But what if we tried this in reverse? What if we arranged the planets in ascending order, with the smallest one closest to our sun? In this case, hot little Mercury would be in position number 1. Yeah, just like today, so far so good. In orbit number 2, we'd find Mars. Mars would get toasty, reaching an average temperature of 32 degrees Celsius. Like a hot day here on Earth. But any surface water might get vaporized, and carbon dioxide in the ice caps and in the soil would get released. Would this lead to a thicker atmosphere? Well, probably not, as the atmosphere would likely get stripped away by strong solar winds. So, unfortunately, the red planet won't become any more habitable with this new positioning. Okay, now we reach our happy place, the habitable zone. Would pulling Venus into the Goldilocks zone create ideal conditions for life? Sorry folks, it doesn't look good. Sure, Venus would cool off a bit, but not enough to sustain liquid water, which is essential for habitability. Venus's carbon dioxide-rich atmosphere makes things hot through an intense greenhouse effect. There's no water on Venus's surface and very little water vapor in the atmosphere. Even if a comet crashed and delivered water here, it would evaporate in the heat. So, big thumbs down for new life. And how about Earth? Well, we'd be in 4th place. This would mean we'd get just half as much sunlight as we get today. That's not so bad, right? Well, unfortunately, this means we'd freeze. Similar to our other scenario, maybe some small pockets of life could survive, but humans wouldn't stand a chance. Without being in that perfect habitable zone, Earth just wouldn't be the same. In 5th place is Neptune, which is closer to the Sun compared to where it is now. Now, Neptune's gravitational field might ward off some asteroids headed toward Earth. It would also make for a beautiful night sky, with Neptune shining brightly, second only to our Moon. Further down the line, Saturn and Uranus would swap places, with Uranus coming in and Saturn moving out. Probably wouldn't change things all that much. Jupiter moves from 5th place to 8th place, 6 times farther away from the Sun than before. That's a big change. 1 year on Jupiter would now last nearly 14 times as long as before, from 12 Earth years to 165. Its hydrogen and helium atmosphere would stay pretty much the same, but the weirdest thing that might happen? Being this far out, Jupiter's gravity would have an effect on meteors, asteroids, and other rocks flying around the outer solar system. And due to its significant gravitational pull, Jupiter would attract them and begin to fling them around the inner solar system. It would be like the late heavy bombardment experienced by the early solar system. Planets would get hit with significantly more asteroids than they do in our current formation. I'm glad the planets aren't laid out from the Sun based on size. Big to small or small to big, either way, things wouldn't be good for Earth. We'd freeze and die. Life would cease to exist. Now, how did we get to the current order of our solar system anyway? 4.6 billion years ago, our solar system started off as a big blob of gas.
Some of this collapsed due to gravity and formed the sun, and other bits came together to form the planets. There was still a lot of gas and dust around, which concentrated into a dense, rotating disk. The rotation of this disk affected the positions of our planets. The smaller rocky planets, Mercury, Venus, Earth, and Mars, were pulled inward toward the sun. And further away from the sun, gas and ice condensed to form Jupiter, Saturn, Neptune, and Uranus. A second transformational phase began 3.8 billion years ago. The orbits of Jupiter and Saturn became locked together briefly, creating instability in the solar system. To counter that instability, their positions changed. Jupiter migrated inward and Saturn, Uranus, and Neptune migrated outward. After a few million years, things settled down, with all four assuming positions similar to where they are today. Regardless of how it all happened and why the planets sit where they do today, I'm just happy the Earth ended up in the Goldilocks zone. And based on this hypothetical, well, it doesn't look like any of the other planets would do as good a job housing humans, even if they were in the right spot. Let's just hope Earth stays right where it is for a long, long time. Time and again, Earth has faced scenarios pushing us to the brink of our existence. Whether it's a giant asteroid that's slammed into us or an invisible virus creating a worldwide pandemic, danger is ever present. But despite these interferences, humanity has always figured out how to claw our way back. But for how long? Will one of these 12 scenarios end life on our blue marble forever? And how likely are they to happen? Number 12. World War III breaks out. Bombs, shelters, rations. The last time we had a world war was in 1939. Are we on the brink of another one? With global tensions rising and battles erupting all around the world, the possibility of a world war becomes greater and greater every year. Regardless of how things escalate, this war would be unlike anything else we've experienced. Advanced military technologies, the fight for natural resources, and nukes would all be possibilities. The battlegrounds could be the United States, Russia, or potentially Taiwan. So if World War III were to happen, how would you survive? If you're not up for an armed resistance, you'd better get out of the big cities, which are often targets. Head for rural areas, make a survival kit, and just maybe start thinking now about a move to a safe haven. Very far north or very far south? Will it be Greenland, New Zealand, or Antarctica? Of course, all this is assuming a world war with conventional weapons, but what if there's something much worse? Number 11. An all-out nuclear apocalypse. A regional nuclear war would kill millions, but it wouldn't end the world. Pull a couple of heavy hitters into the ring like the US and Russia and all bets are off. A 300 kiloton bomb explosion will vaporize anything, people included. But this is just the start. If multiple nukes went off, every explosion would create a giant fireball as hot as the sun's core. You think that's bad? It gets worse. The dense black carbon smoke would spread across the northern hemisphere, freezing the Earth and causing a nuclear winter for up to 10 years. 99% of the population of the US, Europe, Russia, and China could starve to death. Assuming you survive the blast, seek shelter immediately. For the week or two after, you'll want to hunker down indoors to avoid radioactive fallout. Hiding inside the thickest concrete or underground might protect you from the radiation, but how would you escape the harsh nuclear winter? New Zealand, anyone? If human beings don't end up killing each other on Earth, well, there could be another thing that does. Number 10. Alien invasion. Yeah, I'm talking about aliens, and not because they want to enslave us like we see in the movies. What if it's because they're hungry for that one thing that even we can't get enough of? Before I tell you what that is, do aliens even exist? Well, the Drake equation estimates that there's a 53 to 99.6% chance that we're the only intelligent life in the Milky Way. So, if aliens are out there, how would they even get to Earth? Maybe they'd use a futuristic spacecraft or travel via wormhole. And maybe they'd pop by because they're hungry for energy. A Type 2 alien civilization could potentially have a Dyson sphere, a ball that orbits their planet, harvesting solar energy and looking for new sources. Like our sun? Yikes. And if our sun goes, well, you can say goodbye to virtually all life on Earth. Humans would freeze to death. Our crops would cease to exist, and our once blue marble would become a barren wasteland. Okay, maybe a little unrealistic. Let's move on to something a little more likely. Number 9, asteroid hitting Earth. A truly massive 96-kilometer wide asteroid would finish us all off. Shrink it down to 12 kilometers wide and it might leave a few of us standing. It would still be horrific. The site of the impact would get very, very hot. Tsunamis would rise from the oceans. Billions of us would die. The impact would spawn an enormous dust plume engulfing the globe. It would block out the sun and a deep freeze would set in for thousands, even millions of years. Now, chances are small, but if it happens, what should you do? Well, scientists tell us an underground bunker would be the best option. Now, if you can't swing that, well, at least stay away from the impact zone and clear of coastal areas with tsunamis. But sooner or later, you're gonna freeze to death. Or things could get really, really hot. Number 8, supervolcano. Just like a super large asteroid could take us out, so could a supervolcano. 200 million years ago, Earth was hit by a supervolcano, which wiped out 75% of the species on Earth. It was so strong it ripped apart North America from Africa and plonked the Atlantic Ocean bang in the middle. And did it stop with just one massive eruption? Yeah, sorry, that's a no. For 600,000 years, the Central Atlantic Magmatic Province, or CAMP, erupted again and again. Lava covered everything. Volcanic ash rained down. But you won't believe the thing that got us. It was pollution. CO2 and carbon levels skyrocketed, causing sweeping environmental destruction. So, is there a massive eruption waiting to happen today? Well, below the surface of Yellowstone Park sits a giant caldera. We don't think it'll erupt anytime soon, but in the distant future, it might. If it does erupt, well, expect a repeat of what happened 200 million years ago. Luckily, geologists are monitoring Earth for seismic activity. But can anyone save us from a zombie apocalypse? Number 7, zombie apocalypse. The cordyceps fungus creates zombified ants, growing around their brains and taking over their nervous system. Could this jump over to humans and create a bona fide human zombie? Well, scientists suggest that our body temperature is simply too high for the fungus to survive, but what if this fungus somehow did take over our systems? Big cities like New York, London, and Hong Kong would be the first major targets of an event like this, and due to the cordyceps spreading via spores, it would be incredibly difficult to avoid getting infected. The zombies would slowly take over major metropolitan areas. If you live in more rural areas of the world, you'd likely be safe. For now. Number 6, another pandemic. Yeah, that's right, another pandemic. If you're watching this, you were lucky enough to survive the COVID-19 pandemic, but will you survive the next one? Our world is changing, and for the worse. In the next few decades, the probability of a novel disease outbreak will grow 3 times due to population growth, changes in our food systems, and closer contact between humans and animals. Scientists predict another pandemic will hit us within the next 59 years. And a new virus could be a more dangerous killer. It might mutate faster, or we might not make a vaccine for it as quickly as we did with COVID. Instead of 7 million people who died from the virus, it could be tens of millions. During the COVID pandemic, a bit of bioengineering went a long way in creating mRNA vaccines that saved our lives. But can the same synthetic biology that saved our lives kill us off too? Number 5, synthetic biology. In a secret lab somewhere, could someone create a virus or superbacteria that will wipe out the human race? Imagine a supervirus that spreads silently. It leaves its victims asymptomatic for weeks, only to turn deadly after that prolonged gestation. Due to how much the world travels and how much smaller everything has become, well, the virus can spread more quickly and reach more people. Now, that is something that could wipe out humanity. Unless you're just someone who never sees people, then maybe you'll be safe. But if the virus doesn't get you, I bet the next apocalyptic scenario will. Number 4, catastrophic climate change. What if the average temperature rose 4 degrees Celsius? Well, it doesn't sound like a huge deal, but a 4 degrees Celsius rise in temperature would destroy life on Earth as we know it. Sea levels would rise by a half meter to a full meter, and maybe even more by the year 2100. Cities like New York, London, and Venice would see extreme flooding. Food production would go haywire. We'd see heat waves in the tropics and frequent high-intensity tropical cyclones. Our coral reefs would be destroyed. And that's not the end. The water would keep rising in the coming centuries. In a world like this, humanity might not go extinct, but Earth would only be able to support just 1 billion people. Let's hope you're one of the lucky few. Okay, that sounds bad, but what happens if it suddenly gets harder to breathe? Number 3, oceanic anoxia. Ocean oxygen concentrations are declining today. Are we in danger of an oceanic anoxia event? After all, it did happen 450 million years ago. A drop in oxygen levels persisted for 3 million years, and 85% of marine species vanished. Now, if phytoplankton were part of the vanishing marine species, well, the ocean's ability to remove carbon dioxide would be compromised, driving our climate crisis into overdrive. Plus, atmospheric oxygen would go down. Now, thankfully, a full-scale oceanic anoxic event would take thousands of years to develop. So, for the moment, take a deep breath while you can. Number 2, ecological collapse. Okay, so maybe we'll still have oxygen to breathe, but are we on the brink of a major ecosystem collapse? It happened over 250 million years ago during the Permian-Triassic period. Healthy ecosystems thrive on a set of balanced interactions between animals and plants, predators and prey. Every species has a critical role to play. If all the species playing a particular role within the ecosystem disappear, well, that means the first domino has fallen and the collapse of our world is imminent. A startling loss of biodiversity, like we're witnessing today, is the beginning of the end. Just imagine if we lost all the bees, our best pollinators. we'd have to say goodbye to much of our fruit, and humans would be far less healthy. Yeah, robotic bees, anyone? Yeah, speaking of robots, well, here's the thing that's most likely to kill us all off. Number 1, killer robots. You know, even the deadliest effects of large-scale global warming are a few years away. But AI that can kill us? It's here. In a world where AI gets smarter than us, humans can be enslaved by the very intelligence we've created. Or wiped out by one programmed to kill us. Yeah, we're speeding toward the dangerous point of singularity, where AI takes over human intelligence. Yeah, let's just hope our new robot overlords are willing to play nice. Absolute zero is the lowest possible temperature in the universe. Nothing gets colder than that. So, if the entire Earth suddenly cooled down to the most frigid temperature for even 5 seconds, it would wreak a lot of havoc. Just how cold is absolute zero? What would happen to your body at this temperature? And what's the coolest thing about it? This is What If, and here's what would happen if the Earth dropped to absolute zero for 5 seconds. Temperature is how we measure kinetic energy of the particles in any object. Yeah, it tells us how fast atoms, molecules, and particles move. The hotter a gas, liquid, or solid gets, the faster the particles move. And when that movement slows down, the colder that substance becomes. At the lowest temperature possible, or absolute zero, particles stop moving altogether. This is because at 0 Kelvin, or minus 273.15 degrees Celsius, no heat energy remains. The coldest ground temperature ever on Earth, 184 Kelvin, or minus 89.2 degrees Celsius, was recorded in Antarctica in 1983, but it doesn't even come close to absolute zero. Even the coldest known place in the entire universe, the Boomerang Nebula, 5,000 light years away from Earth, is just a tad warmer at 1 Kelvin. So, are you ready for the coldest 5 seconds ever? At room temperature, you know, that comfortable range of temperatures of about 293 Kelvin, the air molecules move at an average speed of 1,800 kilometers per hour. As the temperatures on Earth suddenly plummeted, all those particles would slow down. At 0.00001 Kelvin, the atomic particles would be moving at a speed of about 0.18 kilometers per hour. That's 1,000 times slower than their speed at room temperature. Getting this close to absolute zero, all chemical reactions would be closer and closer to coming to a complete stop. And this would be very bad news for you and everything else on Earth. Chemical reactions are responsible for everything, including how your brain communicates with your body. Without the trillions of chemical reactions going on inside of you, you wouldn't be able to breathe or turn food into fuel. Temperatures near absolute zero would be devastatingly cold. Even at a comparatively toasty 77 Kelvin, you'd be in serious trouble. That's the temperature of liquid nitrogen. After just a few seconds of exposure to this temperature, you'd suffer severe burns, blistering, and frostbite. Needing a toe or 10 amputated could be a definite possibility. So, just 5 seconds of absolute zero could do incredible amounts of damage to all life forms on Earth. But I have good news. The chemical reactions wouldn't come to a total standstill. Even at the near absolute zero temperature of the Boomerang Nebula, chemical reactions do still appear to take place. This is thanks to the strange effects of quantum physics. And whenever quantum physics is involved, things get weird. With all the atoms on Earth at a near standstill, you'd find them starting to clump together. They'd be forming a state of matter known as a Bose-Einstein condensate. This would mean that every atom is in the same energy state and essentially identical to one another from a physical point of view. They'd start to behave as a single atom. And if you could become a Bose-Einstein condensate, it would be pretty cool, pardon the pun. For those brief 5 seconds, you'd have some unique physical properties, like superfluidity. Yeah, you'd be able to flow through tiny cracks without any friction. Only there wouldn't be any cracks because you wouldn't be the only superfluid thing on the planet. But there is a catch. Bose-Einstein condensates can only be formed when bosons are cooled to near absolute zero. Bosons are all atoms with an even number of electrons. That means only some of the atoms in your body and the environment around you could become a Bose-Einstein condensate. And lucky for you, reaching a temperature of absolute zero wouldn't be possible. If Earth and everything on it plummeted to absolute zero, it would instantly pull the heat from the space around it. To keep you and the planet at 0 degrees Kelvin, even for 5 seconds, you'd need an infinite amount of resources. This makes it mathematically impossible. But that wouldn't mean that 5 seconds of near absolute zero temperatures wouldn't destroy just about everything. And nothing would ever come back together from this soup of atoms that you and the entire planet would turn into. Imagine a world where the cities we know are underwater, and what used to be the ocean is now a barren wasteland. This is a world where every bit of water and land have suddenly switched places. Cities like New York and Paris would find themselves underwater. Tsunamis would come rushing into the cities, destroying everything. And if you're on a boat, you'd find yourself falling down into a dry ocean bed. The Amazon rainforest would be flooded and ancient diseases would come back to life. Which species of animals and plants would fare the best? Is there any way humans could survive this? And what would our new Earth look like? This is What If, and here's what would happen if water and land suddenly switched places. One of the more unexpected changes we'd see in this scenario would be significant climate change. This would be because of changing weather patterns and changing ocean currents. And because this dramatic change is happening overnight, we won't have time to prepare for it. But what if we knew this massive switch was coming ahead of time? Would there be anything we could do to stop it? Well, to answer that, let's take a look at our own climate issues that we're dealing with here on Earth right now. Okay, it's safe to say that water and land switching places would be the start of a new mass extinction. Your cities, towns, and any bit of dry land are now covered with water. Water now covers 21% of the globe, and land covers the other 79%. That means we'll have new oceans. We've now got the North American Ocean, the South American Ocean, and the European, African, and Asian oceans, all connected by narrow channels of water. And a new super large continent. In cities, people might have to run into skyscrapers to save themselves from drowning. They'll be looking outside, wondering when the waters are going to recede. Unfortunately, the answer is never. Because in our new world, water is here to stay on the old land. In this scenario, there would be two kinds of unlucky people. First, the ones who were outside on dry land and couldn't swim, they would have drowned immediately. The second group are the ones who lived far away from any kind of water, because now they'd be surrounded by water with no ability to get to land, unless they had a boat stored somewhere. Maybe you'd be one of the lucky ones. If you lived in a coastal city, say like New York, the Hudson River would now be bone dry. Maybe you'd grab a tire inner tube and put on your swimsuit and a backpack and swim out to the dry riverbed. Now, what about the animals? Well, unfortunately, marine life would be toast, or soggy toast. If all the water suddenly disappeared from lakes, rivers, and oceans, fish would be left gasping for air and would die almost instantly. Riverbeds and dried up oceans would be piled up with the carcasses of dead marine animals. No more whales, sharks, or any kind of fish. Say goodbye to sushi. Now, on the bright side, looking at this new world of ocean floors might be a fascinating experience. After all, maps of oceans here on Earth are less detailed than maps we've made of Mars. Scientists find 2,300 new ocean species every year. If we didn't have the water to stop us, we'd find hundreds of thousands of new species. Unfortunately, they'd all be dead. And animals in forests might have it even worse. Instead of a swift death, they might be left to suffer. Big cats like tigers and lions forced to climb up into trees. They might find themselves sharing the canopy with apes. Other animals like zebras and giraffes would be carried away by the current and drowned. So some of our land animals would survive and others would go extinct. But regardless of who makes it out alive, ecosystems would be savagely altered. But there are two species that would do particularly well in this scenario. The first are reptiles. Crocodiles, turtles, alligators. They're used to living on both water and land. And as they generally hang out in water close to land, well, they won't have to crawl far to find a new habitat. It'll be right next door. The second group that'll do great is insects. 66 million years ago, when the Chicxulub impactor hit Earth and the planet was full of dead, decaying matter, insects had a feast. Count on a repeat of that scenario as insects jump on anything that's rotting. The bad news? Well, with swarms of mosquitoes, diseases like malaria are likely to break out among humans. Now, besides insects swarming everywhere, the other major problem in our new switched world? Well, there's no electricity. With power plants submerged in water, there'll be damage to electrical circuits that can't be repaired. Because the water's not going away, for the first time, you realize how dependent you are on energy. Heck, your 13th floor toilet won't flush anymore because water is pumped up to it using electricity. There's no television, and of course there's no internet. Many of the world's population would be gone from this catastrophe, but there is a lucky set of humans who survive this horror. They are the 40% of the world's population who live in coastal cities, or they might live next to a lake, which is now an island. They've somehow lived through the initial tsunami. Their land is now water, but they can make their way to safety. On the California coast, they scramble onto the new shore of Pacifica, the old Pacific Ocean. From New York, they doggy paddle to Atlantica, the old Atlantic Ocean. To get the world back to normal, everything will have to be built from the ground up. Homes, agriculture, transportation, the list is endless and challenging. Building any kind of new home will be hard without materials like wood or cement. But there is one thing we could use: trash. Yeah, it's estimated that there are over 5 trillion pieces of trash in our oceans. Once the water leaves the oceans, humans could get resourceful and use the leftover garbage to make structures to live in. Kind of gross, yeah, I know, but at least it's been washed. Most land plants now will be submerged in water and will die, which means no access to fresh fruits and vegetables. Without vitamin C, scurvy, the disease sailors used to get, will increase. What is available is huge amounts of fish that have just died. Now, smart foodies will get to work. They dry and salt the fish to preserve it for the future. Pickling will be the new trend. Access to fresh water will be very limited. The humans who survive will be in for a punishing time. Now, in the medium term, the big challenge for humans will come from a shift in our climate. Our vast oceans play a key role in moderating our temperature today. As they shrink to a quarter of the area they once were, Earth will get much, much hotter. Water absorbs a large amount of heat, but with the total water area reduced to 21% of Earth's surface, oceans won't absorb as much energy from the sun as they do today. There will also be less water to absorb carbon dioxide. With oceans absorbing less heat and with more carbon dioxide in our atmosphere, Earth will get pretty toasty. Also, today's ocean currents are able to distribute the heat that they absorb to different parts of the world. In this new geography, the paths these currents are able to take will have bottlenecks that will prevent the smooth flow of water. Look how narrow the new Latin American channel is. Less water surface also means less water vapor and less rainfall. In this new world, prepare yourself for dry, desert-like conditions. Your best chance for survival will be to live near the coast. Expensive coastal real estate, that's one thing that remains the same. Now, let's say an enterprising group of humans somehow survives this catastrophe. How will life evolve? Well, humans will become insect and reptile eaters, connoisseurs of pickled fish. But that'll be a tricky balance because with many of our previous weapons now lost underwater, hunting crocodiles won't be easy. And if humans wipe out the reptile population, that eliminates an important food source. Unfortunately, slower moving turtles will probably be quickly hunted into extinction. Reptiles that can retreat further into the new oceans, far away from humans, will have a better chance at survival. In general, smaller members of any surviving species will do better as they can get by with less food. Over millions of years, they'll evolve, and as Earth's food sources get reestablished, the species will become bigger again. Birds are also likely to survive, though with trees gone, nesting becomes a challenge. Maybe they'll build nests in the top floors of old skyscrapers. And don't forget, with the destruction of ocean plankton and all of our land-based plant life, over time, oxygen will settle at a new lower-level equilibrium. Unless plants begin to grow again on both land and in water, this lower level of oxygen will cause all species to evolve in new ways. Mammals may have bigger red blood cells, bigger lungs, or smaller bodies to use their oxygen more efficiently. And insect sizes will decrease over time as less oxygen will be available to them. Now, of course, the big question is, will humans survive such a catastrophic event? Well, it's hard to say, but if we look back in time, human populations have rebounded from numbers as small as a few thousand, so yeah, it's possible. If humans do survive, we'll emerge stronger and hardier than ever before. We'll build a new civilization on what's now become a hot brown marble. Hey, who knows, maybe even one day we'll become an advanced level 7 civilization.
You've seen politics and national borders change all the time, but have you ever witnessed a continent literally breaking apart? Well, it's possible, and it's happening to Africa right now. In 2005, a 60-kilometer-long stretch of the continent cracked open over a period of just 10 days, and it hasn't stopped expanding since. Eventually, the landmass will break right off, giving birth to a brand new ocean. How soon will this happen? And what does it mean for the people of Africa? This is What If, and here's what would happen if the African continent broke apart. The face of our planet is continually changing thanks to the shifting of tectonic plates, but it's rarely this noticeable. In the years since 2005, more cracks in the Earth have opened up in several countries throughout the African continent, sparking fear among their populations. But as scary as the fractures may seem, experts say they could teach us a lot about how our world was formed. Have you ever heard of the East African Rift? Neither had most people in Ethiopia until the ground started cracking beneath their feet. The East African Rift is an active continental rift zone in East Africa. And judging by the blank look on your face, it may require more of an explanation before we go any further. Okay, so the rigid outer layer of the Earth is called the lithosphere, and it's broken up into many tectonic plates. Tectonic plates are basically large slabs of solid rock that move relative to each other at varying speeds. When these plates move apart from each other, they cause fractures to be formed at their boundaries. The land remaining in between the two plates starts to sink and forms what's known as a rift valley. This can lead to new boundaries being created between plates. In the case of the East African Rift, the African tectonic plate is breaking up into two smaller ones, the Somali and Nubian plates. So what happens when these plates completely break off from each other? Well, for one thing, we won't be around to see it. Despite the rapid appearance of the surface cracks, geologists say that the continent won't fully break apart for about 10 million years. They're currently spreading apart at a rate of 6 to 7 millimeters a year, so don't hold your breath. As the plates continue to pull away from each other, the Rift Valley will sink deeper and deeper, and water from the Red Sea will flood in to create a new ocean. Africa will become a lot smaller as parts of southern Ethiopia and Somalia will drift off to form a new island. What does this mean for all of us in the meantime? Well, African residents who live along the rift can expect more disturbances, cracks in their highways and cities, and the emergence of vast canyons where there weren't any before. But it's not all bad news. In fact, most geologists are pretty excited about studying the whole process. They believe it can lead to some pretty groundbreaking information about how our Earth's surface is shaped and how earthquakes and volcanic eruptions work.
Deep under the Earth's surface, there's a scorching hot ball of metal. And scientists just discovered that something very wrong is happening to it. Did the Earth's inner core really stop spinning? What apocalyptic events could this trigger? And are we doomed to become as lifeless as Mars? This is What If, and here's what would happen if the Earth's core stopped spinning. If you were to dig straight down into our planet, well, you'd shovel through 4 distinct layers on your way to the center. First, there's the rocky crust, and that's followed by the hot liquid mantle. 2,900 kilometers later, you'd reach Earth's outer core, made up of liquid iron and nickel. Combined with the solid iron inner core, the 2 core layers of our planet are about the size of Mars. But unlike the red planet, they're scorching hot. At 10,000 degrees Celsius, well, they're hotter than the surface of the sun. And there's also a lot of movement down there. The motion of molten metal in the outer core is what's responsible for generating Earth's magnetic field. Without that, we wouldn't be able to hold on to our atmosphere and we'd lose our protection from dangerous space radiation. And the inner core of our planet is moving too. But new research suggests that it's slowing down to rotate more in sync with the rest of the planet. But slowing down isn't dramatic enough. Let's see what happens when both layers of the core stop moving completely. If only the hot, solid inner core inside the outer core stopped moving, well, you wouldn't need to worry about the apocalypse just yet. The slowing down of the inner core would mostly impact the speed at which Earth spins. It could slow our rotation down enough that our days would become longer, and over time, this could degrade our magnetic field. Yeah, that would be bad news, but not nearly as bad as what would happen if the syrupy outer core stopped spinning too. Without that layer's rotation, well, you'd have to kiss our magnetic field goodbye. And this would put Earth on a course to end up looking a lot like Mars. 4.2 billion years ago, Mars could have been warm enough to have oceans where life might have thrived. But when the red planet's core froze in place, its once strong magnetic field weakened. As the Martian magnetic field degraded, its atmosphere was chipped away by ferocious solar winds, slamming into the planet at speeds of several hundred kilometers per second. That's when the planet transformed into the dry, lifeless desert you know today. But back to Earth. Before it completely turned into a desert planet, well, things would get a little shaky. If the core was to suddenly stop rotating, the tectonic plates would violently slam into each other. It would be a lot like when your bus driver hits the brakes hard and you go flying into the other bus riders. This sudden collision of tectonic plates would cause massive earthquakes along the plate boundaries all around the world. These quakes would destroy buildings, roads, and bridges. Electricity, phone lines, and water systems would be severed. Ultimately, millions of lives would be lost and millions more people would be displaced. Now, as devastating as these earthquakes would be, the damage would just be getting started. With the disappearance of our magnetic field, you'd be exposed to dangerous cosmic radiation that would bombard the surface of our planet. These high-energy particles from the sun would interact with the abundance of nitrogen and oxygen in our atmosphere. And this would destroy our protective ozone layer, allowing more UV radiation to reach the surface. Combining these solar rays and UV radiation would be enormously harmful to all life on Earth. It would damage your DNA, leading to mutations and cancer. And the halting of the core would also make navigating the globe more difficult. Yeah, I hope you have a good trail map for your next camping trip because compasses would be totally useless. All kinds of migratory animals would lose their way too. Birds flying south would get lost and freeze to death, while sea turtles would never find their way back to the beaches that they lay their eggs on. The earthquakes caused by the core suddenly stopping would have already done significant damage to the power infrastructure around the world, but the lack of a magnetic field would continue disrupting things even more. The solar radiation bombarding the surface would damage all kinds of electronic devices and would threaten our power grids. You would end up losing power more often, maybe even permanently. But in reality, you don't have to worry about a catastrophe like this. This study, which implied that the core has stopped and we're all doomed, was a little overhyped. Scientists didn't even talk about the outer core. No, they just meant the inner core, which rotates independently from the rest of the planet. It doesn't stop or reverse its rotation, it just moves slower and faster, like it's done for the billions of years of our planet's existence. Well, good news everyone, we're safe on our big blue space rock.
Millions of years ago, the Earth looked very different. A huge landmass called Pangaea covered about a third of our planet. But about 175 million years ago, the Earth broke up into continents and formed the world we know today. What if that had never happened? Where would your country be located? And how different would your life be? This is What If, and here's what would happen if Pangaea had never broken apart. If Pangaea existed today, in theory, you could drive from California to England, since they'd both be part of the same landmass. And although you may only think of Pangaea as just another piece of land, it would be much more than that. It's played an integral part in human and animal evolution. If Pangaea had not broken apart, you may not be here today. But let's assume it didn't, and that we survived and evolved to be the people we are today. What would the Earth be like? First, let's talk about where your country would be located. North America would be right here. Europe would be a lot closer, just to the east. Asia would be up north by Russia, and Antarctica would remain down south. India and Australia would be further south, connected to Antarctica. These countries that used to have hot climates would now be cold, covered with snow and ice. And those wouldn't be the only environmental changes. Regions in the middle of Pangaea would have lush rainforests along their borders. And as you travel further inland, it would become a desert. This would be due to Pangaea's landmass being so large. Rain, which comes from the ocean, wouldn't be able to travel far enough inland, leaving parts of Pangaea practically uninhabitable by humans and other species. And weather up north would be different too, with Russia being much warmer than it is today. But the weather wouldn't be the only thing that would change. On Pangaea, we might have less diversity of species. The species at the top of the food chain today would most likely remain there, but some of today's animals would not exist in Pangaea. They wouldn't have the chance to evolve. Fewer animals might make it easier to travel, and on this modern version of Pangaea, you'd probably want to do a lot of it. Luckily, you wouldn't have to go far. If you lived in Florida, you'd be right next to the Caribbean islands, Venezuela, and Brazil. You could visit all of these in a single day. And if you lived in Nova Scotia, Canada, you'd be driving distance from France, England, and Germany. Although this might sound like fun, a lot of countries would have new neighbors, which could cause some serious issues for some. Places like the United States, which used to have oceans on both sides of the country, would now have Africa on its east coast. If these countries didn't get along, things could get ugly. How much easier would it be to start a war in another country if they were just a short drive away? Transporting weapons, people, and supplies would all be faster and cheaper if certain countries were right next to each other. Or none of this would happen, and the entire world would be more unified than ever. With all of us sharing the same landmass, maybe we'd learn to treat each other just a bit better than what we do now.
Imagine Earth with an even 50-50 split between continents and oceans. Our planet covered half by land and half by water. How would this change the planet as you know it? What new kinds of vacations could this make possible for you? And what does the color of your pee have to do with this? This is What If, and here's what would happen if the Earth was half land and half water. When it comes to making life possible on a planet, water is an absolute must-have. That's why we look for alien life on worlds where liquid water could exist. When it comes to our own planet, 71% of its surface is covered by water. Most of that is in our 5 oceans. Together, they form one global ocean. Now, if you replaced nearly a quarter of our ocean water with land, how soon would Earth turn into just another lifeless rock in space? Thanks to global warming, Earth's sea levels are currently rising. But if you wanted to balance the planet's land-to-water ratio, you'd see the sea levels absolutely plummet. And not just a few meters, but around 3 kilometers. Earth would look very different. The regions around both the North and South Poles would be completely dried out, and every continent on the planet would expand. And not just a little either. All this newly emerged territory around the world would be roughly equal to the current surface areas of Asia, Europe, Africa, and North America combined. That would be an enormous amount of unused space. Everything extending off the old coasts would be relatively flat, but some of the areas that used to be deep ocean would reveal vast corridors and steep crevasses. As you explored this new land, you'd discover that the one global ocean would be no more. All of the oceans would be separated from each other, and all of the continents would be one connected landmass. And this would be good news for evolution. Early humans didn't have any ships or planes. We spread across the globe simply by walking. Venturing away from Africa some 70,000 to 100,000 years ago, we found our way to Europe and Asia. Eventually, we were able to cross a land bridge connecting Asia to the Americas, possibly as far back as 20,000 years ago. With the 50-50 split in place, you'd now be able to cover even more ground. Finally, you could take that around-the-world trip you've always dreamed of, all on your own 2 feet. But this shifting balance of water and land wouldn't be all fun and games. With so much less water covering the surface, our ocean currents would be disrupted, and this would seriously destabilize the climate. Currents distribute the heat that's absorbed by the oceans around the globe. Disrupting them would mean even colder temperatures around the North and South poles, while the already hot equatorial regions would get even hotter. Climate change would speed up too, all because oceans wouldn't be able to absorb so much carbon dioxide from the air. That excess carbon dioxide would blanket the planet and raise temperatures. Rain levels would also drop off, and this would create dangerous droughts, as well as new deserts in many inland areas. So, while there may be an abundance of new land available, large stretches of Earth could become uninhabitable. Plants, animals, and humans would all need to adapt to being less dependent on water, or at least start using it more efficiently. Water scarcity could result in animals evolving to be smaller, with more making the jump to a strictly carnivorous diet. And sadly, the abundance of life that today's oceans support would struggle to survive. And maybe the most surprising consequence that you'd need to get used to is that your pee would likely change forever. Usually, urine is made up of more than 90% water. But with less water in your daily life, yours would become much darker and start to smell like ammonia.
What if all the oceans disappeared from the Earth's surface? What would a world with no high seas look like? What would happen to all the creatures that live underwater? Could humanity survive on the planet if there were no oceans left? This is What If, and here's what would happen if all the Earth's oceans evaporated. In the early years of our planet, the Earth was flat, but not in a way you might think. The Earth just didn't have any mountains and was mostly covered with water. Then, about 1 billion years ago, land emerged from under the sea and changed the planet's atmosphere. This led to the debut of the first life forms here on Earth. Eventually, the planet will heat up, and all the oceans will vanish. This isn't scheduled to happen for another 1 billion years, but how bad would it be if all the oceans evaporated right now? Today, oceans cover about 70% of the Earth's surface. If you put all that water into Olympic-sized swimming pools, you'd need over 500 trillion of them. With all the oceans gone, we'd still have some water available. Oceans account for 97% of all the water on the planet. The remaining 3% is held in rivers, lakes, underground water, even the ice caps. But that wouldn't be enough to make up for the loss of the oceans. The world's oceans act as a global climate control system. They absorb most of the sun's heat and distribute it evenly around the planet so that no one area gets too hot or too cold. They also sustain the water cycle, evaporating into clouds and then raining back to Earth. But you won't need to keep your umbrella at hand, expecting a big storm once all the oceans evaporated. In our scenario, the Earth wouldn't be able to keep all that vapor in the atmosphere. Oceans would leave our planet for good, turning it into a vast, scorching desert. Sea creatures would be the obvious first casualties in these conditions. Then, with no oceans to absorb the heat from the sun, the Earth would slowly roast until it turned into Venus. How long would we have until our planet became uninhabitable? Well, whatever water was left would evaporate in a matter of days, leaving humanity to die from dehydration. Most animals would go extinct without water. Who knows, maybe camels would become Earth's next civilization. After a few days, plants would give up their attempts to survive without water. After a few weeks, the same would happen to our forests. Eventually, they'd catch fire and would keep burning until there was no vegetation left. In about a year's time, the Earth would turn into a burnt and lifeless rock. And without water, it probably wouldn't get the chance to produce life ever again. What if we found a way to drain all the Earth's oceans through some mysterious portal at the bottom of the Mariana Trench? How long would it take? Years? Centuries? Millennia? Would there be any life left on Earth when the pumping was over? What if it happened overnight? This is What If, and here's what would happen if we drained all the world's oceans. Ocean water makes up 70% of the Earth's surface. How much liquid is that exactly? Well, if you could put all that water into Olympic-sized swimming pools, you'd need this many of them. Even if we opened a portal about the size of a basketball court, it would take us hundreds of thousands of years to drain the oceans. They hold over 1 billion cubic kilometers of water. But what if we had a pump powerful enough to drain all the oceans in a minute? What would happen then? Sure enough, swimmers, sailors, cruise passengers, everyone out on the ocean would feel the effects quickly. Within a second, boaters and swimmers in shallow water would crash onto the bottom. They'd get away with a few broken bones. Deep ocean ships wouldn't be so lucky. A Titanic-sized liner would hit the bottom in 30 seconds and smash into tiny pieces. The same thing would happen to just about every large ship on the ocean within the first minute. What about all the sea creatures? You already know the answer. It would literally be raining fish, since all the whales, dolphins, and other big aquatic animals curiously exploring the surface would be falling to the ocean floor. As for those already near the bottom, they'd be lucky not to get sucked down the drain along with the water. But what comes next is where the real trouble begins. Our oceans have two life-supporting roles. First, they regulate global temperatures by absorbing energy from the sun. They push warm tropical waters north and south and circulate cold waters back to the equator. This way, no place on Earth gets too hot or way too cold. Global climate control. Second, oceans feed the water cycle, evaporating into the clouds and raining back to Earth. The moment the oceans disappeared, the Earth would turn into a vast desert. Go ahead and throw away your umbrella since it's never going to rain again. Wait, what about all the lakes and rivers? Can't we get by with those? Well, without oceans, the world loses 97% of its water. The small amount of liquid left would not be enough to sustain the water cycle. The pools of drinkable water would evaporate pretty fast. In a matter of days, people and most animals would die from dehydration. Plants would have a few weeks before they started decaying in the dry air. Within a few months, forests would begin massive die-offs. And all this dry, dead vegetation would eventually ignite. In a matter of years, most of the world's forests would be burned down. As these huge bonfires sparked all across the planet, the atmosphere would become less and less oxygenated. If there were still humans at this time, the unbreathable air and scorching temperature would wipe us out for good. All in all, the Earth would end up just like Venus, cooked. Where do you go to quench your thirst? The kitchen sink? The local bar? The mineral-rich springs of Bergamo, Italy? In the 21st century, you don't have to go that far for fresh water. But still, supply is running out. What if we didn't have to worry about water consumption? What if you could drink and shower as much as you wanted? What if a trip to the well and a trip to the beach were one and the same? You might give a lot for those privileges, but how much would it really cost? This is What If, and here's what would happen if all seawater became fresh water. The first big question we have to ask is, why is the ocean so salty to begin with? Well, it wasn't always like that. About 3.8 billion years ago, Earth's surface had finally cooled to the point that water vapor turned to liquid, no salt added. That's right, a really, really long time ago, the oceans were fresh water. But that wasn't going to last. Whenever it rains, carbon dioxide from the air dissolves into the falling water. This makes the rain slightly acidic, and when it falls, it causes rocks to erode. From there, rainwater slides towards nearby rivers and streams, taking loose salt and minerals along with it. From there, this runoff flows from rivers into the ocean. Add to that any additional salt and minerals that would be expelled from hydrothermal vents or submarine volcanoes, and then consider that this whole process has been recurring more or less consistently for 3.8 billion years. That's a lot of salt. In fact, there's so much salt in the ocean that if you spread it evenly across all the land on Earth, it would amount to one towering layer of salt that's 40 stories tall. 97% of all the water on Earth is saline, and we've got to assume it's for a reason. So what would our world look like if we took the salt out of the sea? Freshwater oceans sure do sound like a godsend. Right now, it's predicted that a third of the world will be facing chronic water shortages by 2025. At our current rate of consumption, the global demand for fresh water doubles every 20 years. So maybe freshwater oceans would actually yield a good outcome this time. Nope. A sea without salt would decimate marine life and dramatically affect our weather and temperatures, making human life on Earth very difficult, if not impossible. There are roughly 228,450 species in the ocean, and as many as 2 million more to be discovered. But if the ocean were to become desalinated, we'd never find them. Saltwater fish and other ocean creatures evolved to be able to drink salt water to stay hydrated and get rid of excess salt. Not all sea creatures do this the same way, but being able to pump out excess salt is crucial to surviving in the ocean. Some species, like salmon, have adapted to tolerate freshwater and saltwater. But for the most part, all saltwater species would perish. This includes underwater algae, which, believe it or not, accounts for half the photosynthesis that occurs on Earth. Photosynthesis plays a vital role in supplying our planet with oxygen, since trees and plants convert carbon dioxide from the atmosphere into the air we breathe. So without algae, not only do we get less oxygen, we also have a lot more carbon dioxide in our atmosphere. This intensification of the greenhouse effect would make some parts of the world unbearably hot. You'd definitely notice this intense heat near the equator, since our ocean currents wouldn't be circulating warm water and air the way they used to. Convection currents help warm water from the equator get farther north, while colder water from the north is able to cool hotter areas down south. At the equator, warmer water can carry more salt, so this denser water sinks lower, while cooler water flows over top of it. And in the far north, the water gets cold enough to freeze and form sea ice. Salt gets left behind as the water freezes, and naturally, this makes colder water up north denser, allowing it to sink to the bottom to make room for the incoming warmer water that's worked its way up from the south. But without salt, the whole process breaks down. Earth's extremities would freeze, while weather around the equator would intensify. For one thing, hurricanes would be a lot more frequent and a lot more deadly. At this point, our weather and our climate would be totally different from how we know it now. How long would we survive to see all these changes? Not long at all. You'd either freeze, overheat, die in a natural disaster, or starve to death. Yeah, with significantly less photosynthesis and climates that are either extremely cold or extremely hot, our weather would no longer support the diverse plant life it has now. The entire food chain would collapse. Most species would die off, including humans, since crops we rely on for sustenance would all disappear. So, when we say ocean salinization is important, don't take it with a grain of salt. Of course, we respect the scientific method, so keep questioning the world and its properties, on land and beyond.
The sun is releasing massive spurts of energy that are headed directly toward Earth. And if they hit us it could change everything. Power grids could be wiped out. Our communications could cease to exist. Humanity might be put back into the Stone Age. All because of a solar storm. But what makes them so powerful? How is it possible for something like this to happen in 2024? And why are they so dangerous? This is What If, and here's what would happen if a solar storm hit Earth in 2024. So, how could something like this happen anyway? Well, it all starts with the cycle of our sun. Known as the solar cycle, this is an 11-year stretch in which the sun's solar activity increases and decreases. The cycle starts with just a few sunspots raging about and creating mass amounts of energy, and then 5 or 6 years later, it reaches its peak with anywhere from 100 to 200 sunspots. Then it ramps back down for the last 5 years, and we start another solar cycle. You know, these cosmic threats probably aren't the most likely thing that could destroy Earth. What's a lot more likely to hurt our planet is climate change. Hurricanes, forest fires, and rising sea levels are all becoming more frequent due to the Earth heating up. But luckily, the Environmental Protection Agency is working to help solve this. There are new rules in place that incentivize coal and natural gas power plants to cut or capture 90% of their climate pollution by 2032. This could reduce the carbon emissions from these plants by 75%, bringing them back down to levels we haven't seen in almost 2 decades. The EPA has also announced stricter rules that will force these companies to have safer disposal for toxic wastewater and coal ash, byproducts of making electricity in these plants. But that's not all. Companies are being incentivized to retire fossil fuels entirely, shifting to energy sources like wind and solar, both of which are cleaner and cheaper to produce energy from. If we want our planet to stick around, it's essential that our leaders prioritize making progress on carbon reduction. Currently, we're in our 25th cycle since we began tracking the sun in 1755. And unfortunately for us, scientists predict that the sunspots will peak in 2024. This means there's a higher chance that a solar storm will occur. Now, before we get to our solar storm, what are sunspots anyway? Well, they're cooler and darker areas of the sun that are created by a strong magnetic field. They're not directly responsible for creating solar flares, but it just so happens that flares are most common in these sunspots due to their high magnetic activity. The magnetic field lines can become twisted and tangled near certain parts of the sun, and they can suddenly snap and realign, which creates a massive burst of energy. This can result in a solar storm. So now that the sun has released this massive amount of energy, what will happen to you on Earth? Well, when a solar storm occurs, you won't notice it right away. That's because it takes a few minutes before it reaches Earth. Hurry up and get in your last couple of YouTube videos, because once this storm hits, everything changes. Now, the first thing you might notice is that more and more auroras will start popping up worldwide. This typically happens when charged particles from the solar storm interact with the Earth's atmosphere. Although these sights in the sky look beautiful, the good parts about a solar flare end there. Due to the effect on our geomagnetic field, most of our technology would stop working. Things like satellites, GPS, and radio transmissions would become incredibly spotty. Your cell phone likely wouldn't be able to pick up any signal, and communications worldwide would start to fade out or become less reliable. But that would only be if we were affected by a few solar flares. This is an entire solar storm we're talking about here. These are comprised of multiple attacks by the sun on the Earth. But before we get to that, people on Earth aren't the only ones affected by this. Astronauts up in space would also suffer the consequences. Their situation could be a lot worse. The sun would be blasting them with intense solar radiation, and if they're not in a specially shielded area on the spaceship, a solar storm could prove deadly. They could get radiation sickness as well as develop cancer later on. The solar storm could also destroy their ability to communicate with their mission control and vice versa. This is just what would happen on the first day of the solar storm, but several days later, as you're still having trouble getting cell reception, another massive attack would come from the sun. A phenomenon known as a coronal mass ejection, or CME for short, would be coming right for Earth. A CME is a massive explosion of plasma and electromagnetic radiation from the sun. This mass ejection can cause violent geomagnetic storms that interfere with Earth's magnetic field. If this were to happen, Earth as we know it could change for good. Just look at what happened in 1859. A solar storm known as the Carrington event occurred. It disrupted and flat out destroyed telegraph communications. Luckily, in this case, Earth was able to recover relatively quickly from what today would be a cataclysmic event. Telegraph communications were a simple technology. Telegraph lines could be repaired quickly and things went back to normal. But what would happen today? Our lives are so much more reliant on technology, and we have so much more of it. This time, the tech interruptions wouldn't just stop with the odd glitch or spotty signal. Instead, a solar storm could be so bad that it would make all technology stop working. Yeah, the intense levels of electromagnetic radiation could wipe out entire power grids and communication systems. Even something as simple as buying groceries with your credit card would be impossible. We're talking about a full-on global blackout. If you were in an airplane, the cockpit could lose communication with air traffic control and not know where to go. Or, with the intense radiation levels hitting Earth, the plane could fall entirely. The same goes for subways and trains. They could come to a complete stop in their tracks. This would cause catastrophes all around the world. Planes falling from the sky, trains crashing. Now, not having power at your house would be the least of the world's worries, because entire cities, including all hospitals, would be without power. No power means it's harder or impossible to treat certain patients. The lack of power and technology malfunctions could cause millions of people to die. The solar flares and CMEs might last anywhere from a couple of hours to a few days, but that doesn't mean this event would be over just yet. Because of all the damage to our power grids, communications, and technology, Earth would take some time to recover. It might be weeks or months before we get back to normal. We'd have to rebuild parts of our power grids and communication systems. And depending on the parts needed, well, this might take another several weeks. And take into account the lack of communication that the world would suffer. I mean, talking to your neighbors is one thing, but how would you communicate with another city or country? Global supply chains would collapse. This would delay things even further. But once humanity got all these things sorted, we would rebuild. What once felt like the end of humanity might turn into a simple footnote in Earth's history. The result of a solar storm could be traumatic and life-changing, but humans would live to see another day. So, how likely is something like this? Well, it's tough to predict. We can look at the solar cycles and see how many solar flares occur, but there's no telling if they'll hit Earth or not. And although a solar storm could happen, well, keep in mind that even though we're more reliant on technology than ever before, our technology is also more resistant. Communication technology and power grids are built to withstand various types of interference. NASA is also working on technology to help predict and warn us about solar flares. If one is headed our way, well, here's what you can do to prepare. Keep a well-stocked emergency and first aid kit nearby. Like with any natural disaster, it's important to be equipped with first aid equipment, non-perishable food, and water. You might want to invest in surge protectors and remember to unplug any electronics if a solar storm occurs. Lastly, look into off-grid power supplies, backup energy sources like generators or solar panels. Then just wait it out. The world should return to normal.
1.3 billion years ago, two orbiting massive black holes, circling each other at 250 times a second, collided in a violent, universe-rippling explosion that sent waves of energy throughout the cosmos. In its wake, a new supermassive black hole formed over 60 times bigger than our Sun. Fast forward to September 2015, gravitational waves from this ancient cosmic event finally struck Earth. Luckily, the gravitational waves weakened over such a great distance. But what if we weren't so lucky? If a couple of black holes in our solar system collided, could we survive? What would happen to Earth if we got hit by massive gravitational waves? What causes these waves? And how can we detect them? In 1916, Albert Einstein made waves himself with his groundbreaking theory of general relativity, known famously by the formula E equals mc squared, or energy equals mass times the speed of light squared. He proved energy and mass are interchangeable, and that space, or space-time, curves in relation to the energy and momentum of whatever matter and radiation are present. With great foresight, Einstein inferred the collision of black holes, or massive stellar objects, create distortions in gravity, which are pushed out in all directions. Thanks to incredible developments in atomic measurement, scientists in Washington and Louisiana in the US at the Laser Interferometer Gravitational Wave Observatory, or LIGO for short, were able to detect and measure the first ever gravitational waves here on Earth in 2015. This was a historic moment in science, as it was the first definitive proof of Einstein's theory of relativity. Using laser interferometry, observatories can detect a change less than 10,000th the diameter of a proton. That's 1 million times smaller than the width of a human hair. Since then, LIGO has measured 50 detections of gravitational waves. So, what exactly is causing these waves? And could they be catastrophic? There are many sources of gravitational waves, including the collision of black holes, the rotation of asymmetrical neutron stars, supernovae, or even remnants of gravitational radiation caused by the Big Bang. These waves travel at the speed of gravity, equal to the speed of light, and emanate outward in all directions. Like a rock being thrown in a pond, the ripples it creates dissipate over great distances and become smaller and smaller. Luckily, in our pocket of the universe, we are over 400 million light years away from any orbiting black holes. We're generally safe, but if these black holes happen to be in our solar system, the implications are much more dire. When gravitational waves pass through a planet, one side is compressed as the other expands, kinda like squeezing a stress ball. I could use one of those right now. As a result, time and space itself are stretched, causing a slight wobble. But if we were closer to this violent event and the waves were much bigger, this impact could potentially tear our planet apart, triggering powerful continent-splitting earthquakes, volcanic eruptions, and epic storms. Earth wouldn't really be a habitable place anymore, except maybe for extremophiles like bacteria that thrive in hydrothermal vents. Let's imagine our sun was a neutron star of an imperfect, non-spherical shape, sending gravitational ripples outward as it spins. Earth would likely look more like Io, one of Jupiter's moons, which is put under great gravitational pressure by Jupiter, and as a result is one of the most volcanically active moons in the solar system. Our landscape would be covered in lava and volcanic fallout, with an atmosphere made up of toxic gases like hydrogen sulfide. This would cause massive global warming and intense storms, constant tsunamis, tornadoes, and, well, you get the idea, climate chaos. We can count our blessings. We are nowhere near any massive objects shooting out gravitational waves. But thankfully, we can still measure them and learn more about the complexities of our universe. Even though we get hit by gravitational waves, they are generally so small, we can't even feel any impact.
Just 3,000 light years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our Sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition: supermassive black holes. These have a diameter roughly the size of our solar system and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So, how close would a black hole need to be a danger to us? Well, technically, a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis. The trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification. And not in the tasty, cheesy, tomatoey way.
Mamma mia!
Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. Let's hope your superpower is elasticity. For an average-sized stellar black hole, spaghettification could occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it: people, planets, stars, you name it. Unfortunately, our whole solar system would be doomed. The careful balance of the sun and our many planets would collapse, which could send them crashing into one another. And to add insult to injury, our asteroid belt would get sucked toward us. About
200 of the 552,894 asteroids we know of are more than 100 kilometers across. So, if one hits us, we'd be dead before we would turn into spaghetti. Frankly, I'm not sure which fate would be worse. All of the matter in our solar system would join the accretion disk around the black hole. As matter gets sucked into the black hole, it generates massive amounts of radiation, so even if we somehow survived all the asteroids, we'd likely die from the radiation. Believe it or not, astronomers have discovered rare circumbinary planets that orbit two stars. While this may be a possibility with a black hole and our sun, the extreme tidal forces would likely make our planet uninhabitable. And worse yet, we might get kicked out of orbit or swallowed by the sun or the black hole eventually. Sorry, but there's not an outcome where we win here. But, and this is a big but, maybe we could find a way to protect ourselves in some hyper-reinforced space shuttle. If we somehow made it past the event horizon, we might be in for an even stranger time. Physics as we know it would change. Things like gravity, the speed of light, and even how atoms bind and react may be completely different. The truth is, we don't know what would happen. We can't get any information out of a black hole. Would we get pulled into another dimension? End up in a parallel universe? Or maybe we're already inside a black hole.
Oh my god! Oh Jesus!
Oh my god!
Twinkle, twinkle, little star, how I wonder what you... What? Wait a minute. Why are you twinkling so much? Whoa, guys, that's no diamond in the sky. That looks like a supernova. As much as we love to blow stuff up here on Earth, no bombs or pyrotechnics could compare to the incredible force of nature's biggest explosion, the supernova. As a star reaches its grand finale and explodes, what would happen to life on Earth if we were close by? How far away from a supernova are we considered safe? Could anything survive its deadly radiation? And what makes supernovae valuable to us? Before you freak out, Earth is in a relatively safe patch of space called the local bubble. This peanut-shaped region of expanding gas in our Milky Way galaxy results from nearby supernovae explosions that occurred 20 million years ago. These explosions helped shape our solar system, spreading gas, dust, and heavier elements like uranium and gold to Earth. Without these supernovae, we wouldn't have any shiny gold bling or powerful nuclear reactors, so you can literally count your lucky stars. Okay, but are we in danger of any nearby supernovae? On average, a supernova will occur about once every 50 years in the Milky Way. Thankfully, there are no stars massive enough to become a supernova within 50 light years of the Earth. There is, however, one binary star system within 159 light years of Earth that could potentially put us at risk. Binary star systems are Type 1 supernovae. This happens in a tumultuous dance between two stars where matter is sucked from one star into another, typically a white dwarf. Eventually, the white dwarf explodes, resulting in an epic supernova. On the other hand, Type 2 supernovae occur when a star runs out of fuel and some of its mass flows into its core. Over time, the core will start to grow and get so heavy that it can't withstand its gravitational force, and then kablooey! The core collapses and a supernova is born. When these explosions occur,
a powerful blast of radiation is spread throughout space that will kill anything within 50 light years. To put this in perspective, our solar system is only about 2 light years wide, so the supernova's blast would be the distance of 25 of our solar systems in a row. If a supernova occurred as close as 30 light years away, we'd have bigger problems than a pandemic on our hands. The intense blast of radiation would carry a massive influx of high-energy neutrinos that would boil any living creature from the inside out. Hope you like your meals poached. The entire Earth could be vaporized in just a fraction of a second if the supernova was close enough. The shockwave would arrive with enough force to wipe out our entire atmosphere and even our oceans. The exploded star would grow brighter for about 3 weeks after the explosion, casting shadows even during the day. Even if life survived, the superheated gas from the supernova would emit deadly amounts of UV and gamma radiation. These rays would destroy the ozone layer, leading to the formation of nitrous oxide smog. We would all have to go deep underground and embrace our new lives as mole people to escape the lethal radiation and poisonous atmosphere. Unfortunately, there would be an increase in mutations and deadly cancers. And to top it all off, our phytoplankton, which account for almost 50% of all photosynthetic activity on Earth, would die off. Phytoplankton is vital to us and can absorb carbon dioxide from our atmosphere. Without it, we'd have a tougher time breathing. Global warming would accelerate even further beyond our control. And as an essential food source at the bottom of the marine food chain, a lack of phytoplankton would result in sea creatures becoming extinct. And eventually, humankind would too. So, like many what-ifs, almost everything dies.
No! No!
But there might still be a few lucky species of extremophiles that could survive the intense radiation. After a few hundred or thousands of years, the supernova would leave an impressive nebula in its wake. At the very least, we'd have a fantastic view in our night sky. Well, for those of us that can see.
Oh my god.
Is it a meteor shower? Space debris? No, it's something much, much worse. Our nearest neighbor is a full moon no more. The moon exploded and splintered into millions of fragments. Enormous lunar rocks are hurtling toward Earth. Could this wipe us off the face of the planet? How could the moon explode in the first place? And if we do survive, how would losing the moon change life as we know it? Okay, so how on Earth did the moon blow up? A blast mining operation gone wrong? A nuclear blast? A collision with a rogue planet? Whatever caused this catastrophe, you'd have to be packing some serious firepower to blow up the moon.
Guns. Lots of guns.
The largest nuclear bomb ever built, the Tsar Bomba, had the energy of over 57 million tons of TNT. Think that's strong enough? It's just a drop in the ocean compared to the amount of force you'd need to blow up the moon. You'd need the power of over 600 billion Tsar Bombas to destroy the moon. With anything less than that, the moon would just crack into pieces, and its gravity would pull it back together again. But if someone, or something, managed to explode the moon, it would spell bad news for us. The moon debris would scatter across the solar system, some into the abyss of outer space, and some headed straight for Earth.
Earth's gravitational pull would immediately start to attract the moon rocks. As the moon's remains start to pick up speed, they would come crashing down into the atmosphere. Luckily, most of the smaller debris would burn up before it reaches us. Any larger pieces that got through would be traveling much slower than a similar-sized asteroid. The damage they'd cause wouldn't amount to much. But is it just me, or is it getting a little hot in here? The moon chunks aren't causing much damage, but the endless barrage of debris on our atmosphere would start to heat up the Earth. The whole world would start to get hotter and hotter, eventually getting to the point of incinerating all life. Talk about a bad way to go. Oh, and if you're thinking about trying to evacuate Earth, you better do it as soon as possible. The moon debris, combined with all the satellites it would destroy in space, would make any trip out nearly impossible. But what if you did manage to get out of Dodge or hunker down in the deepest parts of the Earth? What would life be like in the aftermath? Well, for some of us, it wouldn't get any cooler. The moon helps stabilize the Earth's axial tilt. It's what gives us seasons. With a new tilt, some parts of the Earth could be constantly exposed to the sun. In the worst case, the polar regions could start rapidly melting, raising sea levels and drowning out parts of the world. As the debris settles, the skies could look a little different. The remaining moon rock might cluster around the Earth, forming a giant ring like Saturn. But don't stop and stare too long. Every once in a while, some of the debris could rain down onto the Earth. Over billions of years, the moon's gravitational pull slowed down the Earth's rotation, giving us our 24-hour days. Without the moon, the Earth would start to rotate faster and faster. We'd have shorter days and stronger winds. Birds and insects would have a tough time surviving the harsh winds. Not only that, ocean tides would start to die down into tiny little waves. The moon's gravity helps create tides on Earth. Bummed out that you can't rip some gnarly waves anymore? Well, dude, there'll be a much bigger problem. It would wipe out all of the sea creatures that rely on the tides and ocean currents for survival. Our whole world would be literally flipped upside down. The Earth would burn up. Our days would be shorter, and the moon wouldn't be there to light up the night sky. You start your day hearing wild news. Jupiter has just swallowed Saturn. And it doesn't stop there. Jupiter is on its way to swallow every planet in the solar system. How big would Jupiter get? What would you see from Earth? And would Jupiter get rings like Saturn? This is What If, and here's what would happen if Jupiter swallowed every planet in the solar system. Jupiter has swallowed a planet before. Around 4.5 billion years ago, a protoplanet slammed into the young Jupiter. The protoplanet was 10 times Earth's mass, made of rocky and icy material. Jupiter's core broke apart and denser material mixed with hydrogen and helium. A few billion years later, the heavy material settled back into the dense core that we see today. Now, swallowing a single planet is one thing, but could Jupiter eat up all 7? In this scenario, you're going to see the planets get swallowed from largest to smallest, although we're saving Earth for last. Jupiter's first victim would be Saturn. From Earth, you could see these gas giants as 2 bright stars. And if you were to look up at the night sky as Jupiter swallows Saturn, well, all you'd see is Jupiter getting super bright. But if you were closer to the action, you'd see complete chaos.
Jupiter is only 3 times heavier than Saturn, so it would be swallowing a planet that's almost its size. First, their moons would collide, creating massive amounts of debris. Some moon remnants would rain down on Jupiter, and some of the debris would float in space. As Jupiter was crashing into Saturn, Jupiter's surface temperature would become hotter than the Sun's outer layer. Whatever remained of Saturn would mix in with Jupiter's atmosphere. They would become one. Now, swallowing Saturn would increase Jupiter's mass and gravity by 30%. Jupiter would also sport prominent new rings from the shattered moons. Next, it would envelop the 2 ice giants, Uranus and Neptune. The 27 moons of Uranus would collide with the rings of Jupiter, adding to the floating debris. Uranus has an icy core made of water, methane, and ammonia, but Neptune's inner core is rocky. Regardless, both cores would melt as the planets crashed into Jupiter. Now, Jupiter would be almost 40% heavier, and it would head towards its first rocky planetary snacks. The rocky planets, Venus and Mars, wouldn't even make it to Jupiter's core. They'd burn up in Jupiter's atmosphere as if they were mere asteroids. Then, we'd see our last planetary neighbor disappear inside this bulked-up Jupiter. Mercury is even smaller than Jupiter's largest moon, Ganymede, so it would get ripped apart by Jupiter's rings, adding to the speedy debris. Now, only Earth and Jupiter would be left, and Earth would be in big trouble. But how would Jupiter go about swallowing our planet? Even in its normal state, without swallowing 6 planets, Jupiter's gravitational force affects Earth. Yeah, every 405,000 years, the pull of Jupiter and Venus makes Earth's orbit wobble. It causes hotter summers, colder winters, and more rainfall in the tropics. And now, Jupiter's gravitational pull would be over 40% stronger. But Jupiter's pull would still be no match for the Sun's gravitational force, so Jupiter would have to come for Earth just like it swallowed all the other planets in our solar system. Jupiter doesn't have a hard surface like the rocky planets. You could say Jupiter is a big, dense ball of gas. Its surface is defined as the point where its atmospheric pressure is equal to Earth's. Well, so could Earth simply pass through? No. Just like the rest of the planets, Earth and all life on it would be toast. First, we'd be bombarded by asteroids while passing through Jupiter's rings. I doubt anyone would survive this, but if they did, they would see the Earth igniting as it enters Jupiter's atmosphere. Jupiter is so massive that even if it were to swallow its 7 planetary neighbors, it wouldn't even double in size. Now, what would happen if Jupiter continued to grow? Well, even if Jupiter increased its mass by 400%, it would stay about the same size. But the extra mass would make Jupiter so dense that it would start pulling in on itself. Yeah, it would get smaller instead of larger. And if Jupiter were to increase its mass by 70,000%, well, it could trigger a fusion reaction and light up like a star.
About 50 billion rogue planets are roaming the Milky Way with no host star to hold on to. They don't give off any light of their own, and that makes them difficult to spot. Last time a stray planetoid the size of Mars smashed into Earth, it scattered our planet's young crust into space, where gravity glued those particles into what we now call the Moon. This time, it would be all hellfire and brimstone with no survivors left. And here's a timeline of how things break down. A few weeks before the collision, an unknown object would appear in the sky. It wouldn't happen overnight, no. We'd know something was coming. We'd see the planet slowly growing bigger, Until one day, it was as big as the moon. It would seem as if everything was unfolding at a relatively slow pace, but that's only because of the huge distances involved. Out there in space, the rogue planet would rush towards us at a speed of 11 kilometers a second. When the uninvited space intruder came into the moon's orbit, bad things would start to happen. The gravitational pull of the alien planet would make the tides on Earth 8 times larger than they are now. Floods would begin to rampage through the coastline cities. And still, the mega tsunamis are yet to come. 28 hours before the collision, the gravity of both planets pulling themselves towards each other would speed up the process. The incoming planet would hit a speed of 60 kilometers a second. Mega tsunamis would plot their way across the oceans. With this would come lightning storms, plus hurricanes and tornadoes so large they wouldn't have a number on the category scale. If you didn't book yourself a vacation aboard a spaceship that would take you to outer space, your time on this planet would be running out. 3 minutes before the collision, the rogue planet enters the Earth's atmosphere. Provided you hadn't already been killed by the lightning, hurricanes, flooding, earthquakes, or volcanoes, you'd see the rocky invader completely filling the sky above you. Nanoseconds before the collision, the atmospheres of both planets would be compressed together and glow brightly. It would get so hot that everything on the side of the Earth about to get hit would instantly vaporize. For the rest of the Earth, the ground would become scorching magma. Upon impact, the collision would cause friction between the two planets. Millions of tons of superheated rock would be sending a wall of fire in all directions. While the hellfire would rush across Earth's surface, the planet's inner core would be melting it from the inside out. This would have one big outcome. The Earth would collapse in on itself. The end of the era. If you did manage to get away in a spaceship, you'd see the massive remnants of both planets catapulted into different orbits. Some of them would hit other planets. Others would be fired out of the solar system entirely. Whatever was left would form a new asteroid belt encircling the sun. None of this would give any hint that there was once intelligent life on planet Earth. But hey, you can sleep well knowing that this won't ever happen. Well, most likely not. A mysterious interstellar object is on a collision course with Earth, and scientists don't know what it is. What could this new astrophysical object be? Where did it come from? Wait, why is it coming closer? Do you see this? What would this do to Earth? And you? This is What If. And here's what would happen if a hydrogen iceberg fell to Earth. In 2017, scientists discovered the first known interstellar object in our solar system. Meet Oumuamua, which means scout in Hawaiian. According to NASA, this cigar-shaped object is around 400 meters long. It was discovered as it was slingshotting around the sun at over 87 kilometers per second. The verdict is still out on what Oumuamua is. It could be a comet, asteroid, or maybe something else. One leading theory is that it's a hydrogen iceberg. That's because scientists observed Oumuamua accelerating away from the sun instead of floating toward it. It's as if this interstellar object had a little jetpack blasting it further into space. But if it blasted its way into Earth's atmosphere, would it trigger a deadly chemical reaction? If Oumuamua was solid hydrogen ice, it would have been formed in extremely cold conditions. Hydrogen sublimates or turns from solid to gas at a frigid minus 267 degrees. And because empty regions of space average out at a temperature of minus 270 degrees, it makes sense that this object could maintain its solid hydrogen structure. As it rounded our sun, that ice on the surface of Oumuamua would vaporize, and that would create the vaporous jets propelling the object straight at you, just like a rocket. This would also explain why Oumuamua has such a strange shape. It was heated by the sun, and it became smaller and thinner, like a used bar of soap. But while empty space may be frigid, the temperature around the sunny side of the Earth could get as hot as 121 degrees. This means our interstellar guest would continue to diminish in size as it traveled closer and closer to Earth. And that wouldn't be the hottest temperature Oumuamua would experience. Like other meteors that enter our atmosphere, it would heat up to a scorching 1,648 degrees. It would just melt before it could ever reach the surface. For this space iceberg to make a devastating impact on the ground, it would need to be massive. But that doesn't mean you'd be entirely safe from catastrophe. The real danger of this scenario is something much, much smaller: molecular hydrogen. Hydrogen is known as an indirect greenhouse gas. This makes it different than gases like carbon dioxide or methane. Greenhouse gases trap heat directly. Our atmosphere currently contains about 0.00005% molecular hydrogen. And if a hydrogen iceberg vaporized inside of it, this could accelerate the effects of global warming. As soon as hydrogen filled the atmosphere, it would react with hydroxyl radicals. These molecules are produced by water vapor, ozone, and sunlight. And they typically react with gases like methane, helping to reduce its concentration in the atmosphere. If Oumuamua released a lot more hydrogen into our atmosphere, the methane concentration would increase as well. And methane is 25 times more potent as a heat-trapping gas than carbon dioxide. Who knew that this interstellar visitor could come with a risk of growing global temperatures and sea levels, as well as more severe storms? But before you start picturing Earth-destroying scenarios in your head, don't worry, Oumuamua is long gone. And even if this stellar iceberg came back and set its course on Earth, it would need to be truly massive to cause that kind of damage. An asteroid is headed straight toward Earth. Initially, scientists thought it would miss us, but they've made some serious miscalculations. And now it's headed right toward our giant blue marble. What happens next? Does this mean the end of humanity? Can we change the trajectory of the asteroid? And why might this actually happen by the year 2029? Now, this sounds like a fun hypothetical, but an asteroid coming for Earth? It's no laughing matter. It could happen. Scientists had thought that asteroid 99942, also known as Apophis, might hit Earth by the year 2029. Apophis was discovered in 2004, and scientists have been closely monitoring it ever since. At one point, research suggested that the asteroid had a 2.7% chance of hitting Earth. Yeah, scary, I know, but since then, new calculations predict that the asteroid will whiz by Earth at a distance of 30,000 kilometers. Now, considering that the moon is 380,000 kilometers away, this asteroid will be incredibly close. But at least it won't be hitting us. And of course, calculations can be wrong. Let's say that in this case, they are, and Apophis is coming right toward Earth. Way ahead of schedule. The asteroid is going to hit us this year. Okay, let's see what we're dealing with. Apophis is 340 meters in diameter.
For reference, that's taller than the Eiffel Tower. But is it the worst asteroid Earth has ever seen? Nah, lucky for us, it's not even close. The Chicxulub asteroid that wiped out the dinosaurs was estimated to be 10 to 15 kilometers wide. So now we're dealing with Chicxulub's little brother. So what does that mean for us? Will humans go extinct from this impact? Well, more on that in a bit, but first, let's look at whether we have any chance of stopping this asteroid. Okay, the first step would be identifying the asteroid, which we've already done. We know how big Apophis is and that it's moving at about 30 kilometers per second. Now it's about the defense measures we could use. There's a couple being looked into right now. One of them being the kinetic impactor. This involves sending a spacecraft to collide with the asteroid, all in hopes of changing its velocity and trajectory. NASA has run some successful tests using this method, so that's an option. Next would be what's known as a gravity tractor. A large spacecraft would fly next to the asteroid, and over time, its gravitational pull would eventually change the asteroid's path. Laser ablation is next on the list of options. Yeah, special lasers could be used to vaporize parts of the asteroid's surface. This wouldn't destroy the asteroid, but it could alter its direction as well as the size and impact of it. Yeah, and last but definitely not least is the final nuclear option. Yeah, that's right. As a final resort, we could nuke Apophis. And with the asteroid's massive size, as well as the lack of time we have before it hits us, this might be the only option. But don't be too quick to hit that red button. Nuking an asteroid can have some serious downsides. It could split the asteroid up, causing it to fragment. Then you'd have dozens more minor asteroids and meteors coming toward Earth, making the impact even more devastating. Yeah, and these wouldn't just be regular asteroids either. Because of the nuke, they'd be radioactive. This would mean that significant parts of the world would not only be impacted with asteroids and meteors, but they'd also experience radiation levels only seen during nuclear warfare. So, what's the best option here? Well, it's tough to decide. Let me think about this for a second. Oh, well, it's too late now. We took too long deciding what to do, and now the Apophis will be here any second. Brace yourselves. You wouldn't get a good look at the asteroid impact, and that's because it landed somewhere in the middle of the Pacific Ocean. This is the most probable spot an asteroid would land, considering the Earth's surface is mostly water. So you might not see the impact, but you definitely notice it. Once the asteroid hit our planet, it would be as devastating as several thousand nuclear bombs going off, just with a lot less radiation. It would make a crater at the bottom of the ocean as big as 1 kilometer wide. And what would happen next would be even more devastating. The massive impact would create giant tsunamis that would rage worldwide. Several hours after the asteroid touches down, cities along the Pacific coast would feel Apophis's impact. The tsunamis would travel across the Pacific Ocean at jetliner speeds. Places in North and South America like California, Peru, and Chile would face towering waves. Due to the energy from the asteroid, it would likely cause waves taller than 30 meters. Waves as big as this are responsible for one of the most devastating tsunamis ever. In 2004, Southeast Asia experienced a tsunami that generated waves over 30 meters tall, killing over 230,000 people. But instead of waves like these reaching just a few countries, this would be a complete global catastrophe. Not only would the Americas experience these tsunamis, but so would Japan, Australia, and the Philippines. These places would all be devastated by the impact.
Tsunamis like these would likely destroy millions of lives. So that's what would happen if an asteroid hit the ocean, but what if it made impact on land? Well, to start, the impact crater would be much more significant. We know that an asteroid's impact crater can be anywhere from 10 to 20 times the size of the asteroid itself. And now there isn't any water to soften the blow, so the diameter of the crater could be as large as 7 kilometers, with a depth of over 1 kilometer. Depending on where it lands, this asteroid could be big enough to devastate entire cities. The initial impact would send a massive shockwave that spreads for hundreds of kilometers. This could destroy entire buildings and seriously damage infrastructure. It would throw tons of dust and debris into the atmosphere. It could get so bad that it could cause an impact winter. This would be caused by a dust cloud temporarily blocking the sun, causing crops and vegetation to die out, which creates even more casualties. Something like this could last weeks or months and be an overall environmental catastrophe. This entire event, during and after, could cause millions of people to be killed, depending on where the asteroid lands. We can only hope that an asteroid collision like this would land as far away from people as possible. But now for the good news. If Apophis did somehow make an impact, it wouldn't cause a mass extinction like the Chicxulub asteroid did for the dinosaurs. The event would be incredibly traumatic and have lots of casualties, but humanity as a whole would live to see another day.
This is the most powerful object in the universe. The biggest spinning magnet to ever exist. It's the cosmic equivalent of a great white shark. But it wouldn't eat you. It would just turn all your atoms to dust. This is What If, and here's what would happen if a magnetar entered our solar system. If you thought neutron stars were big and scary, well, you haven't heard of their more powerful stellar cousins yet. Like neutron stars, magnetars are leftovers from supernova explosions. They're just packed with a lot more matter. Their density is so high that a single teaspoon of a magnetar could weigh in at 1 billion tons. They're also the most magnetic stars we know about. We use a unit called a Gauss to measure the strength of a magnetic field. Earth's magnetic field is only about 0.6 Gauss. The magnetic field of a magnetar can be as strong as 1 quadrillion Gauss. How long would it take a stellar monster like that to rip our planet apart? It wouldn't be the worst thing in the world if a magnetar was sitting quietly in our galactic neighborhood, but if it decided to stop minding its own business, there are 2 ways a magnetar could end all life on Earth, together with the planet itself. It could get too close to the planet. You'd start to feel its presence when it was about halfway between the Moon and the Earth. At that distance, a magnetar would erase the information off all your credit card's magnetic strips. Whatever you do, try not to get closer than 1,000 kilometers from a cosmic invader. Because if you did, your atoms would get stretched out of shape. Your bioelectric field would get scrambled, disintegrating your molecular structure. And your body would just disappear. Alternatively, a magnetar could destroy us from much, much further away. As if being the biggest spinning magnets in the universe isn't enough, magnetars can also be affected by something called starquakes. Starquakes happen when a star's crust cracks, letting massive amounts of radiation out into space. This blast of radiation could compress the Earth's magnetic field and partially ionize the Earth's atmosphere, even from 50,000 light years away. We know this because we've already come a little too close on at least one occasion. In 2004, gamma radiation from a magnetar reached our planet from outside our Milky Way galaxy.
In just 1/5 of a second, it released more energy than our sun has released over the last 250,000 years. Move that magnetar and its starquake up to 10,000 light years away, and things would get much worse. First, it would destroy our ozone layer. Then, it would wipe clean most of the planet's surface, along with all life as we know it. The truly scary part of this is that we wouldn't even know the magnetar was heading towards us. It would be a blink and you're gone scenario. I won't lie to you, there are magnetars close enough that if one had a violent starquake right now, we'd all get wiped out very fast. When scientists began their search for these interstellar monsters 40 years ago, they didn't realize how many of them exist out there. You might find some comfort in the fact that most magnetars don't make it much past their 10,000th birthday. Their short lifespan ends with them becoming neutron stars. Still dense and still magnetic, but not nearly as dangerous as a magnetar. So, we all know about the Big Bang, right? The cosmic explosion that created our universe? Well, as with everything, there is a beginning and an end. This is the Big Rip, the ultimate fate of our universe. It will be a cosmic event that will tear apart galaxies one by one. Stars, planets, you, everything will be eviscerated. Luckily, it's not going to happen for another 20 to 30 billion years. But what if we weren't so lucky? What if the Big Rip happened tomorrow? What would happen to our planet? And would this really be the end of everything we know? This is What If. And here's what would happen if the Big Rip happened tomorrow. In the future, the Big Rip will literally tear apart the universe. A process that will take about 1 billion years from start to finish. But the mad scientists here at What If have sped up the clock.
So that's, coming along.
The Big Rip is now scheduled for tomorrow. Try to get some sleep now, you've got a big day ahead of you. So, how will this go down exactly? Well, something called dark energy is driving the expansion of the universe. So, as the universe expands, so does the dark energy. During this expansion, dark energy transforms into something called phantom energy. And no, it's not just going through a goth phase. If this transformation happens and the phantom energy increases faster than the expansion of the universe, the Big Rip is set to make its debut. Think of it like a water balloon, and the water is filling the balloon up too fast. Eventually, the balloon will pop. But in this case, it's not a balloon, it's the entire universe. Meanwhile, back on Earth, you're going to have a very, very interesting day. Imagine that you're looking up at the beautiful night sky and you see a shooting star. Wait, that's not a shooting star, that's the Andromeda Galaxy. And it's moving away from us. That's weird. So, since you're confused about what's happening, you whip out your telescope and try to get a closer look. You try to look for other galaxies in the local group of galaxies, but they're gone. Suddenly, all the stars start moving away from you. It looks like you're traveling at light speed. That's the Milky Way breaking apart. You see Saturn shooting through the night sky, and oh my, there goes Jupiter, and oh gosh, you got Mars too. Then, all you see is blackness. The sky is empty of any stars. There's just complete darkness. Okay, it can't get any worse, can it? Well, now the ground is shaking and you see massive tidal waves, earthquakes, and volcanic eruptions. This is because the moon is breaking away from Earth's gravitational pull. But before you even have a chance to react, the Earth will be snatched away from the sun and it's going to get really, really cold. And for the grand finale, our planet will be torn apart and explode. Luckily, you'll be dead by the time this happens. Yeah, you heard me. I said luckily. If you manage to survive long enough during the explosion, you'd be able to witness your own disintegration. All of your molecules would be getting pulled apart. As you unraveled, all the atoms that make up your body would be swirling around, disintegrating into electrons and protons and neutrons. And then, poof, they'd rip apart as well, leaving nothing behind. Nothing is sacred to the Big Rip. And as the universe keeps expanding, it'll get ripped apart too. The universe is gone. Just gone. Or at least, it's gone as we know it. We have no idea what would occur after the Big Rip. That's totally unknown. So, sorry for the spoilers, but that's how we close the book on our universe. Have you ever heard of Medusa? The snake-haired Greek monster who turns people to stone with a single glance? Well, she may just be a myth, but there is an area so deadly that it could actually turn you to stone. The infamous Lake Natron. What makes Lake Natron's water so dangerous? What kind of creatures live there? And could you survive if you fell in? This is What If, and here's what would happen if you jumped into Lake Natron. Before we take the plunge, we'd better look at what Lake Natron is made of. Much like the Dead Sea, this Tanzanian lake doesn't run off into any oceans or rivers. This allows it to soak up all that salty desert rain. Soupy. Yet, what makes it especially lethal is its close proximity to the active volcano Oldoinho Lengai. The volcano spews a rare kind of lava, rich in sodium and potassium carbonate, called natrocarbonatite, or natron for short. Releasing into the water, this mix of sodium carbonate and sodium bicarbonate were key ingredients once used in Egyptian mummification, creating the perfect preservative in lake form. The whole chemical composition is extremely alkaline, with pH levels of 10.5, close to that of ammonia. This gives the lake its rosy hue. Any birds who happen to take a dive and don't make it out become calcified in a hardened stone-like husk. Oof. Talk about killing two birds with one stone. In 2013, wildlife photographer Nick Brandt was one of the first to document this phenomenon. He discovered several stone birds and other unlucky animals in the dry season when the water had receded. He theorized that since the lake is so mirror-like and reflective, the birds must have flown right into it, as if it was a big glass door. But despite so many birds dying in Lake Natron, there is a particular species flourishing. Turns out, the lake's toxic waters provide a safe haven from predators, making it perfect flamingo flocking grounds. So, if flamingos can handle it, couldn't we? Well, it's not that simple, unfortunately. Flamingos thrive in salty lakes because of their tough skin and scaly legs, which prevent burns. They can drink the fresh water from nearby springs or geysers at the edges of the lake, and if they're desperate enough, they can even filter salt water with special glands in their nasal cavities. And to top it all off, their strong stomachs allow them to feed on the toxic algae found throughout the lake. This makes Lake Natron the perfect spot to raise and protect their young. So let's say we tried to live like a flamingo and decided to take a dip. Well, depending on the time of year, The water can be up to 60 degrees, which is hot enough to cause third-degree burns in 5 seconds or less. Also, I wouldn't plan on doing any fancy dives or cannonballs, as its shallowness is also chock full of sharp, salty structures. You wouldn't be turned to stone instantly, but if you happened to drown and stay submerged, your entire body would harden and be preserved. If people found you hundreds of years later, you might still have your hair and organs intact. Yeah, still looking spiffy after all those years. Like mummification, natron's super high alkalinity stops the decomposition process. Thankfully, this means you'd be safe from vultures or any other hungry scavengers looking for a snack. If you waded into the lake at a time when the water temperature was lower, it could feel more like a hot tub. But your eyes or any open wounds would sting like crazy because of all that salt. I'd strap on some goggles if I were you. In 2007, another bird flew straight into this chemical cocktail. A group of wildlife videographers plunged into Lake Natron's toxicity when their helicopter crashed. The pilot suffered a broken leg and another passenger had a broken hip. Incredibly, one of the passengers managed to struggle to shore and alerted some of the Maasai tribespeople nearby. They quickly built stretchers and carried the injured to land in the nick of time. Even though you could survive Lake Natron's waters, I'd stick to a swimming pool if I were you.
You know, videos about falling into things very popular on What If. You may have seen what if you fell into the world's deepest hole, what if you fell into a pool full of piranhas, what if you fell into a pit of snakes. Of course, there was Lake Natron. We've got some more deadly lakes coming up for you later on in this marathon. But first, what I want to say to you is Oldoño Lengai. You may recall that's the name of the volcano in Tanzania that feeds the natural carbonatite into Lake Natron. So it's goggles and wetsuits if you want to go swimming in Lake Natron, but what if you went to Antarctica? Well, it'd be parkas and boots, obviously, but have you ever thought about what's underneath Antarctica? It's not just ice floating in the middle of the ocean. There is land underneath there, and it's not always hospitable.
Deep beneath the thick layer of million-year-old ice, something is lurking quietly, waiting to rip through the rigid ice sheets. No, not that. This enormous icy wasteland is sitting on top of a volcanic ridge. And in our hypothetical world, these volcanoes are about to wake up. Could their scorching lava wipe out the surface of Earth? Or would the thick Antarctic ice stop the lava before it makes our planet uninhabitable? This is What If, and here's what would happen if Antarctica's dormant volcanoes woke up. Antarctica is the coldest continent on Earth, and it's quite mysterious. We didn't know it had active volcanoes buried underneath it until 2013, when scientists accidentally detected 2 clusters of small earthquakes. Now that we've scanned Antarctica with ice-penetrating radar, we know that there are many more volcanoes hiding below the ice. 138 to be precise. But that's only the ones we know of. How many more could be hibernating there? And how much trouble would we be in if all those volcanoes suddenly decided their slumber was over? It shouldn't be too surprising that these ash-breathing ruptures have been buried underneath Antarctica's ice shield this whole time. After all, volcanoes are easy to come by, even outside our home planet. There are volcanoes on Jupiter's moon Io, Saturn's moon Enceladus, and on our planetary neighbor Venus. But let's not waste our time there. We've got our own world to save. Do you know what happens when a volcano erupts? There are usually warning signs before the real action begins, like the waves of earthquakes. They indicate that there's molten rock moving beneath the surface. Then, lava and ash join the party, accompanied by heated gases. It depends on a variety of scenarios and the kind of lava involved, but on average, lava moves at about 10 kilometers per hour, pretty easy to outrun. But when a major eruption occurs, a volcano releases superheated gases and ash. Combined, they create something called a pyroclastic cloud. These things are hot, reaching up to 700 degrees, and they can move at 80 kilometers per hour. Being trapped by one of these would mean the end of days for you. But Antarctica's volcanoes are a different story. They're buried under layers of ice that are more than 4 kilometers thick in places. We wouldn't be dealing with volcanic gases making their way to the surface, at least as far as one eruption goes. The heat released would melt massive caverns in the ice, creating substantial amounts of meltwater. And that's when things would start getting ugly. The newly created meltwater would cause the ice above it to move more rapidly. The Antarctic ice cover would begin heading into the ocean. From there, the domino effect would kick in. The huge weight of the ice puts all that pressure on volcanoes, keeping them stable. But decrease that pressure, and a volcano gets limbered up, and magma finds a way out through an eruption. In the case of Antarctica, multiple volcanic eruptions could wake up over 100 other volcanoes and destabilize the entire region. As the volcanoes continued to blow their tops, more meltwater would be created, causing more of the Antarctic ice to slide into the ocean. Antarctic ice would be enclosed by warmer ocean currents. On one hand, we'd get a new look at Antarctic bedrock that's been hiding under the ice this whole time. On the other hand, the ice wouldn't just disappear into thin air, it would melt. And if all of Antarctica's ice melted, it would raise the global sea level by about 60 meters. Rising sea levels could contribute to major storms moving slower and dropping more rain. Hurricanes and typhoons would wreak havoc on the Earth's surface. Wildlife along coastal areas would lose their habitats, and agricultural soil would become contaminated with salt. Extensive flooding would push millions of people away from the coastline. If the eruptions happened in the span of one day, we'd be looking at thousands of deaths and storms wiping out everything floating in the oceans. But let's go back to Antarctica for a second. Now that all the ice has melted, what about the rampaging magma? The good news is it wouldn't turn the Earth into a lava world. After all, the eruptions would occur underwater. The hot magma would solidify in the cold water of the Antarctic Ocean and maybe add more real estate to Antarctica's own bedrock. But things don't end there. When volcanoes erupt on land, they spew out heated gases, including carbon monoxide, methane, carbon dioxide, and nitrogen. To go along with this, there's usually some water vapor thrown into the mix. By some estimates, volcanoes are responsible for the release of 645 million tons of carbon dioxide every year. If the Antarctic volcano eruptions turned out to be powerful enough, they would blow open huge expanses of ice, allowing the release of even more toxic greenhouse gases. When one of Antarctica's surface volcanoes, Mount Takahe, erupted some 18,000 years ago, it spewed out the chemicals that ate a hole in the ozone layer. That hole warmed up the southern hemisphere and caused glaciers to melt. It helped wrap up the last ice age.
If you traveled to the deepest points of Earth, what would you find? Lost cities? Mythical sea monsters? Rivers of gold? Probably not, but there's still a lot to discover, so join me as we travel deep underneath the surface to explore some of the most inhospitable places on Earth. What lives at the bottom of the Mariana Trench? How much of the ocean is unmapped? And what is mined deep below the Earth's surface? This is What If, and here's what would happen if you explored the deepest points on Earth. Not many people can claim that they've been to the deepest points on Earth, but Victor Vescovo can. From 2018 to 2019, Vescovo led an expedition that visited the deepest points in all 5 oceans. The 5 Deeps expedition covered 87,000 kilometers in just 10 months and completed 39 dives using a small submarine. For your trip, you're only going to visit one trench, the Mariana Trench. You'll need to save about $750,000 for the trip, but you'd be one of the few people to explore this deep. What would you see as you descend? First, you'd need to travel to Japan. From there, you'd take a submarine about 2,000 kilometers out into the Pacific Ocean. Challenger Deep, the deepest point of the Mariana Trench, is almost 11 kilometers below the surface, and it would take about 2.5 hours to reach it. There will be a lot to look at in the beginning of your descent. The first 200 meters below the surface is where most ocean life thrives. As you travel deeper, it becomes darker and the less wildlife you'd see, though you'd still get to witness the occasional whale diving for food. You'd see your first deep-sea creature, the fangtooth, at 1 kilometer below the surface. This appropriately named fish is 16 centimeters long with 2 giant teeth. To make room for them, the fangtooth has 2 sockets beside its brain. As you travel deeper than 2,500 meters, there are no more whales. They don't usually dive down this deep. But when you hit 8,000 meters, you'd encounter the Mariana snailfish. At this point, the atmospheric pressure is nearly 1,100 times what you feel at sea level. If you weren't inside a pressurized submarine, it would be like having the weight of a fully loaded truck on your head. Those little snailfish out there must be pretty strong to withstand all this intense pressure. Eventually, you'd reach the very bottom, the Challenger Deep. If you look closely, you might spot an amphipod species, Hirondellea gigas. These small, deep ocean creatures are only about 3 centimeters long. And that's about it down in the Mariana Trench. No secret treasures, hidden cities, or sea monsters. Next, it's time for you to travel to the world's deepest sea volcano, the West Mata volcano. This underwater site is located southwest of the Samoas. You'll need to rent another submarine to travel down 1,200 meters below the surface. But since you just visited the Mariana Trench, it should be no problem for you. If you're lucky, the volcano would be active and you would enjoy seeing lava fountains and glowing bubbles. Just be careful of all the debris that erupts into the ocean. Both the West Mata volcano and the Mariana Trench are natural deep points on Earth. But what about something that's man-made? The Mponeng gold mine is the deepest operating mine in the world. Around 4,000 miners work in it every day. And despite safety precautions, it's still risky. In March 2020, a seismic event killed 3 miners who were 3.5 kilometers below the surface. To get to the mine, you'd need to travel to the Gauteng province in South Africa. You'd take the elevator, known as a cage, with 119 other workers until it reaches 2.5 kilometers below the Earth's surface. As the elevator doors open, you'll notice the heat. It's about 30 degrees. And that's only because the mining company has created a system to cool down the air.
Without fans blowing over a mixture of ice and salt, the mine would be a whopping 60 degrees. Why? Because you're so deep in the earth that its inner heat is warming up the surrounding atmosphere. You'd only be 2.5 kilometers underneath the Earth's surface. To go lower, you'd need to walk or drive the rest of the way. You'd be at the bottom of the mine when you reached 4 kilometers. That's as deep as 10 Empire State Buildings. Luckily, there are no cave creatures to worry about down here. The only life down here, other than the miners, is monotypic bacteria. While the Mpening gold mine is impressive, all of the deepest points on Earth are in oceans. According to NASA, over 80% of the oceans remain unmapped, unobserved, and unexplored. And if we want to continue to explore these areas, we're going to need to take better care of our planet. They're not the biggest falls in the world, not by a long shot, but they're certainly among the most famous. Niagara Falls attracts millions of visitors from around the world every year. People come for the history. They come for the romance. They come for the spectacular view. But some people just can't get close enough. This is What If, and here's what would happen if you fell into Niagara Falls. There are 3 different waterfalls that make up Niagara Falls, but the one that gets all the attention is the Canadian Horseshoe Falls. The Canadian Horseshoe Falls is about 57 meters tall and 670 meters wide. Water rushes over its edge at a peak speed of 109 kilometers per hour, dumping about 2.8 million liters of water over its edge every second. Considering its height, its speed, and its raw natural power, it's hard to believe that anyone could survive a trip over the falls. And yet, it's been done several times. Was it skill? Or was it luck? How do you survive a fall into Niagara Falls? The first person to survive a trip over Niagara Falls was Annie Edson Taylor. In 1921, on her 63rd birthday, she crawled into an oak and iron barrel and floated right over the edge of the falls. Taylor performed this stunt for money and fame, but she didn't earn much for her feat. Nonetheless, daredevils seeking to follow in her footsteps were not deterred. In 1928, for example, Jean Lussier went over Niagara Falls in a 182-centimeter rubber and steel ball lined with 32 inner tubes. Lussier survived the fall and spent the rest of his life selling souvenirs to tourists. Not all the daredevils were as lucky as Taylor and Lussier. In fact, of the 16 people who've tried to beat the falls, just a little more than half have lived to tell the tale. To date, only 5 people have survived an unprotected fall down the Canadian Horseshoe Falls. The first and youngest was Roger Woodward in 1960. He was only 7 years old at the time when a boating accident caused him to be swept overboard and over the edge of the falls. Woodward was rescued shortly after and made a full recovery after spending just 3 days in the hospital being treated for a concussion. Today, that event is still referred to as the Miracle at Niagara. Most rescuers and experts at Niagara consider unprotected survival stories to be blind luck. But there are some strategies that might just save your life if, for any reason, you find yourself hurtling 109 kilometers per hour in freezing cold water towards the edge of a 57-meter drop. The first thing you need to remember just before you go over is to take a really deep breath. When you reach the bottom, there will be so much water swirling around you, not to mention the intense pressure of the water falling from above that you could easily suffocate. So, taking a big gulp of air before your fall could buy you some time. You'll also want to take precautions to protect your head. If you can, orient yourself so that you fall feet first. Then you'll want to wrap your arms around your head with your elbows over your nose and clench your eyes and mouth shut as tightly. Incredibly lucky if you survive the fall, but that doesn't mean your ordeal is over. The water temperature below the falls is around the freezing mark, which gives you about 15 minutes to get out of there before hypothermia kicks in. You'll likely be badly bruised and terribly disoriented, but if you can stay calm and focused, you might just be one of the lucky few to survive a fall into Niagara Falls. Of course, the best way to survive is to pay attention to the warning signs and respect the safety rails. After all, the falls are huge. Do you really need to risk your life to get a closer look?
All that stands between you and a pool of boiling, rotten egg-smelling, acidic water is a humble boardwalk. And your good judgment. Stray off the path, and you could be headed toward quite the swim. Heads up, scorching temperatures would be just the start of your problems. How long could you survive your accidental dip? How would it feel to swallow these colorful waters? And why might there not be anything left of you to save? This is What If, and here's what would happen if you fell into a Yellowstone hot spring. Yellowstone National Park is one of the most iconic in the United States, and it's situated atop a volcanic hotspot. If you decided to take an off-trail hike, you could accidentally walk right into Emerald Spring. This hot spring is located in the Norris Geyser Basin, and it looks spectacular. Except you'd notice that the visuals don't make up for the stench. Ugh. Yeah, you'd catch a whiff of what smells like rotten eggs. That's the result of sulfur-eating microorganisms that create sulfuric acid. The acid evaporates and turns into hydrogen sulfide gas, which gives off a putrid aroma. Oh. Get a little closer and you'll be able to feel that the green waters are hot. Sizzling hot. There's no way you'd even want to stick a toe in them. But that might not be up to you. As you approached the dazzling but stinky hot spring, the ground around it would seem solid. And then you hear a crack. The ground at your feet gave way to your body weight. You were standing on a delicate crust formed by underground minerals dissolved by the water and then redeposited on the surface of the spring. All of this made the crust as thin and fragile as a sheet of ice. Your whole body would be completely submerged. You'd now understand why the word hot in hot springs is not an understatement. The blazing temperatures, hitting 82 degrees Celsius in places, would send a sharp pain through your skin. That's dangerously close to water's boiling point. For context, temperatures of 50 degrees Celsius can give you third-degree burns in 5 minutes. If you fell into Emerald Spring, chances are you'd be dead in 3 minutes or less. Now, before things get really nasty, you could try to push through the pain and pull yourself out of this mess. But even then, the outcome wouldn't be pretty. You would end up in a hospital in critical condition, clinging to your life. But if you didn't make it out in time, you'd begin to boil from the inside out. And this would be just the agonizing start of your very unavoidable demise. You see, hydrothermal vents help turn Emerald Spring into a potent acid bath by perpetually infusing it with chemical microbes. On top of that, microorganisms compound the problem by breaking off pieces of the surrounding rock and adding sulfuric acid to the pool. All that makes falling into Emerald Spring the near equivalent of dousing yourself with hydrochloric acid. When Emerald Springs water touched your skin, it would cause your tissue to swell and bubble. If it wasn't for your gurgling, you'd be able to feel the popping of your exploding blood vessels. You'd start to bleed out. The fat under your skin would also begin to bubble, and with all that screaming, you'd swallow more and more liquid acid that would burn through your stomach and destroy your internal organs. If your lifeless body wasn't pulled out in time, all that would remain of you would be a thick coat of blood, fat, and tissue floating on the top of the emerald green water. After a 23-year-old man fell into a hot spring in the Norris Geyser Basin, authorities had to delay retrieving his body due to a thunderstorm. The next day, nothing of the unfortunate visitor's body remained. Urban legend has it that all the authorities found were his wallet and flip-flops. Sadly, he's just one of 22 people known to have died from hot spring-related injuries in and around Yellowstone since 1890. In a best-case scenario, you would end up in critical care battling third-degree burns. Worst case, you're dissolved into a fizzy goo. So follow the park rules and don't wander off the designated paths.
Hey, hot enough for you? Yeah, I hate when people ask me that too, it's so banal. But in actual fact, it has been hot enough for me. People in regions all over the world, including mine, have been suffering through some pretty intense heat waves lately. I'm not gonna lie, it's been pretty uncomfortable, not to mention pretty stinky, if you know what I mean. But what if you lived in the hottest place on Earth all the time, year round? 40 degrees Celsius, 100 plus Fahrenheit heats every day. Well, there are people who do it. Have a look.
Ever wonder what it would feel like to step into an oven? Welcome to Death Valley, California. Temperatures here can climb to a scorching 54 degrees Celsius, which is as cozy as the internal temperature of a steak. In Death Valley, it's so hot you could fry an egg without a stove. But how soon would you get fried yourself? What would your days in the hottest place on the planet be like? What could you do to survive this intense heat? And what could happen to your body if you weren't careful? This is What If, and here's what would happen if you lived in the hottest place on Earth. It's so hot you can barely breathe. This national park that stretches across California and Nevada might as well be hell on Earth. Located 86 meters below sea level, it's the lowest point in North America. And the surrounding mountains trap the superheated air like an oven. For 5 months of the year, temperatures hover around 48 degrees. You'd think that life there would be unsustainable, but it turns out that Death Valley isn't always dead. It comes to life in the spring as colorful wildflowers bloom and the temporary lakes fill the lowlands. And besides the tourists visiting the park, around 500 people live there all the time. So pack your bags, you're moving to the scorching hot desert to join them. Life in Death Valley would be very different from anything you may be used to. Not just because of the heat, but because it's quite a commute to, well, anywhere. The nearest high school and shopping center is an hour away. It's a 2-hour drive to the closest major city, and there are no doctors, dentists, or restaurants around. Despite this, or because of this, there's a tight community in Death Valley. In the Cow Creek complex, residents of its 80 units share a gym, a playground, and a library. And since they don't get many visitors during the hottest times of the year, they end up spending a lot of time together. Though there isn't much of an entertainment scene in Death Valley, there's a lot to see outdoors. I mean, after all, we're talking about a national park. You could listen to the tiny pops and pings of billions of salt crystals bursting apart in the heat. Maybe enjoy the view of the colored hills thanks to the oxidation of natural metal deposits in the mountains. You could swim in a water-filled cavern, and if you're lucky, you could even catch a devil's hole pupfish, a rare fish that can withstand the hot water. Life in Death Valley doesn't sound so bad, except for that. It would take some adjusting to the heat. When our body temperature reaches 41.7 degrees, it can become life-threatening. This is known as hyperthermia, and it can lead to deterioration of internal organs and eventually death. In the climate extremes of your new home, you could easily heat up to the point of hyperthermia. Your best bet would be to take it slow. First, don't forget the sunglasses, as the salt-covered basin can be blinding under the sunlight. Make sure you always have sunscreen and protective clothing, and avoid staying outside in the warmer hours, usually from 4 to 5:30 p.m. If you don't want to die of hyperthermia, you should prepare before you even set foot in the desert. Your ability to survive in a hot climate is largely determined by your body shape and size. That's because heat is a byproduct of cell metabolism. So, larger animals with larger bodies and more cells typically produce more heat. Dropping a few kilos or pounds might be a good idea to adjust faster. Most people adapt to the heat after a few weeks, but it could take you a full year to get fully adjusted. At this point, you'd have a lower core temperature and your blood vessels would increase blood flow to your skin. You'd also start sweating more. Not that this should be a problem. And once you start wearing a sweater at 27 degrees, you'd know you're officially acclimated. Feel like upping the stakes of your late-night skinny dips? Well, welcome to Lake Neos, one of the most dangerous lakes on the planet. Here, your cannonball might just take thousands of lives. What makes Lake Neos so deadly? How much damage could it cause? And how bad a splash will you make by falling in it? This is What If, and here's what would happen if you fell into Lake Neos. In the northwest region of Cameroon, Africa, over a volcanic crater lies Lake Neos, a small lake with depths of about 210 meters. Crater lakes like Neos tend to release carbon dioxide due to volcanic activity deep below. Usually, this carbon dioxide dissipates slowly as the lake naturally shifts. But if the lake stays still enough, the gas dissolves into the water and continues accumulating there, steadily turning it into a ticking time bomb. So, what would happen if that water were suddenly disturbed? Neos is one of only 3 lakes known to accumulate deadly levels of carbon dioxide. Agitating this kind of lake could cause something called a limnic eruption. But hold on, let's not get too far ahead of ourselves. You'd have a front row seat to this catastrophe, and without even knowing it, you'd be the trigger of a major disaster. As your body sank into the deadly waters of Lake Neos, the dissolved carbon dioxide would rise to the surface. The lake would start to bubble, and these bubbles would cause even more turbulence. Have you seen the famous Diet Coke and Mentos eruption? Yeah, that would be you. a 90-meter water jet would explode into the sky, sending you flying as high as Big Ben in London. We'll say you're lucky enough to survive the drop, but you'd still have all the carbon dioxide to deal with. In 20 seconds, all of the accumulated gas would be unleashed in a cloud over 1 kilometer wide. It would spread as far as 25 kilometers away from the lake, and it would travel at a speed of up to 48 kilometers per hour, silently choking most of the living creatures in its path. If you were in a village nearby, instead of soaking in Lake Neos, you'd hear a strange rumbling sound, followed by the sight of a white mist rising from the lake. The deadly gas cloud would then usher in a gust of wind, putting out any fire that might be around you. This is because carbon dioxide gas is heavier than air, and at high concentrations, it displaces oxygen. No oxygen means no combustion and no fire. But it also means you wouldn't be able to breathe. You would drop dead after a single gasp of air. This is exactly what happened in 1986 when a landslide or an earthquake triggered a limnic eruption on Lake Neos. In total, 1,746 villagers and 3,500 livestock died instantly. No one was there to witness how its usually serene blue waters turned red from all the iron churned up from the bottom. Still up for a swim at the most dangerous lake on Earth? This is the deepest hole mankind has ever dug. It's a straight drop into the bowels of the Earth. For 20 years, Russian scientists and engineers drilled deeper and deeper, hoping to uncover whatever mysteries the hole may hold, earning it the ominous nickname of the Well to Hell. What would happen if, for whatever reason, you fell into this hole? What would happen to your body? How deep would you fall? And what would you find at the bottom? This is What If, and here's what would happen if you fell into the deepest hole on Earth. So, you managed to take the plunge. You'll start plummeting at about 10 meters per second, and every second after that, it gets faster. If we take terminal velocity out of the mix and assume you weigh 80 kilograms, you'd eventually reach a speed of 490 meters per second. So, as you fall deeper and deeper, what would happen to your body? Falling at such high speed, you'll start to notice things getting a little toasty as your heart rate starts to elevate and panic sets in. You might find it getting a little harder to breathe. Why? Well, at 150 meters down, your poor lungs would be getting crushed by the constantly increasing air pressure. You might also encounter what cave explorers like to call foul air, deadly underground pockets of carbon dioxide. Great. Things can't get much worse, can they? Yeah, they can. Less than 3 kilometers into the trip, you're going to see your skin start to burn up. Literally. And as you continue to fall, it only gets hotter and hotter. This is because you're being pulled closer to the gravitational center of Earth and its molten core, which is baking the planet from the inside out. A temperature of 80 degrees can severely burn a person's skin in less than a second. At this point in the hole, you're feeling heat of over 180 degrees. On the bright side, you've probably already passed out. When you fall out of a plane, you can pass out from lack of air, but
wake up as oxygen becomes more available and catch a glimpse of the ground as you smack into it. Down here, you're not waking up. Okay, so things don't look good. But let's say you came prepared and wore an atmospheric diving suit to help with the increasing pressure as you fell. It's heavy, but it will help with that breathing problem. In 2016, Luke Akins jumped from over 7,600 meters without a parachute and survived without a scratch. Granted, he landed in a net, so if he's allowed to have one, you can too. Okay, so you land in the net. Great. Including your terminal velocity, you have successfully managed to free fall 12 kilometers straight down at a speed of 200 kilometers per hour. How long were you falling? Well, factoring in air resistance and terminal velocity, the whole trip took just over 3 minutes. And now, you've got to get back out. This is not going to be easy, but it may not be impossible. In 2018, Alex Honnold managed to scale Yosemite National Park's 914-meter tall El Capitan granite wall without ropes in just 4 hours. Granted, he wasn't wearing a huge suit like you are. This big outfit wouldn't help you climb, and you would need some climbing equipment to help you get a better grip on the walls of the hole. But what's it like down there? To answer that, let's flash back to 1971 in the Kola Peninsula of northwest Russia, to be exact, when Russia began work on the Kola Super Deep Borehole. Measuring in at just over 12 kilometers deep, the Kola Super Deep Borehole is the deepest hole humankind has managed to dig on Earth. Team Kola had managed to break the world record for drilling depth, trying to get a leg up on the US during the Cold War. Eventually, though, they encountered temperatures of 180 degrees, which melted their equipment, so the hole was capped in 1992. When you're at the bottom, you'd find things are warm, to say the least. Not to mention, your body would be dealing with air pressure equal to 54 elephants perched on top of your head, weighing in at a whopping 378 tons. Talk about a headache. At least you could admire some of the 2.7 billion-year-old rocks down there. But really, could something like this, falling down this hole, ever happen?
Went to a party last night and I got stuck talking to a super borehole, but that's another story. The Kola super borehole has been sealed up, so you can no longer fall into it or drop things into it. But you'll get 2 more chances to fall into super boreholes soon because China is digging 2 more. One is going to be 10,500 meters deep. The other one's going to be 11,000 meters deep. Let's just hope that they also keep them to 23 centimeters so that my waist does not fit through there. Okay, our next story is kind of timely because a week or so ago, a former Air Force intelligence officer was testifying before Congress about UFOs, and he believes they exist, that the government knows about them, and that they're not telling you about it. Now, we've heard about UFOs before, they've been debated in Congress, but this is the first time a witness has ever been brought forth. Now, he didn't have any physical evidence, so we don't know what to believe, but if you want to try and find some physical evidence, why don't we all get together and storm Area 51?
If you happened to wander into the Nevada desert and stumbled upon the secret US military base, Area 51, you'd quickly be arrested, killed, or maybe even abducted by aliens. But what if you happened to organize 1 million other people through social media to storm Area 51? I mean, they can't stop us all, right? Or can they? And if you did manage to get into the base, what would you see? This is What If, and here's what would happen if 1 million people stormed Area 51. If you haven't heard of it before, Area 51 is a highly classified US military base. It's heavily rumored to have secret military technology, and perhaps aliens. For decades, it's been the source of conspiracy theories, but now you want to see if any of those theories are true. How do you get to Area 51? It's off limits to visitors, so it may not be on your GPS. But there are online guides that you'll need to use. The closest airport is in Las Vegas. From there, you'll have to rent a car and drive through the southern Nevada desert for several hours. Keep in mind that there are going to be 1 million other people doing the same thing as you. If you think traffic in your city is bad, just wait till you see this. Nevada's most populated city, Las Vegas, has less than 800,000 people living in it. In fact, the entire state of Nevada only has about 3 million people. Adding another million people all at once would seriously damage Nevada's infrastructure. The roads to get to Area 51 aren't an 8-lane highway. Instead, they're small 2-lane roads and dirt trails. If 1 million people decided to do this, they may not even make it to the military base. Instead, they may get stuck in traffic or get into an accident. So much for seeing any aliens. But let's imagine that everyone somehow makes it to the front gates of the base. Now 1 million people are ready to storm Area 51. What happens next? Well, you and your friends are peaceful people, so you wouldn't be carrying any guns. You're just simply running into the base. As soon as you crossed the Area 51 borders, you'd quickly be met by the base's private security. These people, also known as camo dudes, have weapons in hand and patrol the base 24/7 in white pickup trucks. You wouldn't be able to sneak up on any of these guys, as they'd surely know you're coming. And it wouldn't just be the private security trying to stop you. With an event this big, the whole world would surely know, and it would be impossible to keep it a secret. Area 51 is a detachment of Edwards Air Force Base, which is located in Southern California. Thousands of active military members are stationed at Edwards. You could expect to see them, along with thousands of other armed soldiers and police members. They'd have their guns, tasers, tanks, and who knows what else. The armed forces would try to keep casualties at a minimum, but they'd still be hitting everyone with pepper spray and other non-lethal weapons. They'd still be determined to keep what's inside Area 51 a secret. So most likely, the camo dudes and their military counterparts would open fire on the crowds. And they're authorized to use deadly force, so don't be surprised if they started firing bullets. If you're lucky enough not to get shot or pepper sprayed, you'd get arrested. But what if you somehow managed to sneak past all the guards? Well, despite this, you still wouldn't be at the actual Area 51 base. At least not yet. You'd have to find it. That's because the original Area 51 base occupies a space of 150 square kilometers, but the property surrounding it is 1,600 square kilometers. It's reported that the base is discreet with blacked out windows and hardly any visible lights from the outside. You could be walking around for hours before you found it. But once you reached Area 51, what would you see? Well, we're not really sure what's there, which is what makes this so exciting. Crazy military technology, UFOs, or even aliens could be lurking about. Proceed with caution though, as some suspect that the base is heavily polluted from decades of government experiments. If that's true, just being in the base without proper equipment could result in you getting sick or dying. So, storming Area 51 probably isn't a good idea. It would most likely result with you getting sick or arrested or dying. Sorry, you won't be getting a baby alien as a souvenir gift.
Whoa, watch your step. One little stumble and you could fall face first into a pit full of nightmares. Hundreds of angry rattlesnakes. How would they be able to see you? What would happen to your body if you were bitten by hundreds of snakes? And why would sucking the venom out not save your life? This is What If, and here's what would happen if you fell into a pit full of snakes. Rattlesnakes live in the forests, grasslands, and deserts of the United States and South America. You can identify them by their triangular head shape and, of course, their distinctive rattle. Running into even just one of these serpents in the wild would be enough to make you scream. And there's a good chance you'd find a lot more than one. Rattlesnakes often live together in dens or snake pits to avoid freezing and protect each other from predators. If you fell into one of these deadly pits rattling with venomous vipers, could you make it out alive? You picked the wrong day to fall into a hibernaculum. That's the official Latin name for the dens where snakes gather together. Depending on the snake pit and your luck, you could find yourself face to face with anywhere between 8 to 300 rattlesnakes. Winter is the most likely time you'd find hundreds of them congregating for warmth. If you happen to fall directly on top of these snakes, it would be only a matter of seconds before they'd attack. Yet, by some stroke of good fortune, you'd land in the den without immediately disturbing them. That's not to say that you'd be out of trouble, because these snakes would be on high alert. Their primary defense mechanism is to hide, and you just blocked the only exit. Rattling and hissing to scare you off, they'd use a couple of unique methods to hurt you. The rattlesnakes would know exactly where you are. During the day, these snakes can detect you by sampling the air with their tongue and tasting it with an organ near the roof of their mouth known as the Jacobson's organ. This organ tells a snake which direction higher concentrations of airborne molecules are coming from. At night, rattlesnakes use their pit to locate you. And no, I don't mean the hole you just fell into. I'm talking about a small hollow spot between a rattlesnake's eyes and nostrils. It's also called the pit. This area of the snake's head contains a membrane that can detect infrared radiation from your warm body. Just like in the Predator movies. All of these hundreds of snakes would be able to see you up to 1 meter away. Now the only question would be, how soon till they strike? Oops, I spoke too soon. The first one would sink its fangs into you, injecting its venom under your skin. Even if only one of the hundreds of snakes bites you, you'd be in trouble. Approximately 1 out of every 736 people who suffer from a rattlesnake bite dies. That means more people die from rattlesnake bites than any other snake bite. As more and more snakes began to attack you, they deliver more of their poisonous venom to your body. It only takes seconds for the venomous cocktail to travel from the fangs and into your tissues. But what is this deadly concoction? Rattlesnake venom is a complex mixture of different proteins, metals, and macromolecules that affect your organ systems. The venom coursing through your veins contains enzymes that lead to cell death, known as necrosis. At first, you'd experience some of the less severe symptoms, mild swelling, pain, and bruising, but you could also start to vomit or see your heart rate rise to more than 100 beats per minute. If more severe symptoms kicked in, you'd feel extreme pain, like being stabbed or burned by an explosion. Your airways would start to swell, cutting off your air supply, and you could slip into an altered mental state. But the worst would be yet to come. Your blood would become unable to clot, so you'd lose a ton of it, and your muscles would become weak, stiff, and would even start to break down entirely. This would make escaping the pit very difficult. You'd have to find all the strength you could muster to climb out of this snake pit, and now you'd need to get some antivenom as fast as possible, ideally within 4 hours. Antivenom stops venom from binding to your tissues, which is what causes serious blood, tissue, and nervous system problems. The question would be, how much would you need after being bitten by so many snakes? One young girl in California who survived bites from 1 adult and 6 baby rattlesnakes required 4 doses of antivenom. You might need more than the hospital has in its inventory. And beware, trying to suck out the venom from your wounds or making a tourniquet wouldn't help you much in this case. Cutting off the blood flow would just lead to a higher venom concentration in one side of your body. The best thing to do would be to stay calm. Don't touch your wounds and, of course, get medical attention immediately.
Uh-oh. You just fell into a pool with this thing. What is this? How would falling in here affect your health? And could you actually survive this? This is What If, and here's what would happen if you fell into a pool full of spent nuclear fuel rods. This is a spent nuclear fuel pool, and you've just accidentally fallen into it. But what exactly is this thing? This large pool of water is meant to cool spent fuel rods after they come out of a nuclear reactor. While powering a nuclear reactor, these fuel rods become very, very hot. We're talking 2,800 degrees. After it's spent 3 to 6 years inside of a nuclear reactor, a fuel rod is no longer efficient. Problem is, it still emits plenty of harmful radiation, and it will for the next 10,000 years. Even though it's trash, there's not a garbage dump in the world that will accept it. So, why is water a good place to put these things? Not only does the water spend several decades cooling the fuel rods, but it also affects their radiation. The water essentially acts as a biological shield, with hydrogen absorbing and deflecting the radiation bouncing against it. This makes it completely safe for you to stand near the pool with no ill effects. But what happens if you fall in the water? Well, as soon as you orient yourself, you'll quickly notice the temperature of the pool. This big tub of water won't be the refreshing dip you're looking for on a hot summer day. Instead, it'll be around 30 degrees. So, a bit colder than your average hot tub, but still very warm. Let's hope you didn't accidentally turn off the water flow as you're falling into the pool. If you did, then you'd be in some serious trouble. Spent nuclear fuel pools are constantly cycling out water in order to keep it at a cool enough temperature. Remember, these fuel rods are incredibly hot, and if the water isn't cycled out, then it would heat up significantly and slowly evaporate over time, resulting in you burning to a crisp. But that didn't happen. So now that you're starting to swim in this hot pool of water, when does the horrible radiation poisoning kick in? Or when do you turn green and start to gain superpowers? These are the sort of things that are supposed to happen when you fall into something that has nuclear fuel in it, right? Not exactly. Although that sounds like fun, it wouldn't happen to you if you fell into a spent nuclear fuel pool. That's because of the water. Not only does it protect the people outside of the pool, it'll also protect you if you happen to fall inside one. As long as you don't swim several meters underwater to touch the fuel rods, you'd be completely fine. Yeah, in theory, you could swim in this pool until you looked like a raisin without feeling any negative effects. Although they're protecting something incredibly dangerous, spent nuclear fuel pools are quite serene and kind of boring. In fact, this might be a lot cleaner and safer than your average public pool. You won't find any germs or children peeing in the water here. And swimming in this pool would expose you to less radiation than you experience in your everyday life. We encounter radiation in medical procedures such as X-rays and CT scans, from certain fuels like gas or coal. Even our televisions and other screens give off tiny traces of radiation. Swimming in here isn't any more dangerous than watching a What If video.
66 million years ago, a giant asteroid struck Earth, wiping out the dinosaurs and 75% of the other animals on Earth. Devastating, yeah, but this was millions of years ago. What if this asteroid were to collide with us today? Is there any chance we could stop it? What parts of the world would be most impacted? And why might this end up being a good thing? This is What If, and here's what would happen if the dinosaur-killing asteroid struck in 2024. Okay, let's see what kind of asteroid we're dealing with here. Known as the Chicxulub impactor, this asteroid was as wide as 100 to 200 football fields. That's 10 to 20 kilometers wide. And now it's coming directly toward us, specifically the Yucatan Peninsula in Mexico. If you think you can run away from this thing, yeah, no chance. It's hurtling toward Earth at 20 kilometers per second. Suddenly, it crashes into the sea, killing everything in the immediate vicinity. But that's not all. A thermal pulse radiates out from the blast site, releasing the energy equivalent of 10 billion nuclear bombs. Cue an enormous shockwave of air that destroys everything within 1,500 kilometers. Plants and animals are shredded, forests burn to the ground. A magnitude 10 earthquake would crack the earth open. Quakes would radiate throughout the United States. Massive tsunamis would rise. Mexico City, Florida, and Texas would all feel the effects. I know Texas has talked about seceding, but I don't think this is what they had in mind. Now, although there will still be life on Earth, it might not last much longer. Plumes of dust and sulfur in the atmosphere block the sun. For the next 15 years, it's a cold, dark, awful winter. Only a few of us will make it out alive. But maybe the humans that do survive will be able to rebuild Earth. And funny enough, that massive asteroid that caused all the damage, well, it might hold the key to a stable new future. If you want to see what I mean, let's head to the impact site. Some of the most valuable materials known to humans are scattered within this massive crater of destruction. And luckily for us, it's not 66 million years ago. It's 2024, and we're Homo sapiens, creatures with really big brains and bright ideas. No offense to the T-Rex, but they definitely weren't getting Wordle in 2, and they definitely weren't tracking the sky for asteroids. But there's a team at NASA doing just that. And if we were able to spot an asteroid ahead of time, could we somehow steer it off course? Well, it's possible to deflect an asteroid from its path. Here's 5 different options we can explore. The first possibility is a kinetic impactor. This is the only deflection option scientists have tested so far. The idea behind it is to violently slam an object into the asteroid, pushing it off its path. NASA tested this technique in 2022 by slamming a spacecraft into Dimorphos. Dimorphos is the moon of a near-Earth asteroid, and thanks to the force of the collision, it's now going faster. So, in theory, we could use this option to move an asteroid off course. But there's a bit of a problem. The asteroid we're dealing with is way too big. In order to successfully knock it off course, we'd need multiple kinetic impactors. I'm not liking our chances with this one. Let's see what else we got. Okay, the second option for deflection is called a gravity tractor. Think of this like your dog pulling on its leash, taking you down a different path to smell something interesting. Minus the dog and the smell. Here, a spacecraft flies next to an asteroid, changing its path by the force of its gravity. Unfortunately, there's a big problem with this method. Well, for starters, it takes a really long time, and again, it only works on small asteroids, ones that are less than 500 meters in diameter. Yeah, this will be a no-go when it comes to the massive asteroid heading toward Earth. Okay, the third option is something known as an ion beam shepherd. But instead of herding goats, this shepherd is a spacecraft herding the asteroid out of our way. The spacecraft has an ion engine which generates an exhaust of accelerated xenon ions. These ions are super powerful charged particles, and the force of these charged particles deflects the asteroid. But probably not powerful enough to deflect a Chicxulub repeat. Okay, next up, space lasers. Now, if you're imagining zapping the entire asteroid with lasers so it vaporizes, no, that's not it. Unfortunately, it isn't as cool, but it can be effective. The laser is trained on the surface, creating plumes that push the asteroid away, And if we had enough lasers that were powerful enough, this might be a viable method. Finally, for a really big asteroid like the one we're dealing with here, and something's got to be done, there's always nukes. Now, this would be incredibly dangerous because there's always the possibility of fragments of the asteroid or other space debris falling on Earth. Not to mention, launching nukes in general is a super risky endeavor, but let's be